Hello, everyone. Good morning. Thank you for being here. I know it's early and you guys probably went out last night, so you guys are the real ones for coming to the first talk. My name's Rodrigo. I'm going to be the MC at Stage 6 today. I'm the ecosystem funding lead at the Ethereum Foundation here from Colorado, and yeah, excited to present some of the speakers we have today. Before we start, a few items. If you guys need to use the restrooms, it's around the corner to the right beyond the booths. Please exit quietly. If you want to take pictures or record any of the wonderful talks that we have today, you're welcome to do so, but please do so without flash. And if you'd like to ask any questions to the speaker, we have a system called Meerkat. If you used it yesterday, there will be a QR code, and you can also access it through the Devcon app. Our first talk today is from Niharika at Safe. She's a technical product manager working on account abstraction dev tooling. The talk is on the butterfly effects and paradoxes of account abstraction in DeFi. So everyone, if you could please welcome Niharika to the stage.
GM, everyone. Today, I'm going to be talking about the butterfly effects and paradoxes of account abstraction in DeFi. Imagine this. In 2018, Uniswap introduced the automated market-making model, a smart contract that runs billions of dollars of transactions daily. This single innovation became like a cornerstone of DeFi, setting off a chain reaction of new protocols in DeFi Lego blocks in form of composability. And that's essentially the butterfly effect in action. Incremental technological decisions leading to massive ripples across the entire ecosystem. Let's fast forward to today. We stand at another edge of transformative shift, account abstraction. On the surface, AA might just seem like a technical optimization, another EIP, another EIC. But beneath that, there lies a potential to reshape how users actually interact with these DeFi protocols, from simplified wallet experiences to seamless gas management. AA can remove some of the most frustrating DeFi UX challenges that plague the ecosystem today. However, as with any transformation innovation, AA brings its own set of challenges and paradoxes. How do we improve security without compromising on the usability? How do we ensure decentralization while seamlessly offering Web 2-like UX? And how do we foster innovation without fragmenting the ecosystem? I'm Neha, and I'm going to be, I work with Safe as a technical product manager, and I'm building AA dev tooling to build more secure on-chain apps. If you're interested in this topic, I'd be happy to chat with you later. So let's navigate the butterfly effects and paradoxes in the DeFi realm. Before everything else, let me quickly explain the concept of butterfly effects. This concept comes from the chaos theory, famously illustrated by the idea that butterfly flapping its wing in one part of the world can set off a hurricane in another part of the world. At its core, it demonstrates how very small or insignificant changes can lead to large, unpredictable outcomes over time. And this concept is not just limited to abstract mathematics or weather conditions. It's deeply relevant in the technological space, and especially with DeFi, as the system is vastly interconnected. And small innovations or decisions can cascade into massive system-wide changes. Now, let's take an example in the tech history about the QWERTY keyboard. In the late 19th century, the QWERTY keyboard was designed to prevent typewriters from jamming by spreading apart frequently used characters. It was a very small and a practical mechanical decision made at that time. And fast forward to today, QWERTY is actually the most dominant keyboard layout globally, influencing how billions of people interact with computers and mobile devices daily. And that small local decision in the 19th century has rippled across centuries, shaping modern digital communication. And now if I allude back to the AMM model of Uniswap, here's how the butterfly effects come into the picture. Uniswap introduced the AMM model to enable swapping without relying on order books to match buyers as well as sellers. And they use a simple formula to facilitate these trades in the liquidity pools. At its core, it's a simple equation, x times y equals k, where x and y are two quantities, two tokens of the same value in a pool, and k is a constant that remains unchanged. And in a nutshell, here are how it works. The liquidity providers deposit the two tokens into a smart contract, which is the pool, and the traders can swap between these tokens directly from the pool, paying a small incentive fee to the LP providers. And why is it transformative? 3 reasons. 1, accessibility. Anybody can become a liquidity provider. That democratizes the liquidity provisioning. Efficiency. AMM eliminate the need for complex order books, and it reduces the barriers for decentralized trading. 3rd, composability. Protocols can very easily integrate Uniswap into their own ecosystems, which enables many swapping or liquidity strategies. So the incremental change that we see with Uniswap was that in 2018, the AMM model was introduced, removing the need for order books in an exchange. And here's the ripple effect. So now we have AMM model, and anybody can provide liquidity, which democratizes liquidity. And after that, it made DEXs to be more central to DeFi, and inspiring more and more DEXs to come up, like Curve, Balancer, or SushiSwap, which cater to very specific use cases like stablecoin swapping or multi-asset pools. And as a result, anybody can provide liquidity, which democratizes liquidity. And after that, it made DEXs to be more central to DeFi, and inspiring more and more DEXs to come up, like Curve, Balancer, or SushiSwap, which cater to very specific use cases like stablecoin swapping or multi-asset pools. And as a result, billions of dollars started flowing through these contracts, which resulted dollars started flowing through, in which account abstraction actually hits the hammer on its nail. There can be very simple onboarding to a wallet experience. In case a user is locked out of their account, there are social recovery mechanisms or multi-factor authentications baked in, having the native gas token on the chain. Users can also bundle multiple transactions into one simple transaction, for example, for swapping, for approving, and this is also quite gas efficient. Security features like setting daily spending limits or session keys will become a standard, and this significantly reduces the risk of losing funds or falling victim to a malicious contract. And cross-chain and layer 2 compatibility. Cross-chain interactions can be abstracted. Users interact with DeFi protocols without needing to manually bridge the assets or even be aware of the underlying network. Account abstraction is not just about solving these UX frictions, it's about truly unlocking the potential of DeFi. It bridges the gap between Web3 and Web2 to offer more intuitive, more secure experiences so that many more non-native crypto users can participate in DeFi with ease and confidence. Now, I want to give you a real-world example of how innovation in DeFi is causing ripples in the world today. Polymarket is a decentralized prediction market which has taken the world by storm because of the recent US presidential elections. Something that's not talked about enough is that Polymarket uses SAFE in its architecture. If you read on Polygon, Polymarket's use of SAFE in its architecture is a critical component to its UX strategy and security. By leveraging proxy wallets and maintaining a non-custodial approach, Polymarket ensures that its users have control over their funds while still benefiting from enhanced functionality and the security that SAFE offers. And here I would like to take a look at some numbers. So far, Polymarket has created about 420,000 SAFEs. And the number of transactions that went through, sorry about that. And the number of transactions that went through SAFE on Polymarket were about 1.6 million, which is approximately 3.7 transactions per account. Quite sticky enough for Web3. And finally, so far the betting volume on Polymarket is 5.7 billion. And as we see it, the smallest innovations in account abstraction, like easy onboarding experience, can set off a cascade of transformative events. In DeFi, innovations like account abstraction are not just a technical upgrade, they're a catalyst for a future where finance becomes more accessible, more secure, and more efficient. While these numbers are quite optimistic, addressing DeFi gives rise to several challenges and paradoxes, where solving one problem creates new problems, or it reveals conflicting priorities. Let's take a look at them. The first paradox is of security versus convenience. This highlights the tension between making systems that are more secure and ensuring that they remain convenient for the users to use. And striking the right balance between the two is the key to great user experience. One of the advantages of account abstraction is its ability to provide advanced security features such as multi-sig wallets, social recovery mechanisms. And these features enhance the security of user assets by reducing the risks associated with the private key loss. However, adding extra steps or extra layers of security comes at a great expense of convenience. For instance, in a multi-sig wallet, it requires several parties to sign off a transaction before it hits the chain. Or with social recovery mechanisms, it is designed to involve several trusted parties, which requires some coordination and forethought. And while these features make accounts more secure, they also introduce friction in day-to-day use. The second paradox that I want to talk about is customization versus standardization. While account abstraction offers great level of flexibility to users to define their own account behavior, and this includes custom transaction logic as promised by ERC 7579 or automated workflows. Users can create account personas that fit to their needs for either trading strategies or rebalancing portfolios or just to hold assets. However, with increased customization comes the risk of fragmentation. And standardization is very critical to ensure that different wallets, protocols, services, they work seamlessly together. And everybody can create their own custom account behaviors, and the risk of incompatibility with different protocols or apps grows. And this paradox centers around challenges of offering enough customization to meet the needs of the user while maintaining enough standardization to ensure interoperability. And what if I tell you there was a way to transcend these paradoxes? And this is where AI agents, intents, come into the picture. Intents are a fundamental shift in how users interact with decentralized systems. Instead of micromanaging every single transaction, the user simply expresses their desired outcome. Whether it's swapping tokens or executing a yield farming strategy, these are all high-level goals that can be abstracted away while interacting with multiple protocols. And this is where AI agents also kick in. These intelligent agents can interpret users' intents and navigate decentralized ecosystems and optimize the outcomes autonomously. And imagine an AI system where it's continuously monitoring several different liquidity pools without any kind of human intervention. In essence, like intents and AI agents, they resolve the very paradoxes that we discussed in the previous slides and have the potential to set off a ripple effect in DeFi to another level. There are two use cases that I'd like to discuss. Here, an AI agent can be used in decentralized trading. For example, the user expresses the intent to maximize profits by grid trading strategy, where token X and Y should be within a price range of $100 to $120. The workflow would look like this. The agent would be constantly monitoring the price of X and Y in several different pools. And as soon as the price in the grid hits to the lower level of 100 or 105, it places buy orders. And as soon as it hits a higher range, it places sell orders. And this would be occurring in a gas-efficient manner potentially transaction batches, because there are several tokens involved which can save gas. And the outcome is that the user achieves their desired profit targets without needing to manually track or execute these trades. The final use case that I want to talk about is with polymarket. The user might express an intent to maximize returns by betting on most likely outcome of the US presidential election to reallocate funds based on real-time changes in the probabilities. And here's how it would look like with the workflow. So the AI agent would be constantly monitoring off-chain data, news, reports, or social media sentiments, and it defines some probability estimates. Bets can be placed on the highest expected value based on the current odds and the transaction costs. And if new data suggests a shift in probabilities between different candidates, then the AI agent would dynamically reallocate the funds to a more favorable outcome. And as a result, the user can actually maximize their potential earnings while minimizing risk without needing to interfere manually, because AI agent would just take care of readjusting the portfolio. And in this essence, we see how the future of Web3 can look like, where decentralized systems become more intuitive and automated, and AA provides the programmable infrastructure, and AI agents provide user intents to be read in a more intelligent manner. And together, they can empower users to interact with DeFi in a more smarter and a more accessible way. And with this, I want to close by saying that whether you're a user, a developer, or a product leader, your actions today could spark the next wave of innovation. And let's embrace this responsibility and continue building a decentralized future, one small flap at a time. And the question I want to pose to you today is that what small decisions will you make today that will shape DeFi for tomorrow? And with this, I close my talk. I'd be hanging at the AA Community Hub later today and happy to chat with you.
Thank you for the amazing talk. Now I think we have the most interesting part is we can have questions from the audience. If you guys haven't logged into Meerkat, you still have a few minutes to do so, but why don't we start with the first question with the most upvotes. How do we safely navigate through quickly changing account abstraction environment 4337 seems already deprecated?
Okay. I do not agree that 4337 is deprecated. It's rather getting upgraded with new entry points. And there's more standards that are coming into the picture. For example, 7702, which enables EOAs to perform or make themselves better as smart contracts.
And then the last question, what do you think about the emphasis the Web3 community puts on technical solutions for UX issues? What other things do you think are required for the UX to truly improve?
So, of course, like from a technical perspective, we saw that there are several issues that do plague the DeFi industry, but also culturally, I think DeFi has not performed the best. It has been in the news for several scandals, several scams, and there has to occur a mind shift that DeFi can actually truly change people's lives. And there, I think technology would kind of fail, and it's more about the vision that we're working towards and making sure that the vision that we're working towards is inclined or in line with what we're doing day to day. It should not be that we are only so deep into technology that we forget about the end user, and it's only about over-engineering. All right.
I think that's it. Can we get a final round of applause for our wonderful speaker? We have another. Yeah, we have another talk starting in about 8 minutes on data ownership from Rachel. So if you guys are interested in that, please stick around. Hello, everyone. Thank you for coming today. I'm Rodrigo. I'll be your MC. I am the Ecosystem Funding Lead at the Ethereum Foundation. Few quick things before we begin. We have bathrooms to the right around the corner. We also encourage you to take videos and photos, but please do so without flash. Most importantly, we have a Q&A system that uses Meerkat. The QR code will be over on the screen in the bottom right-hand corner. Please you do so when the talk begins. You can ask questions throughout the talk, and you can also vote on other people's questions. So even if you don't intend on asking a question, feel free to log in and vote on other people's questions. I think it makes the session really cool and interactive. Our session today is from Rachel at Privacy and Scaling Explorations. She is working on Cursive. They have a booth. They are working on ZK solutions to human connection. Please go check out their booth today. As a reminder, the booths will change over tomorrow, so if there's booths that are open today, please go see them today. So please welcome Rachel. Her talk is on, oh God, I forgot the name of the talk. Okay.
Great. Hey, everyone. I want to start with a little poll of the room. So can you raise your hand if you ever opened a social app to connect with a friend, that was your intention, only to get lost in some content that you can't look away from? Okay, yes, so relatable experience. Maybe even this week, while you were in Chiang Mai, you meant to check in with a friend, send them, or sorry, we're in Bangkok now. You meant to check in with friends, send them photos of your trip, but you got busy catching up on important content. And maybe you're thinking, yeah, Rachel, that's ads-based social media. It's for dopamine hits, and you're not wrong. But here's the thing. These platforms were built on a promise of bringing people together. Many still claim human connection as their core mission. So today I want to examine this disconnect. For those of us genuinely seeking meaningful relationships through these social apps, are they actually helping us achieve that? And more importantly, how does our lack of data ownership undermine our ability to truly connect? Let me take you back a little bit. Before I was a designer, I had my fair share of rage over government websites and healthcare portals that made it really hard to be an informed, law-abiding citizen. And when I learned about the field of UX, I was giddy over this idea that services could actually be improved to the point of making it easier for people to do hard tasks. I couldn't wait to start honing this craft. And when going into the field, I think a lot of us are introduced to this book that gets recommended as essential reading called Don't Make Me Think. It's filled with a lot of amazing principles for removing friction for users so that they can achieve their goals. And while many public service applications, at least in the States, are still decades behind by usability standards, social media apps have nailed these principles. They're so easy that you're served exactly what you like before you even have to think about what you want from the app. But my question is, when does easy become too easy? When do thoughtfully crafted UX principles cross the line from enabling to exploitative? What happens when frictionless design and our surrendered data serve profit rather than people? When social apps make us feel good for at least some of the time, we often end up entrusting a lot of our personal data to these centralized systems. But that convenience to entrust others to custody, manage, and use our data introduces some additional vulnerabilities. The cost can come in different forms, like losing sentimental things we thought were permanently ours, or potential genuine connections with other humans lost. If our accounts get hacked or we get banned for maybe unjust reasons. So yeah, imagine losing all of these things. But perhaps most relevant right now is what if we lose genuine quality time with the people that we care about and as a Devcon attendee, this might be old news for some of you, but for the average consumer, it may not be obvious that the companies will use our behavioral and informational data to bait us into opening their app and keeping it open longer to maximize the number of eyeballs on ads. And I believe all of these costs are making us feel less connected to the people we actually want to connect to. I think it's really important to remember that designing for usability isn't as simple as ease of use. It's about designing systems that help users actually achieve their goals. There was this time when I believed these popular social apps could be a place to connect, and it always felt strange that these connections happened publicly by writing on each other's walls, or that all of my interests were broadcast to all of my friends. I remember exactly when it clicked for me that the promise of connection here was an empty one. It's when this ad ran in 2022 that claimed personalized ads by helping us fit in and be happier, been deleted from YouTube. So, I don't know. Maybe they realized they couldn't convince users that buying things would make them feel less empty inside. And while we see now the return to human connection rhetoric externally, you'll find a focus on content consumption if you look a little deeper. I thought I would find empowering users in a lot of designers' bios. With a quick search, but the focus seems to be primarily on empowering creators of content. The goal is getting more people creating more content that keeps folks on the apps longer. The user desire for a genuine human connection remains unmet. So, what happens when we flip the script? When we put data back in users' hands? Genuine connection becomes more than just website copy. Let's examine this through the 3 pillars of usability: effectiveness, efficiency, and safety. And I want you to do some thought exercises with me. What might it feel like to use a more effective social app that helps us, go back to achieving that goal of connecting with other people? Maybe we reconsider the "don't make me think" philosophy. Instead of algorithmic suggestions that keep us scrolling past our bedtimes, imagine apps that aren't trying to hijack our attention. Imagine no more For You page bombarding you with content the moment you open the app to message a friend. Instead, you see tools for intentional connection. You, not an algorithm, decide what connections would be meaningful. You choose what to share, when to share it, and who sees it, by utilizing your private portable social graph. Now let's consider efficiency. When we own our data, could we more efficiently connect with other users? Instead of broadcasting information, perhaps we would narrowcast it. What if, instead of putting your life on display by posting and liking on public pages, you could intentionally connect with specific people by only revealing your private data to those who meet certain match criteria. Almost like putting digital pheromones out into the ether. You might do this to find friends who share your interests, connect with mentors who complement your skills, discover people in your community with similar or differing perspectives, or discreetly signal that you're open to new work opportunities only if they meet certain requirements. Lastly, how might safety be enhanced when users own their data? I like to think about these three varieties of safety for users. There's technical, social, and psychological. From a technical standpoint, safety can increase for users when builders commit to using open source code for encrypting user data. Instead of saying, trust us, they say, verify. Imagine being able to control what you share with who. Go back to that. And the feeling of social safety that that might bring if we had even more control over this process than we currently do. And now put yourself in the future when these applications have been refined through many iterations by awesome builders that are in this community. Lots of user testing has been done, and you have full control over defining the experiences you want to have utilizing your data. Imagine the psychological safety that might bring if the expectations remain consistent and remain consistently met. This isn't just theoretical, it's UX principles in practice. Instead of optimizing for purely engagement metrics, we're optimizing for actual human connection. When we own our data, we're free to connect on our own terms, not through the lens of what's most profitable for the platform. So now picture yourself opening a social app and actually connecting with a friend instead of getting lost in a feed designed to keep you scrolling. To me, that's the promise of user-owned data, where technology enhances our relationships instead of competing with them. At Cursive, we're experimenting with these ideas. You can get an NFC chip at our booth on the first floor to start building your own private portable social graph to make MPC queries over. So you can try out some of these examples that I gave in the presentation, where you add your things that you're interested in, ways that you want to connect with people, and while our servers don't see the data you're adding, we're running this cool cryptography that if you do have a match over private data with another person on the app, you'll be notified and connected. There's a lot of design challenges in this space. I think they're really fun to think through, and I'm excited to meet people who are excited to talk through these challenges. I would love to invite all of you to join us in redefining usability for an era of data ownership, because I believe authentic connection is worth designing for. Our work is funded by Privacy and Scaling Explorations, who I've been with for the past 3 years. We have an impact booth right out here in the hallway, so you can check out more of this open source tooling that makes app experiences like the cursive one possible. Thank you so much.
Thank you for a super interesting talk. I think we have a few questions from the audience. The first one, besides cursive, can you give classic or future use cases or examples? What are current projects that meet the UX and decentralized ownership?
That's something, honestly, that I want to learn more about. So if you have ideas, please share them with me, because doing more comparative research and testing these tools is a really important part of all of us improving.
The next question, ads are a way of supporting and paying for services. How should builders and designers balance business needs with usability?
Yeah, this is a great question. And I think we're in this privileged position that I think is so valuable, that this work is funded in the way that it is so that we can run these experiments. I think that there is some learning to be had, and the discovery, to the answer to that question, will come through trial and error and testing. I think a lot of these ideas felt like pipe dreams a year ago. Oh, it'd be crazy if we could do this, if we could actually put this into production. And the only reason that everyone here can even try the app that is in production now is from so many cycles of testing these advanced cryptography in production. So yeah, I don't know if I have the answer to that question at this time, but I think that this builder and experiment phase is really important.
Here's some related questions, but this one's a bit different. Can you talk about the underlying consent models baked into cursive?
I really want to encourage everyone who's interested in more of the technical aspects of this. I'm really brushing the surface, to go to Vivek's talk at 3:30 today, because he's going to be getting into how we achieve what is going on in the app that you can experience.
Ads are a way of supporting and paying for services. How should builders and designers balance business needs with usability?
So, okay, this is something I'm excited to explore. If you want to talk about it, come find me, because I want to try and understand this better. But when I was kind of looking at my maps of things for this talk, it's we have in the classic models with ads, users the application company and then advertisers. So like you're optimizing for that relationship between the advertisers and the business. But like, what if, I don't know, you can remove that party? Are there, I wanted to check the question, but it's gone. Are there ways like to try and balance those things? I mean, I think that like, you know, less, like paid services is one route to explore.
Another question. Right now, users already have the option to control whom their data is shared with on Facebook. People don't bother to go into those settings and change them. How will this would be different with Web3?
I think that, you know, there is this feeling of like, nobody cares. No one cares about privacy. But as time goes on, I see more and more people in my life like caring, but it's not until they actually experience the consequences that I kind of like, you know, dug into a little bit in this presentation to give like some personal examples that have made my friends like stop and like think about how they're managing their privacy, and they're thinking about conceptualizing data ownership. One of my friends got her Facebook hacked and she lost all of her photos. Like that was where every photo from like our middle school, high school, college was stored, and like feeling that collective loss of all of these memories in a friend group, I don't know, hit everyone as like, this isn't ours. This isn't this person's. So I think we'll see it change over time and people wanting more optionality.
I think we have time for one more question. Love the talk. Have you considered that without the attention economy, social apps might not be sticky enough to onboard enough people to actually feel useful?
Yeah, I definitely think that this is a valid concern, and I think, you know, I'm interested in exploring, like, what is useful, what utility could we bring to people, and one thing that's been on my mind is like, maybe it's not about maximizing the time you're on the app and spending, like making your connections in it. Maybe it's just about like the starting point of realizing, oh, there's someone in this room that I could have like a really cool conversation with if I just have some amount of awareness that we're both here. So I'm like trying to conceptualize this different relationship with the applications we're using, where it's not like so much I'm in my hotel room and I'm, you know, sending messages to catch up. It's more like in the moment, how can it change the experience I'm having in a community, in a space, in a group?
I think we're running out of time for questions, but if anybody else has a question, they can go to the Cursive booth, and I think Rachel will be there to answer them later today.
Yeah, and lots of other amazing teammates who are helping build this experience.
So, if we can give a final round of applause. Hello, everyone. Thank you for coming. I'm Rodrigo with the Ethereum Foundation. Just a few quick reminders. The bathrooms are around the corner, beyond the booths to the right. If you are taking any videos or photos, please do so without flash. We will have Q&A questions through Meerkat. Please scan the QR code that will be in the lower right-hand corner of the screen. Even if you don't plan on asking a question, you can vote on other people's questions and decide which is the most important question to be answered. Our talk today is on the wallet and UX stack to build Web3 applications for the masses. Our presenter is Nich Kesonpat. She's a researcher at 1KX. Please, everybody, give a round of applause.
Hey everyone, great to see you here. Yeah, so my name's Nich. I'll be talking about the wallet and UX stack today to build applications for the masses. I'm a researcher at 1KX on the investment side, focused on middleware. And what do we mean by middleware? Why did we see this as an investable sector? Is because we asked ourselves the question, what accelerates innovation and adoption in Web3? Right? And so the two things that does this is one, smart contract developer tooling that improves the developer experience, and two, it's wallet infrastructure that helps us improve the Web3 user experience. So we'll be talking about how these two things have evolved over the past few years and why there's no better time now to build a Web3 application than today. So let's talk about DevTools. If you look at what the developer experience was like to build on Ethereum from 2016 till now, back in 2016, you had to run and maintain your own node. You have to write your own token contract. There was no ERC20. There was no token standards for you to just import. You have to implement your own wallet connector. So be opinionated about the wallets that users have to download and use in order to connect to your application. And then you have to wrangle with really raw on-chain data and basically be an expert in blockchain, like how the core protocol works, before you even get to implement your application, right? Today, thanks to all these tools, the time taken has gone for you to deploy your dApp has gone from hours to days to literally minutes. And you can come in as a Web2 developer and pretty much get started right away building applications on Web3. So if you look at how Web2 developer tools removed the barrier to innovation and the impact that this had, in the mid-2000s, you had the advent of cloud computing, right, which democratized access to powerful hardware. So people who are building websites didn't have to think about running their own servers anymore to connect to the internet. And this unlocked the wave of early Web2 apps, Netflix, MySpace, and so on. And then you had API-driven development that allows you to connect to third-party databases and do programmatic data reads and writes, so you don't have to implement your every service in-house from scratch. So if you look at things like Plaid, this payments rails allowed fintech apps like Venmo and Robinhood and Shopify to be built. And then you have development frameworks allow you to reuse pre-written code and scaffold performant and responsive web apps without having to start it from scratch. And in Web2, this took over 2 decades to get to where we are today, for the experience to get to where it is today, for the 14 million JavaScript developers that are out there, compared to the tens of thousands of blockchain devs. So in Web3, we've seen new abstractions and dev tools improve the developer experience as well. From the first ICOs and Ethereum launching in 2015 to Infura and Consensus, MetaMask, so on, allowing devs to outsource the node infra so people don't have to run their own nodes anymore, to token standards, Truffle, Ganache, if people were developing dApps in 2016, remember those scaffolding frameworks. And protocol APIs like Chainlink, the graph, allowing you to read from the blockchain without having to wrangle with low-level blockchain data. Continuing to today, we had early DeFi primitives in 2019 with things like Aave, Uniswap allowing you to scaffold and compose on these open DeFi protocols and build on these DEXs and build more and more subsequently complex applications. To things like Foundry launching, getting easier to build and test. And now, like over the past 2 years, we had account abstraction technologies, which we'll go into more deeply in a little bit, that completely changes and flips the user onboarding journey onto Web3 on its head, right? It's even getting easier to navigate docs. So, developers are going to a website and learning what it is that a protocol does. Now, AI tools are allowing, ChatGPT-like interfaces for you to learn about how to get started on a dev tool right away. So if we think about how users have onboarded onto Web3 in the past, the most successful crypto businesses have been centralized exchanges, right? People onboard onto Binance, Coinbase, OKX, and they just stay there and they never kind of funnel into the self-custodial stack and use dApps. And the most successful self-custodial dApps have been these exchange-owned wallets because they're like the most defensible top of funnel for people to go in. And then you have things like portfolio trackers, which is like just a small percentage of people who onboard onto like Binance and so on. So why is this, right? Because exchanges have been the best at helping users achieve a very common goal for entering crypto so far, which is buying and trading and holding tokens. And the usability of exchanges is, pretty much top of the line, right? You have the familiar email-based onboarding, seedless, fiat on-ramping, it's gas abstracted, it's chain abstracted. There's been, there's a lot of talk on, chain abstraction and account abstraction. Centralized exchanges have been, offering this experience from the beginning. But then what makes a user then funnel down the line onto self-custody and dApps, right? It's lucrative on-chain opportunities that aren't offered by these exchanges. So this has differed for each cycle. We had DeFi Summer back in 2020. We had NFT Mania. And then we had, ordinals. We had meme coins, right now, and like point farming and airdrops. So the opportunity for dApps to be built, you can use account abstraction and wallet infrastructure to onboard users into your application right away without having to require them to go to a centralized exchange or even download standalone wallets. So here we have like a few examples of dApps onboarding without going through centralized exchanges. But the technology that allows you to do so is wallet infrastructure, right? If you look at how you interact with dApps, before you even make your first transaction back in 2018, you see this confusing wallet selector screen where the user has to navigate out of your dApp, download a separate application that they don't know, onboard to a centralized exchange to get gas, top it up with their wallet before they even get to connect and interact with your application. Nowadays, with embedded wallets and onboarding SDKs, you're creating embedded wallets on behalf of the users, and without having to make them navigate out to a third-party app, and also the wallet is created on the user's behalf directly. And this is like a very, very meaningful change, right? This is an excerpt from Coinbase's Q3 investor report. Ever since they implemented their smart wallet, account abstraction wallet in their dApps, the dApps onboarding time has reduced from what was 2.5 hours before the user made their first transactions to 8 minutes. And when you compare it to Web2 dApps, this is kind of Web2 applications, this is still kind of average, right? But it's a drastic improvement from how users would interact with their dApps just from a few years ago. And so every layer of the wallet stack removes user friction and points of churn, right? So you have key management and signers, allowing users to do signature abstraction and interact with each chain without having to be chain aware. and do seamless onboarding through their emails and familiar Web 2 logins, to smart accounts, right, where you can really scope out the security features of your wallet and do things like recovery, multi-factor, and sub-accounts. To account modules, this is an emergent sort of development pattern we've seen where the users or the dApps can install a regular smart account wallet, but then subsequently extend on the features through modules that are being built by third-party developers. So the wallets are now becoming more like developer platforms where you can install these features without having to onboard onto another wallet. To creativity and communication, helping you do things like transaction batching, where you don't have to, where you can do multiple transactions in one click, and also permissioning and session keys, where you don't have to do confirmations with every interaction that you do on chain. Some things that we're seeing on the horizon are things like personalization APIs that allows wallets to give notifications to users, alerting them of things that they can do on-chain, personalized to what they've done before, right? So this is things like available NFT mints, art collections that they can do, quests that they're eligible for. And these things are very useful for improving retention and improving the sort of transacting users on wallets. To things like policy expression, prerequisites on who and how you want to interact with on-chain protocols. To things like chain abstraction, this is aggregating your liquidity across multiple chains, and it just helps, helps us being, removing the requirement of being chain aware in this multi-chain, sort of multi-layer 2 universe. To things like data pipeline and warehousing to make more performant dApps. If you look at the adoption of smart accounts, there's been a lot of discussion about 4337 and account abstraction here. It's grown pretty fair over the past year and a half or so after the entry point contract launch. But what's really exciting that's on the horizon is something called EIP 7702, right? So if you look at the account abstraction, sort of 4337 adoption relative to the hype that it created last year, it could be a little bit underwhelming sometimes, but this is because 4337 requires dApps to sort of deploy new accounts for new users, and it's very, very high friction for users with existing EOAs to migrate their assets and their identity to a new wallet, right? And the dApps have existing EOA users already. There's little incentive for them to do that. But with 7702, which is coming in Q1 next year, it allows EOAs to deploy code to the address and upgrade itself to a smart account. So then users can experience the benefits of account abstraction, which are primarily gas sponsorship, transaction batching, passkeys. And we think that the top wallets will likely implement this, but require users to opt in instead of enabling it by default, because this still doesn't subvert the passkeys and seed phrase risk of EOAs. So you still need actual native account abstraction for that to happen. But it also can improve security via session keys, right? Yeah, so we think users will opt into this if they want to use a dApp or feature that requires AA features. And embedded wallets will actually play a key role in this, because it puts this decision on developers instead of users, without waiting for users to enable 7702 for their standalone wallets. So in summary, all of these abstractions, both on the DevX and UX side, increase the pace of innovation and adoption. Better smart contract developer tooling increases DevX, more developers, more applications, and then wallet infrastructure enables better user experience, better apps, and hopefully more users. And yeah, that's the talk. Happy to answer any questions.
I think we have one question so far. You guys still have time to submit questions if we can do so quickly. The first one is, what is your thought on the kind of chaotic standards and implementations of account abstraction combined with the friction of L2 in Ethereum?
The chaotic, I'm not sure I understand the question.
I don't think I understand either. If we have any other questions, or if whoever asked the question wants to elaborate, what do you think would be the end game of on-chain experience, and how far are we from there?
Yeah, so if you think about when you're using a dApp today, and the amount of time you're spending doing things other than using the dApp. So for example, like right now, if I want to use like an NFT, art marketplace, right? Historically, I have to download a wallet and top it up with gas, and if it's on the wrong chain, I have to migrate and so on. So that's like not helping me achieve my goal of buying NFTs, right? I think the end game is reducing the amount of time that I have to think about blockchain stuff, versus using the dApp is as little as possible.
How do you think the hardware wallet ecosystem, anything you are interested? I'm going to mark that as answered.
The hardware wallet? I don't think hardware wallets are going to go away. It's, hardware wallets is definitely found PNF with users who wants to keep their assets super safe, but things like smart accounts and multi-signature wallets, I think, is something that I'm most excited about, because with hardware wallets, if you lose that, then that's still a single point of failure, right? I think hardware wallets are great as signers to something like a safe.
What is a good way to onboard very casual dApp users who want to hold either zero or very tiny amounts of crypto that need low to medium level security and upgrade the security as the balance grows?
I think onboarding SDKs and embedded wallets are a great solution for this. So embedded wallets, to the user, they come up as these modals that allows you to either sign up or log into the dApp with their emails. They create a wallet on their behalf, and right now embedded wallets are very powerful, a very powerful player in the market, because they can aggregate different products and services like fiat on-ramps, swaps, off-ramps, and things like that. And you can also sponsor gas for the users as well. So the gas sponsoring on L2 has become a user acquisition cost now for dApps, because gas is low enough for you to just do that on behalf of users and allow them to make the first transactions. So I think, that's an easy way for you to onboard casual users. And you're seeing now like different chains offering gas subsidies for dApp developers to build on their chain and use their services. If you're building on Base, for example, they have their smart wallet, their on-chain kit, and they have their paymasters as well. I think like giving away around 30K in gas credits for you to build on them. So yeah, there's a lot of optionality now that you have as a dApp user.
Can you give a good example of a smart account implementation to raise the penetration of a Web3 game?
I think so smart account implementations are pretty agnostic in terms of what types of use cases they enable. But there are, so gaming developer platforms, for example, that have dev tools for you to scaffold your game, like NFT marketplaces and embedded wallets, have these embedded wallet solutions on behalf of their platform. So I look into those.
I think this is a good one. What customizations could L2s do to reach UX endgame faster than L1?
So we're starting to see specialized L2s now versus generalized. So by generalized versus specialized, I'm talking about things that came out, 2020, 2021, like Optimism, Arbitrum, and so on. That's kind of doing a wide blanket of the types of dApps that they want to be built on their ecosystem. But now we have consumer-focused layer 2s like Abstract, which is built by the Pudgy Penguin team, that is specifically focused on consumer apps. So this comes with everything from native account abstraction to gas sponsorships to embedded wallets, and that optimizes for the types of apps that you want to build for consumers. So I'd look into things like Abstract Chain.
Is there any possibility to help user navigating through dApps more safely?
Yeah, so a lot of wallets now are going away from the blind signing pattern where users are signing things and they actually don't know what it is, to having a clear and verified human-readable information that pops up that allows a user to be really aware of what it is that they're signing for. And then there's some small tools like Fire, which I think is now Cerberus, that warns you if a dApp that you're interacting with is dangerous or malicious or not. There's these registries of trusted contracts that you can install within wallets or within your browser extensions to do a double check.
What standard do you think will get the lowest friction in the years to come?
The lowest friction. I mean, with 7.702, I think it's like a step forward from 4.3.7, right? Because 4.3.7, you still have to deploy a new wallet.
What are your thoughts on differentiating wallet types or front-end experiences for users, e.g. a wallet address is like a bank account number for many, which increases friction? There's a few identity protocols that allow you to have different addresses mapped to a human-readable name. These, things like ENS and things like clusters, which allows you to have aliases on different chains, and that maps to a wallet, would improve the user experience a lot because, I don't think addresses are that meaningful to the vast majority of users, whereas I can just say, niche.eth, and have people send tokens to me there. How do we solve the fact that embedded wallets are siloed to the app where they are created? Is that really Web3?
So the dApp specificity and the siloed issue was an issue in the past, but projects like Capsule and Privy have now launched global embedded wallet features where if you create a wallet within one dApp, you can sign in with the same login, and that wallet will be imported to another dApp. So this was an issue in the past, but the embedded wallet providers are launching or have launched these features in the past few months.
Since Web3 dApps tend not to analyze user events via tools like Mixpanel, Sentry, etc., this does affect user experience. Is there a Web3 alternative to conduct user analytics while sticking to Web3 ethos?
There are tools for dApp analytics, like telemetry performance, showing the dApp developers analytics of where the users are dropping off, but this is quite nascent. It's offered at a primitive level, I believe, by things like Alchemy, and there's a few Web3 analytics protocols that are starting to do that. But since a lot of things are on chain, the dApp developers are being savvy and kind of doing these analytics themselves because I think we haven't reached the scale where developers are willing to pay for these tools in terms of the revenue they're generating from their dApps. We haven't seen sophisticated analytics tools yet.
What about UX and account abstraction beyond EVM?
Yeah, so I think, the concept of AA is very EVM sort of centric, right? Solana has a completely different account model where this account abstraction features are baked in from scratch, and you can have other parties natively pay for your gas. So for some non-EVM sort of chains, this is kind of a moot point because it's natively baked into their protocols, which is what Ethereum aims to do with native account abstraction.
How do we do away with seed phrases and private keys? Can an alternative be secure?
Yeah, so that's what native account abstraction aims to do, right? We want smart accounts to be the default thing. We want users to be able to sign with any keys that they want, like pass keys, social login, email addresses, hardware wallets, and so on. The alternative is, so why the alternative is more secure is because it's removing the central point of failure, right? The point of removing seed phrases is removing this point of failure and having like redundancy in terms of like what keys can be used to move assets out of your account. And then you can scope the different permissions or capabilities based on each of these keys. So yeah, that's why smart accounts where you can have features like multi-signature and session keys and recovery. We want to make that the default way that people interact on chain.
That's all the time that we have for questions right now. Thanks you guys for asking a ton of questions.
It's a lot of questions.
Yeah, if they want to ask questions, is there anywhere that they can reach out to you after?
Yes. I think, can I go back to the slide? Well, you can just find me around here.
Okay.
Or like, yeah.
But can we give a final round of applause for Nitch?
Thank you.
If you guys enjoyed this talk, we have a panel on wallet UX that I think you guys will also enjoy. That will start in about 3 minutes. Hello, everyone. Thank you for joining us today. We have a panel on wallet UX. We had a few last-minute changes to the lineup, but please welcome Derek Rain, the host, Hester Brookman, Eric Galansky, and Lucas Shore. And, yeah.
GM, who's awake? Okay, we got a few people who are awake. That's amazing. Yeah, welcome to the Wallet UX panel. Let's maybe, before we get to the speakers, let's get to the audience. Who thinks Wallet UX is amazing today? Who thinks it could be better? Okay. Who thinks it's terrible? All right, the next question. Before we get to the intros, who here knows what Fireblocks is? Who here has used Fireblocks? Oh, right on. Who knows what Safe Wallet is? Who's used Safe Wallet? And who has heard about MetaMask? All right, that's a good amount. All right, let's get to the intros. I'm so thrilled to be here. I think my name's Derek. I'll get to my intro last, but I think Wallet UX and UX and EVM is really one of the biggest challenges, and we have the most amazing crowd here to discuss that today. So I'm very thrilled to introduce Arik, Lucas, and Hester. And Arik, why don't you give a quick intro about you and Fireblocks?
Sure, thanks, Derek.
I guess ladies first, but...
Yeah, so I'm Eric, and I work for Fireblocks. It's great that some people here actually know Fireblocks. In a lot of situations, we're a bit behind the scenes. If some of you, for example, use Revolut, or you use... anybody here played Off the Grid? That's been exploding recently. So like the biggest Web3 game ever. So like those kind of... A lot of times when you use something that uses the blockchain behind the scenes, Fireblocks will be there basically in payments, in stable coins that you might be using, and even if you're just doing trading, the other party a lot of times will be Fireblocks based. We basically provide a wallet and other infrastructures for companies that are building blockchain-based products. Yeah, that's on my side.
Lucas?
Yeah. Hey everyone, I'm Lucas, I'm with Safe. Yeah, what we do is we build account abstraction infrastructure. We're coming from this perspective of like with Ethereum, with like new technology, as it's always the case. It has a lot of potential, but this potential is locked in the beginning because it might be expensive, it might be very technical, hard to use, it may be just not accessible for different audiences. And for us, while the potential is there with like DeFi, financial inclusion, with new kinds of coordination mechanisms, like we still far away from actually having this potential fully unlocked. And we see account abstraction as a key accelerator to making that happen. So smart accounts can really level up the user experience and the security and all of that for interacting with Ethereum as a technology. And that's what we've been doing for the last, I don't know, 6-7 years. Still some time to go, but like I think we made some good progress.
So hi everyone, I'm Hester. I'm standing in for a colleague, actually Adam, who can join. I'm a product manager at MetaMask on a team called Wallet UX. Don't kill me. We do what we can. No, so a little bit more context. Wallet UX is a team that coordinates, is responsible for bringing different units together, features, accounts worked on by a variety of teams. And we try and bring that together in what is to be a cohesive, easy-to-use experience. So if we introduce different account types, smart contract account types, we'd work on how do we actually introduce those in your importing flows, in your account selection. Same for settings and discovery of other features. So yeah, I think that's a little bit about me, and I'm very happy to join these gentlemen here.
I love that joke. Yeah, my name is Derek. I work for a company called Reown. We used to be called Wallet Connect, and many of you have probably interacted with Wallet Connect. Thanks for using the product. Okay, so first question, let's do a little bit of I'll start with a little bit of a hot take. So I'll claim that account abstraction actually failed. Some data for that is Trust and OKX were the main consumer wallets that actually launched account abstraction, but in OKX wallet, you can't sign up anymore. So yeah, what do you think about that? Did account abstraction completely fail?
I think we're partially there, is what I'd say. Account abstraction becomes useful, and Wallet UX is about usefulness as well, and it becomes useful when you get the opportunity to control what the account then does. And I think that's the kind of the missing piece, the granting permissions, enabling users, having an interface for users to control what that abstracted account actually does.
Are you going to ship an account abstraction?
I think, so what is very well known, we're working on a framework called Delegator Framework that introduces permissions and permission management for smart contract accounts.
I think account abstraction to some extent is a victim of hype versus reality situation. And like you mentioned, this is one example. The numbers are definitely not there yet for the account abstraction, but the hype is so much there that people kind of expect it's one day to get everything that was promised. Now, the reality is that when, for example, account abstraction sort of launched, which is not exactly something you can do to something like account abstraction, there was no mempool for account abstraction, right? So there was just like an entry point. And that entry point changed, I think, 7 or 8 times since, right? So there's like a product, like they take time. And 4337 was the first iteration of account abstraction that had some level of traction and usability. And I think 7702, which I'm not sure how many people here are familiar with, but I think 7702, EAP 7702 is actually going to be the next phase. And this is something that the Ethereum Foundation is working on right now, like the core devs, not the Ethereum Foundation itself, but the core devs are working on introducing that into Ethereum beginning of next year. And one of the big differences between 7702 and 4337, because we're probably not going to go and talk about the standards themselves, but I think the big difference is that the first iteration of account abstraction was really just looking at smart contract wallets as participating, right? So like Lucas has already kind of been in that game for the last year. But the next version is also looking at EOAs participating. So MetaMask can start getting into that game as well, and Fireblocks with our offering and our clients of Fireblocks can also get into that game. And since 99% of people still use an EOA, this inclusive offer, like new proposition, is actually going to be a big boost towards adoption. But we're definitely not there yet.
Yeah, I do think that account abstraction was overhyped massively, but I think it was also necessary because that is the reason that we have like about 10 panels on account abstraction at a conference now. We have a bunch of discussions and like progress, a bunch of builders working at that, and it needed this initial impulse to get things started. But it also, at some point, the sobering effect comes where the big promises take longer, etc. Like for me anyways, the goal is not necessarily the account abstraction part, which is often associated with like the EIPs and the standardization of Ethereum, etc. around it, but it's really moving users towards smarter accounts, because that will unlock the potential for users, that will make them feel more secure, have better convenience, etc. And I think in that regard, we haven't failed at all. Like right now already, just looking at safe smart accounts, they make up 10% of the transfer volume on Ethereum. Like 10%, like that's not, I wouldn't consider that as a failure at all. And that means obviously there's 90% to go, but like at some point we will also reach a tipping point where like as apps see that actually a lot of their transfer volume is coming through smart accounts, they start optimizing for it, and it creates this virtuous cycle of like constant optimization, which eventually will lead us towards having every account a smart account, which we should strive for.
Yeah, but even on Safe Wallet, I think you don't support 437 yet in the UI. So the 10% that you mentioned, they don't use the ERC 437 features. Just to like give a cynical nitpick.
I mean, the user doesn't care. The user doesn't care if there's 457 there or not. They care about, oh, my transactions are sponsored. They care about, oh, my transactions are batched together. I have multi-sig. They care about these things. If 457 is the right thing to achieve that, if 7702 is the right thing to achieve that, whatever EIP is coming in the future, I don't care. I want that the user benefit gets to shine.
Yeah, I agree with that.
Yeah, I just wanted to say there's probably like 20 different talks about 4337 or 7702 and just one wallet UX, or like maybe there's a couple more like user UX. There's not a lot of them, right? I think maybe that's a bit of an indication of the priorities we have currently in the ecosystem, focusing a lot on the details of the different solutions and not focusing enough on like what Lucas just said, the end result. How does that look? Is it comfortable? Right? So like that's part of maybe the shift we need to do as an ecosystem.
Cool, then next, can each of you maybe pick your top 3 exciting UX improvements that we're gonna see over the next year or 2?
We're gonna see 3? That's amazing.
Yeah, I can think of 2. I'm gonna rely on you both to add a 3rd, 4th, 6th, 5th. No, I'm thinking 2 of the things I am really excited about is permission management. I think that's going to give a lot more control that users so far have had to rely on Solidity developers to get smart accounts, to make accounts smart or do what you want it to do. And the other thing I'm excited about is introducing more identity components into wallets, being able to track your proofs and credentials that you have shared. So I think those would be my top 2 picks.
Cool. I think you left a really easy one for me, so I'll take that one. But gas abstraction, right? When people talk about account abstraction, they usually put a lot of things into that bucket. But I think gas abstraction, or sponsored and gasless transactions, are some of the things that are most exciting, because probably a lot of the people in the room don't remember that feeling, because you're obviously very versed in working with blockchains, and sometimes when we're like that, we sort of assume everybody is. But if you go to a website and you want to do something, and I don't know, you're buying an NFT, or you want to pay with basically dollars, right? For somebody who's not part of our ecosystem already. And suddenly somebody starts saying, hey, you need to have Ethereum to make that transaction. That's very, very painful in terms of the adoption of new users for this ecosystem. And by the way, even for us, it happens sometime, right? I had it just recently where somebody, I wanted to complete something. It wasn't a chain that I didn't have the native token for, right? An EVM chain. And suddenly you're in that position you were the first time you used the blockchain. How do I get this gas token now? So I think what smart contract wallets in general and account abstraction as it connects to EOAs brings as well with 7702 is definitely the ability to let users onboard to blockchains without first figuring this really hard thing of getting the gas token. And I think that's just in terms of onboarding, we already see this is very useful.
The good thing is if you go last, you can actually think about 3 things. I would say, from a user's perspective, what the user value we should bring, especially with smart accounts, is around speed, security, and scale. That's really what the user feels from what comes out of it. And there, I think, over the next year, we will see big advancements in all of them. Speed, it's around one enablement for this could be session keys, where session keys allow you to have actually have the wallet be a cold wallet where the key is secure, but you give permissions to session keys that then allow you to do easy interactions with an app without every time signing with your private key directly. That's the one thing. And security part is we still rely a lot on the front end managing the security for the user. where I think with account abstraction, smart accounts, that we can introduce better and harder security guarantees for the user, where like we've got providers like a blockade, for example, in Safe Wallet. They check every transaction and they say to the user, this is like malicious, this is okay, and the user just trusts the front end there. But like these same guarantees could be given on a transaction level, on a transaction inclusion level, where blockade could actually say, hey, our engine said this is a malicious transaction. Whatever front end is used, even if you had the private key exposed, we block this, and the only way to then go forward is if you have unpack whatever your social recovery or your backup key or whatever, so that we will see like these advancements in security for the user. And the last one, I would say, is scale, where the user should really do as much as possible with their wallets. And right now we live in silos across chains where it's really hard to migrate between jurisdictions across different L2s, etc. And I think there we also see advancements in like, yeah, the user just has like a single unified balance. They can go to an app. They don't care what chain it is. They just spend the assets there. They can use those assets on a different chain with a different application, and the scale of user interaction just increases massively, and that also requires account abstraction.
Maybe it's worth, like Lucas just mentioned, this multi-chain situation. So I think it's maybe kind of bringing the audience into our situation, right, in terms of getting good UX for users, not just wallets. So this ecosystem was built initially for a single chain. And even as people were thinking about smart contract wallets, for example, the entire idea was you pull the wallet on chain because everything is on chain. And then L2 started to happen. And it's not the wallet's fault, but basically it's my take that when more and more L2s happened, they basically degraded the wallet experience for users, right? Because suddenly problems like I have money on this chain, I don't have money on this chain, but the DApp is on this chain, they didn't exist initially. And now we have a lot of chains, right? Like probably on the panel next to us, somebody's announcing a chain. So suddenly even your Uniswap is on a different chain, and your ENS might be on a different chain, and everything is on a different chain. And that creates a user experience problem because you need to get the user informed of the fact that it's a different chain and he needs to do some action? On the other side, you might hide from him that there's a different chain, but if you hide from him, what if you introduce a security risk as a result? Maybe the other chain is not as trustworthy as the one you have money on, right? So there's a real dilemma between the usability, user experience that you can give to people, and sometimes on the other side is not, I don't want to do development work, it's rather, there's a risk element, right? There's a security problem that you need to account for. So that creates like a very complex process.
So I actually would say it's a trilemma. I think the problem with wallet UX is always you want to maximize on convenience, you want to maximize on security, and you want to maximize on control. Like in Web 2, we figured out how to maximize on convenience and security, arguably, but like people just don't have the control. That's why Web 3, that's why we want non-custodial solutions that users have more control. They can migrate their accounts to whatever solutions they want, etc. But then suddenly, the problem is you can only maximize on two of them, because like you can have control plus security, but that's usually the very technical solutions which then don't bring the convenience, or like cold storage solutions, etc. Or you can have convenient and convenient solutions with a lot of control, but then usually this is too much abstractions and the user doesn't understand what they sign anymore and they do something wrong and the security gets lost. So kind of this trilemma, I think we've been navigating over the last years in the wallet space, and I think there, again, account abstraction, I would hope that it helps kind of managing these trade-offs better, or even enable it eventually to have like all of the three be maximized at the same time. But I think that's that's at least my mental model when it's about wallet UX is these three things.
So we got quite a bit. We got identity, permissions, session keys, chain abstraction, gas abstraction, security. So we got quite a bunch of things. There's going to be a QA later. If you disagree, if you think the speakers forgot something, please put in your hot takes. I'd be curious, I know the amount of Fireblocks users is probably not so huge, but the last statistic I saw from MetaMask was 30 million, I think, monthly actives in the last bull cycle. So you probably have a lot of user data. Is that also what your users are asking for? Like, does this come up, chain abstraction or anything like that, gas abstraction?
Yeah, so I think what we get as feedback is related to convenience, to like having a good UX, whatever that means, and it's up to us to then interpret that and understand how those problems might be addressed with account abstraction. Yeah, I'd be doubtful that we're actually getting, like we could do some searches, but I'd be doubtful that we're actually getting demand for account abstraction. So it's our interpretation that some of the feedback that we get can be resolved through account abstraction and better control and security.
Cool. I'd be curious.
I just want to say that Fireblocks has created more than 250 million wallets. Just throw it into in terms of the amount of users and stuff.
But I mean, how many end users are in?
So a lot of them so a lot of times what would happen, Fireblocks kind of has when we're talking about models, there's well, actually more than 2 models, but we can simplify it into 2 models, where there's more of a treasury-oriented model for companies that hold a lot of money, and we want to make sure they're secure and that they have all of the things they need to build, and that's like what a lot of people usually think about Fireblocks when they're familiar with Fireblocks. And the other model is more wallet as a service. So a lot of times what will happen is companies will create millions of wallets on Fireblocks for their users, right? And in that we also have, for the clients, the ability to do custodial and non-custodial wallets. So a lot of times what will happen is that the client of Fireblocks will create non-custodial wallets for their users using MPC technology and things like that, that is underneath the surface to make sure that the wallet is actually still non-custodial for the user.
Got it. Yeah, I want to tap into that a little bit more later, but one thing that fascinates me is Lucas and Safe are massive innovators on account abstraction and smart contract wallets, and one feature of that is that now you can have multiple signers and you can have spending policies and all this. And I'm curious, what is the wallet of the future, basically? Do I still have an app in my phone to use the account, or do I just have a passkey signer and I sign in the app directly? What's the wallet of the future in, let's say, 5 years, and how does it impact your business? I'll hand to Lucas, he's smiling.
I don't know if there's going to be the wallet of the future. Obviously, if it's kind of sci-fi kind of thing, the wallet is completely invisible to the user, and it just interact or kind of acts on the user's behalf as with an AI agent behind it, and in a very secure way. And when the user eventually at the end of the lifetime passes away, all the assets get somehow routed to the descendants of this person, like a lot of the things that are today not solved, but I don't know. This is more the kind of esoteric perspective. I don't know if some more product-oriented answers.
No, I'm thinking what remains, especially if we're talking about introducing more embedded wallets, smart contracts accounts, is that you continue to have a place which then becomes an evolution of the wallet where you aggregate, search probably through smarter AI interactions, what you've done in the past, what you want to do in the future, what kind of caveats you want to add to that. So it becomes more your control center of accounts. I don't see those fully abstracted away in managing or exercising control, but I do see them abstracted away from interactions that you do with, let's say, dApps or other decentralized applications.
Can I add a bit of a hot take on that in that area? So I think, obviously, Lucas mentioned earlier, one of the easy ways to provide great UX for users is just be custodial, right? That's what Web 2 did. And so there's kind of as an ecosystem where we want to enable something better, something different. And there's now this very big push in the ecosystem of everybody being excited about wallets that you can sign with a passkey. I wonder like how many people here are excited about the ability to like onboard, have a passkey, just sign it. You don't need to create keys. You don't need to do those kind of things. There's a lot of companies that are building this right now. But I think passkeys are a very big risk of centralization, right? And I don't think anybody talks about it, right? So like, out of the people here who have a passkey or ever experienced a passkey signing, I don't think maybe is there anybody here who created his passkey outside of Apple or Android? Or like actually create, okay, we have like 5, like, okay, that actually created a passkey in their own system. Like you can do those kind of things, right? Passkeys as a technology is decentralized, but we know a lot of times that user habits beat technology. So if you create your passkey in Apple, Apple will back it up in the Apple cloud, and Apple can move it around between Apple devices, but you cannot get your passkey. So if Apple decides to shut down your passkey, you cannot sign. I don't know if that's self-custodial. Like somebody should tell me, I have no idea, but like it's definitely not the fully decentralized world that we imagined. So I think there's going to be challenges. It's very exciting because it gives us the UX we want, but I'm not sure it gives everything we want.
I want to take a hot take on that, or like I want to counter that. Actually, in our app SDK, I think it's the passkey is a convenience feature. The way it's used today, it's a second, it's a 2FA, and that's how it's used in Google, and I think that's how it's going to be used in crypto too. In our app SDK, that also uses a safe smart account for normie users, and it's ERC-437, so they don't need to have gas and whatnot. They first provide their email and then their passkey. So now the email still also can be censored, but ultimately I think the wallet of the future, basically you have multiple signers, and if you have serious funds, maybe you have some ledger in a safe or something, if you in a bank safe. So no, I think the passkey is a nice convenience feature, and I think it's successful as such, and in crypto it's going to be the same.
Yeah.
Yeah,
But I would say passkeys as the primary and only signer of an account, I very much agree that this should not be the way we should go down. As session keys, app-specific keys, passkeys are amazing, but not as a primary key. And
sorry, Hester.
I think Luca summarized it exactly how I would want to put it, not as a primary solution, not a primary key. And I think to add to the point of decentralization, it also kind of reduces global access because not everybody has the ability or availability to use passkeys.
Yeah, and this is kind of like the process. We need to go through things, right? We get excited about this technology. Over time, we understand, wait a second, there's some trade-offs here, and hopefully new solutions come in, but like that's going to take some time.
Personally, I'm more, with regards to centralization, I'm more concerned about that the way we fix the UX problems, such as smart accounts, is going to lead to more decentralization. Until very recently, the only UI where I could manage my safe core was the safe wallet UI. And today, the only UI where I can manage my Coinbase smart account is the Coinbase UI. Same for trust. So actually, the user now gets vendor locked in there.
But for Safe, this is exactly the thing we didn't want to have. Like Safe is an ecosystem. We were pushing this 200 builders, like some do like more dev tooling, but there's at least 50 user front ends where you can port your account, because that's exactly the risk that we have going towards account abstraction, is that we will lose the portability of our accounts. It's the greatest thing that if I don't like Fireblocks anymore, I hopefully have a way to migrate my account somehow to MetaMask or to Ledger, or like this is what Web3 kind of makes so powerful, to have this control.
So I shouldn't have called out the reowned UI, for instance, also supports Safe. So Safe is a bad example, but personally, I'm more concerned about these things than the passkey centralization. So Arik, what do you think?
I think that's a great point, right? When you had an EOA, it's just a key. So it's more easily portable, right? There was multiple wallets that allowed you to import even keys, even though there's obviously security problems there. When you import the key, you took outside, like it's already outside of the safe environment. But still, like it was easy to transfer. What we saw initially in the smart wallet space is you could not migrate stuff, right? Like you had a safe, they had their implementation. Let's say you now wanted to move to an Umbire wallet. That was like, you basically had to move your funds. right? Like there was no way to do those kind of transitions because they were not aligned on the standards that are used and things like that. A lot of the work that's happening right now, again, is mostly on the back end of a lot of our communication, right, between us and a lot of other companies, is there different standards are being formed, right? If SAFE has one implementation of modules and other smart contract wallets have different implementation of modules, it's hard to reuse model, it's hard to do things. The more standardization that we do, the more portable everything becomes. So there's like the smart contract side of the standardization that a lot of work is being done there, and also kind of giving the props to the Wallet Connect initiative as a start and re-own as an actor. What happens a lot of times behind the scenes, and this is how a lot of us know each other, is that the Wallet Connect team kind of organizes us to all of the different wallets together, and we talk about how do we make user experience, because eventually there is one app on the other side, right? Like, again, it's always easy to use like a Uniswap, and they need to interact with a lot of wallets. And if we don't align in that interaction on something that a lot of different companies, a lot of different wallets will support, Uniswap will not add the feature, right? Because they're like, if only 2% of my users can use this feature, it's not even worth it. But as soon as we all combine the efforts, both on the client dApp side and the wallet side, we can push kind of like those things forward. So a lot of this decentralization is also about allowing the interaction to be the same, and then you can move wallets without feeling like you lost a leg when you were moving, right? So that's like, I think that's important.
We love you too, and Arik is amazing on the standards, as is Lucas. But I think the smart account, the problem I mentioned, you cannot standardize because there's too much innovation. I'm also talking in my book because Rion are building a library so that wallets can easily manage any smart account implementation and such that users can still rotate. I want to, maybe Lucas has another take, but I want to switch gears a little bit because it's so rare that we have wallets with so many users and different types of users on the stage. Maybe, and someone like Arik who's onboarding new types of wallets. I heard the stat this week and it seemed credible, I don't get it together right, but TLDRs, we penetrated 10% of the market, so 10% of internet users somehow interact with crypto. So that doesn't mean, but there are probably users like myself, like my bank, I have X accounts, but maybe soon I will have 5X accounts because my Chase bank also has crypto. I mean, that's probably Arik's wheelhouse. But I'm curious, A, where are we going to get these 90% from? And then B, does it keep you up? Do you think you can compete, or is someone completely new like Apple going to come away and sweep away the users?
We get them from mobile.
From where?
From mobile, that would be my answer. I don't think we built good enough mobile interfaces yet.
MetaMask or everyone? Just kidding.
Generally speaking, no, and I know that's the space that Wallet Connect makes a huge difference. But I think that's the growth of our user base. Yeah, and no, let me pause there. Yeah.
Mobile, yeah.
I totally believe that the biggest adoption comes initially through intermediates. So I don't think what's going to happen, maybe, but I don't think what's going to happen is that we're going to onboard 1 billion users to like if you're saying to extensions on browsers, right? Mobile is definitely one of the things, but I think what's more likely to happen is that companies that already have billions of users, right, and hundreds of millions of users are going to be embedding more and more blockchain capabilities. And as they do, some users will feel the blockchain first time without knowing it's a blockchain, right? Again, there's a lot of people playing a game that has blockchain behind it, and they don't know, and they don't care. And I think a lot of, it's like #1 in the store, first time it ever happened. And so I think that's what's going to happen, right? I think that social networks are going to bring those capabilities, and I think that, online shopping is going to bring those capabilities because they have so much to gain from optimizing all of their operations to be, or many of their operations to run on blockchains. It's cheaper, it's faster, like they can create better experience. That's why they'll do this. They will not do this because they like blockchains as a concept. They'll do this because they will provide better service to their users and they're going to save money. And so I think that's where adoption comes from. And over time, the people that until now heard about blockchains as the place where people get hacked or the place where price has gone up a lot but they missed the train, they're going to feel the blockchain as, oh, that's why my internet is better now. And hopefully over time we can get them to be, you know, more self-custodial and more advanced users, things like that. But I think that's where adoption comes from.
Yeah, I actually also very much see adoption to potentially come from more custodial solutions first, where like I think we also reached the limit of how many people we can convince to write down the seed phrase and store it securely. But like people are used to like Web 2 experiences. If something, even if it runs on the blockchain, has a Web 2 experience and it has some custodial nature to it, they would use it if it brings a value. And I very much want to see a future where we very much embrace exit hatch as a viable option for things. Where like the source problem that we have today with intermediaries and with custodial solutions is that I'm locked in. Like I have no way out. I have my bank account. Like my bank account is not going to say, oh, here's an easy migration path how we can move from Credit Suisse to UBS. I mean, except just acquiring them. And but like let's say JP Morgan and UBS, they don't have like this interconnection. Yeah, you can send out the assets one by one, or like I know. Rewind your position in your portfolio, etc. But like, there's no interoperability there. There's no exit hatch there. Like, that's what we need. That's what unlocks innovation, better competitive environments for startups, etc. And like, I want to use Facebook. It's fine if it's custodial. Like, it's fine if they manage my social graph, if they do transactions on my behalf, if they have a way to securely authorize. But like, I want to have this exit hatch that if Facebook I know goes down the wrong path, I can take my social graph and port it into some other solution, and I think that's the very thing we should preserve with control. Like if we don't have this anymore, I start doubting why we do things in the first place, because then we will slowly but surely go down the same path as Web 2 had. So this kind of exit hatch value I want to see in the future.
Yeah, there's one I would add that maybe we haven't touched on, which would be stable coins, which we've seen as a force for adoption. Certainly don't hope to see more of that as a root cause to drive adoption, but it's definitely where I think we'll see more adoption happening, access to stable coins in volatile economies.
Interesting. I mean, one thing that I think we're going to see soon with stablecoins is an explosion of stablecoins, yield-bearing stablecoins. So we were talking about, I think, gas abstraction, chain abstraction, but we didn't talk about stablecoin abstraction. But obviously, when I do a checkout on Stripe in USDC and I have a yield-bearing stablecoin, I want to be able to use that. So that's going to be a problem for sure.
Yeah, first of all, I can say we see stablecoin explosion, right? Like, because that's obviously a place where we're very active. But I think, for example, like for me, I don't know, I feel like it's sort of an arbitrage opportunity right now. We have a world with so many coins, and pretty much nobody uses a stable coin that is not the dollar. That's unclear to me, right? Like, it seems to me like something that's temporary and will change over time, because not everybody necessarily wants to be somebody in Europe not necessarily wants to hold his money in dollars most of the time, right? Like, because he still lives in euro costs in that sense, and then he moves automatically to the dollar. Obviously, there's a good thing about it if you're from an economy where you don't trust your coin, but like your native coin in the country. But it kind of feels like weird to me. I think that's something that will be solved. I think over time we will see more stable coins that are on different fiat, connected to different fiat. And we're going to see more of an FX marketplace on the blockchain that we barely see right now. So that's definitely something that will happen. That's by definition will bring more stable coins. And the other thing that will bring more stable coins is that eventually more institutions that the average person trusts will have their stable coin, right? Now, like, again, like we ourselves, we're like, well, we're kind of used to having stablecoins. Some of their more trustworthy organizations, some are less trustworthy organizations. But like for the average user, they know their bank. And if their bank has a stablecoin, they might just kind of trust it more. So like I think also that's something that will happen. We need to earn trust. And like as an ecosystem, like the ecosystem has done a few things that hurt the trust thing. So yeah, definitely going to see a lot more of those. But also, I think more decentralized.
What do you think is going to be the killer app? It seemed like you have some negative sentiment towards stablecoins. I think but then yeah, maybe what's going to be the killer app? Could be stablecoins, could be something else.
No, just to add some nuance to that, I wasn't referring to stablecoins, more the reason for end users to find stablecoins opposed to their fiat stable currency. That was the negative sentiment that unfortunately shouldn't be the driver. Let me think on the killer app.
Because I think what we were talking about for new users, like the next 90%, and they will probably not just have one account, but maybe 100. Another thing might be, Lucas used the example of Facebook, like if Facebook becomes a crypto app, or Instagram adds crypto, like that's a new account, it's a new, so might draw in this, if they build a killer app that might really quickly get us 1 billion users. I think we saw a little bit of that with Friendtag. They obviously didn't get to 1 billion, but I know Telegram is hypothetically a new platform, and they might have app-specific wallets. So I'm curious to see is this going to happen overnight? Is there going to be a killer app drawing in these users, or are we 5 years away from pulling in these next 90%?
Yeah, I mean, we definitely had 2 killer apps this year. One is Polymarket, and the other one was WorldCoin, or it is WorldCoin. Like you can say, yeah, Polymarket, it's US elections, probably this adoption, it's going to be hard to maintain it, but like they definitely made it into mainstream media. They were able to onboard a lot of non-crypto users with account abstraction under the hood to kind of have this Web 2-like experience. And WorldCoin similarly, like, yeah, there are some controversies around it, but they onboard a lot of users who had no touch points with crypto before. Like I heard something like 25% of the people in Buenos Aires signed up for WorldCoin, and now it's about them actually making good use of this and funneling this user base to something that's valuable. But like they definitely, like, we're not 2019 anymore, where the only people using the products are the people building the products. We definitely made a lot of progress there.
All right, final question. Any hot take on UX, on wallet UX? Arik already shared one.
Any hot takes on what, sorry?
Wallet UX.
I think, I don't know if it's hot take. Getting to great wallet UX is a bigger problem than people think, and not necessarily everything works in the same direction. Again, as I mentioned right now with the like multiple chains, sometimes you don't just go forward, you actually go backwards. So like I think it's like really requires a big push from the entire ecosystem to get to where we want to get to.
No, I would just second that. That's a great point. I think when we talk about wallet UX, we often talk about the user interface and things feeling clunky or slow. But I think that's like a perception that is a combination of the ecosystem that represents itself in the wallet. That's where you see the fragmentation happening on many levels.
It's like always, we're the one at the gate, so we're the ones that people see. So we kind of hide all of the problems of everybody behind us.
What's your hot take, Lucas?
Try to make it as spicy as possible.
We're in Thailand. So.
No, like I love MetaMask, and I also like especially what you're doing at MetaMask. But I do think a big reason of why we haven't made more advancements in Wallet UX so far is because of MetaMask. Because MetaMask has had too much moat, and generally competition drives innovation. And I do think it changed a little bit in the last 2 years, I would say. But like 2018 to 2022, like MetaMask was just, like everyone just integrated MetaMask in their app until Wallet Connect kind of opened it up a little bit, leveled the playing field a little bit. Everyone was optimizing for MetaMask, and if one entity always dictates the UX of an industry, that's not good. So like again, like MetaMask is great. Everyone should use MetaMask. You guys are doing a good job. But like, I think looking back, there was a missed opportunity that we didn't have more competition in our industry. I think we would have been further along.
You actually got a hot take. That's so cool.
Yeah. Yeah.
Yeah, I should have started with that, but Hester, please respond.
No, I think it goes back to standards. And there was definitely an era where standards were lacking, the kind of wallet alliance dissipated, for lack of a better term. And that was definitely an era that I think we've passed now. There is strong competition, which is a good thing, and I think that's going to drive the UX forward.
Maybe a sign of that is that I think a lot of the early standards around wallets have just been basically reverse engineering what MetaMask is doing, so that other things like wallets do the same, and then you can use both because it's the same. And I think right now what's happening is a lot of the standards is more like communication between wallets and creating the standard that everybody believes is correct. So like that probably signals a shift in that, but like we're definitely not there yet because like, you know, like competition increases, but definitely there's still a big advantage.
I'm quite bullish, I think. I mean, even at this conference a few years ago, people wouldn't talk about UX, you know, now like UX is we maybe wouldn't have had this panel, you know, just a year ago, so I'm quite bullish. And wallets like yourselves are super game. Arik, many people from MetaMask, many people from Safe, when we put together an event, everybody get in the same room for a week, you're always happy to provide people, so I think we're gonna be able to fix problems together much quicker. Let's get into Q&A. Maybe a quick clap for the hot take, especially Lucas. That was a good one. Elephant in the room, maybe. I don't know. Curious what the audience thinks. Alrighty. I like the first one. Yeah. And these are rated by how many of you voted. So yeah, let's do the first one. Hester has a take. Go ahead.
Well, I just because of the framing of the question, I don't think it's about 100% decentralized. It's about 100% distributed control, which is different from decentralized. I think distributed control is a worthwhile goal that is achievable. Fully decentralized, I would be highly doubtful because of the fragmentation, because of the indexation that needs to happen for accounts, for networks, for tokens, anything we surface in the wallet. But distributed control of those indexes, I think that's a goal that's achievable.
Centralization is such a sneaky thing, okay? Because at the moment you think you solved it, you most likely just pushed it into a different place, right? And this is what we see as an ecosystem like Ethereum staking. So there's so much work on making solo stakers easy, making this, and then suddenly like a Lido comes in, people are like, oh, we missed that part. And then like, you know, and then new actions happen. So like what usually happens with centralization, just like security issues, you push them from one place to the other place and you need to constantly reduce like those. So I mentioned this earlier with passkeys. I think that's going to be the second place, the other place that suddenly catches us sort of off guard. Then that's going to be solved, and then there's going to be a new place that catches us off guard. So like it's going to be that process where you just move it around between places until hopefully it doesn't have anywhere to hide.
You wanna,
please.
Yeah, I can take the next one with thoughts on Coinbase Smart Wallet. I'm personally super excited that they're working on this. I would have had higher expectations at the beginning of the year of where we are now, because like the promise of like Coinbase is offboarding all of its user base, which already has crypto on chain, and they use Smart Wallet for that, and they have amazing innovation there around magic spend, where you can actually use your Coinbase centralized exchange balance on your wallet and spend it with a dApp directly. Like I thought this would be like a, yeah, this kind of opens the floodgates, and now all the Coinbase users are coming in. We haven't seen that actually. There's a bunch of wallets deployed, but like if you look at how much assets are actually used on these wallets, it's quite minimal. I mean, minimum like $1 million or something, but compared to what Coinbase is. But still, I just recently heard that they're doubling down on this strategy, and that's a very good thing where like they very much engage with the ecosystem, the wallet ecosystem, especially also the account abstraction ecosystem. They get where things are heading. They contribute to standards as well. Yeah, I hope they will especially embrace the standards that enable neutrality, such as ERC 7579. So we have like an open way to build on Coinbase Smart Wallet, and it's not a permissioned thing. And like yeah, so long story short, thought it would be faster, but still very much excited about it.
Let's go to the...
Just to add one thing, I think it's a very positive indication to our industry that somebody like Coinbase, who has so much control over their users, are willing to relinquish some of that control to advance the ecosystem. So first of all, that's like a big kudos to them on making those steps with slowly, because they're not just making money, they also have this thing they believe in, and they're slowly pushing towards that. We kind of expect now L2s to do that, right, with their like single sequencers, and we want them to move to more decentralized efforts. So it's just a bullish thing for all of us that they're kind of willing to do that effort, and so good on them.
I really like the innovation too, but gotta say, like all the exchanges are obviously following that strategy, and they're all doing amazing. Like OKX was really the first large-scale wallet to do an account abstraction wallet. The first one half a year before the second one, Trust, which is also owned by Binance, came along. So I think all the exchanges are doing surprisingly amazing innovation. I'm surprised that nobody's asking what Arik's favorite Pokemon is. I know the answer, ask me later. Not Glurak. Yeah, who wants to take the on-ramp question? I think the questions are great. I have a take on on-ramp, but...
I want to take the next question.
I think on-ramp's been absolutely amazing. Like, there's so many fee-less on-ramps. It's mostly for the West, but the innovation in on-ramps has been amazing. So I think it's gonna, you have a counter?
I think we talked about it a bit as well. Like, I believe on-ramping does in a lot of situations go through somebody who already has user attention, right? And can solve some of the problems that the user has to deal with and just get them more easily into the ecosystem. I believe in that.
I mean, everyone's coming online with an on-ramp. Stripe has an on-ramp, like it's not big yet, but like it's gonna be, you're going to have an account somewhere within a custodial solution where you already have your bank account linked, and then you can easily on-ramp. And then one day, everyone will have this magic spend-like feature where I can just source funds from, this is a bit further out in the future, but yeah, I think on-ramp's getting great. Off-ramp, a little bit less innovation as far as I can tell, but still, I mean, there's like Bridge was the big fintech acquisition recently, which makes off-ramp for now in the US easier. In the EU, there's also like this bank account type off-ramp innovation. So very bullish on that. I like the question. Yeah, if you have enough designers.
Yeah, I know. I'd love to. This one.
We are hiring designers.
No, I think one of the challenges for designers, I mean, the space is mind-boggling for any of us, right? Like, there's so much to keep up with. It's the same for designers. I think what really helps designers is being involved as early as possible. You can't design for anything that you don't fully understand. And what I still see often is designers being kind of looped in at the end to add a user interface on top of something that's already abstracted. If you imagine coming into the space now, especially with account abstraction coming, you would have no concept or understanding of how accounts are generated or initiated in the first place.
Maybe the problem is not that we don't have enough designers. I think we don't have enough founder designers. Like, I think that we're such a technical space that a lot of the founders are technical, and maybe like the designer view of the entire company is something like founder designers might be interesting. I don't know how many of those we have.
It's a cool take, yeah. I mean, Rainbow Wallet is very designer heavy. Family launched yesterday, founded by a designer. So interesting take.
I think in the early days also we were kind of designing or building for ourselves as a target audience, like a lot of technical people, and that kind of worked. But I think now we reach a point where we are not the target audience anymore. Like if you want to extend, you said like 10% had touch points with crypto. Like if we want to get to this 90%, we need to build for people that are way different than ourselves. And it doesn't just have to do with designers, it just has to do with having a extremely user-oriented approach to product development. Not solve technical challenges with technical solutions, but solve user problems with whatever is the best way to solve that. And it can involve design, it can be technical innovation, it can be different ways that you achieve that, but like maximize on user value and not on just innovation. And the other part is that our industry very much just likes doing the same thing that everyone else is doing. So we live in narratives, and like if someone else is doing something, we just assume they somehow had some big insights and we just copy them and we do that instead of talking more to our users and actually do what our users tell us to do instead of what our competitors are doing.
Last question and then we wrap. Sorry to put you on the spot, Hester, but the question is the extension wallet going to disappear?
Sorry, which one?
The second one, is the browser extension wallet going to disappear?
Interesting. I think the interaction paradigm of an extension, the way we know it, might disappear. What you're definitely seeing is everything moving into a side panel, which makes total sense because you have the wallet in context of what you're doing, something you don't have when you're using the traditional extension. Disappearing entirely, I don't necessarily see that happening, just because there are so many use cases that you would want to use on a desktop interface. But it'll definitely, it'll reduce, again, with the use of smart contracts accounts. Your mobile might be your primary way to manage your accounts and signatures. Yeah, paired as a companion to what you might still do on a desktop.
Awesome. Thanks all, and thank you for listening.
Okay.
Thank you.
Thanks for the great panel, guys. We have another presentation on ERC 3668 on Linea starting in a few minutes. If you guys are interested in that, please stick around. Hello, everyone. Thank you for coming. My name's Rodrigo. I work at the Ethereum Foundation. I'm glad that you guys have all come. This is our last presentation before lunch. As a quick reminder, please refrain from using Flash on your phones. Use Meerkat to ask questions. You guys have been doing an awesome job with that. And I'd like to introduce our final speaker before lunch. It's Arthur, product manager at Linea, and he's going to be talking about ERC 3668, trust minimized data retrieval from L1 to L2, or from L2 to L1, sorry.
Sorry about this. Okay. Hello, everybody. Thanks for being there. I know it's the lunch break, so thanks really for being there. So my name is Arthur. I'm a product manager at Linea. And so like today, I will be talking about ERC 3668. So yeah, let's get started. Basically, the agenda is quite straightforward. I will explain what it is, why do we need it, right? And how does it work, the use cases behind it, and I will spend some time talking about the cool integration that we did at Linea to benefit from this standard. So maybe to set the context, let's just talk about how we can access external data. I think most of you knows, but natively, right, a chain cannot access data from the external world, whether it's over chains or the web. But like over the time, we built some other protocols that solve those problems. So the main one are bridges, right? If you most known to if you want to bridge assets, so coins, NFTs. But there are also message bridge that let you send a transaction on chain A and it executes a transaction on chain B. There are also oracles that are well known for like price feed mostly, but most recently, they have creating more generalized implementation, such as like chain-link functions and other. And lately, we have also coprocessors that are enabling those kind of use cases. So the question you might ask yourself is, okay, why do we need another solution? And basically, ERC 3668, also known as CCIP read, was a standard proposed by the ENS team, especially Nick, because they had like unique use cases where they wanted to access the information for L2, especially for managing like domain name with cheaper like gas cost, but they have some constraint and the design is reflecting that. So the first benefit is that it doesn't require any transaction to send on chain compared to all the other solutions that we mentioned. So this is more efficient in a way if you don't need to store the data on chain because you don't have to pay the gas cost. You also avoid external dependency on external protocols because it's an ERC and it's like on top of the protocol but doesn't have those dependency and external additional trust assumption as well. So let me tell you a bit how it works. There is three parts to it. It starts with the client, and here we are not talking about execution client or consensus client, but more like the UIs or like backends that are calling the blockchain. And like the client will call a smart contract, right? Standard if call to get some information, something that happens quite generally. And the main part of the design from ERC 3668 is this allows the contract to revert with an error that's basically tell the client, actually you need to give me a bit more data so that I can do my job. So at this point, so the client will add the job to fetch the data on a gateway, so a standard HTTP call, and of course the gateway will send the result, and then the client is like giving back the information to the contract through a callback function. And at the end of the day, you have an answer. So here I talk about call, but actually the callback function can be also sent in a transaction. So that means that at the end of the day, you have some logic that can be executed on chain in a block. The nice thing about this design is that if you look at the off-chain data error, there is all the information stored on there to explain to the client what he needs to do. So in advance, the client doesn't need to have any information about what are the gateway to call, what is the information that I need to send to the gateway, which is the call data, or what are the callback function, and so on. So this means that the client can have a standard implementation and you don't need to integrate each time like a specific use case. So if you want to integrate like a chain like, I don't know, optimism and a chain like linear, you don't have to do it twice. So if you are following like attentively, you might ask yourself, but okay, like it seems that you have to trust the gateway, and like thanks to during the introduction, we said it was like a secure and trust minimized way to fetch data. And actually, you don't have to trust the gateway necessarily if the gateway provides also a proof of the information that were given. And the nice thing about it is that you know that L2s, like in the design of Rollup, are posting their state on the layer 1, and so you can like just fetch a storage proof on the L2 and then like verify it on the layer 1 so that you can be sure that the data is accurate. So that's what is shown here. When the gateway is doing the HTTP request, actually the gateway will call a L2 RPC, will ask for the information through an if call, and then also like do something like a if get proof to get the storage proof. And then when the contract receives the information, it will call the rollup contract, which can verify the proof at a high level. So I think like the design is quite cool, but what can we do with it? As mentioned in the introduction, like ENS was the one proposing it, and actually they had a very specific use case in mind, which was to enable to manage like domains on L2 for cheaper like gas cost, and that's the main use case that we are seeing today. One example is the linear names that we introduce on linear, where you can have like names like brian.linear.if or arthur.linear.if. It's something that we built and that can be reused by like the ecosystem to build any integration with ENS, and it works like everywhere ENS is resolved. As an example, like we have an NFT collection on Linear which are called ifrogs that wanted to give a ENS domain to all the holders. So for instance, now if you have a you type 743.ifrogs.if, it resolves to the owner of this NFT, and if the NFT is transferred, like the name is transferred with it as well. So this is kind of cool. But it's just a first use case, and it doesn't stop there. Like it can be used for any type of use cases where basically you want to either compute or store data on the layer 2 or even off-chain and access it on layer 1. So some examples include like DAO governance, where with solution like, like governance solution like Snapshot X that are providing like voting on chain. You can vote on linear or over L2s that are much cheaper in gas, and then you can just take the result and call this result to execute transaction on the layer 1. One other interesting use case, for instance, is to like gate access to smart contracts. So for instance, like if you are doing an airdrop or NFT mints, you can require people to have specific credentials that are minted on layer 2 in attestation, for instance. So, okay, you might ask your question, how do I need to implement that? It seems really complicated. You are talking about proof and so on. The nice thing is that we already implemented all the smart contracts. So like all this complicated logic, or not so complicated, but all this logic is already taken care of. We have a gateway that is running. We have all the smart contracts, the ones that are verifying the proof, which for ZK rollup is especially difficult because the ZK layer 2 usually have a different way to store data because like the standard hash function can be a bit like complicated for ZK. So for instance, on Linear, we have like sparse Merkle tree instead of Merkle tree. But basically, all of that is to say that we have contracts that are open source and that can be called to verify the data, to also fetch the data directly. So basically, on the smart contract level, it's much more simpler. And on top of that, there have been teams like the Unruggable team that have built additional layer of abstraction that simplify it even more and abstract the chain so it can seamlessly like work on different chains. So to summarize the benefits, like ERC 3668 is efficient because you don't have to send a transaction on L1 when you don't need to. It's secure, especially when you are working like on a layer 2 with like zero knowledge proof like Linear. You don't introduce additional dependency to other protocol, and like the development overhead is minimal because all the contracts, the gateway, everything is already for you to build on. And so if you want to get started, those are some links to our docs, documentation, open source repo. But most importantly, we are doing a workshop just after the lunch break where we will deep dive into really code example, and you will be able to have a live version running on your laptop at the end of the session. So yeah, that's it. Thanks a lot.
Just a reminder, guys, if you guys have any questions, you can ask them through Meerkat, scan the QR code. Looks like we already have some more coming in. The first question, is it possible to read L1 data from L2?
So yeah, in theory, it's totally possible. Like ERC 3668 allows to fetch any data. The only thing is that you need to have like the state of the blockchain that you want to query anchored on the chain where you want to, from which you want to, sorry, I will go again. But you need to, on the blockchain that is querying the information, you need to have the state of the blockchain that is being queried. And so, like, it's not, most rollup doesn't have that at the moment. Maybe at some point we will see, like, Oracle that are streaming this kind of data on chain. But it would be something really cool to build.
The last question we have, doesn't it make the process more centralized?
So indeed, like the point of centralization here is the gateway. But if we come back to, okay, actually like the smart contract can like pass multiple URLs. So you have a kind of redundancy here because you can have multiple different gateways, not to rely on a single point of failure. But since the gateway is passing a proof, like it cannot be tampered with, so there is no additional trust assumption regarding like the accuracy of the data.
We have another question. Keep them coming, guys. We still have time. Does it open up to a temporal attack if the L2 storage proof is not posted on L1 yet?
Yeah, that's a very good question. So you are aware that like L2s are not finalizing like every second or minutes on L1, and so basically you don't have the state of L2 like before it's getting finalized. So on the like ZK rollup, it can be from a few minutes to hours, depending on the layer 2s. On optimistic rollup, it's like the 7 days. So this means that you need to wait this period in order to fetch the data, so there is this latency. But like as the space evolves and we are going to faster finality, hopefully this will get better. I don't think there is an attack. It's just that like the client and smart contract need to be aware of this limitation and like work with it at the moment.
What libraries already implement this behavior?
Ethers.js for sure, WAGMI as well. Unruggable is creating a like higher level abstraction to work across chains, so you don't even have to worry about like the specific of the each gateways and so on as a builder that wants to rely on your own gateway. Those are the libraries I know.
Is there any work latency when reading data?
So yeah, it's the finalization latency. So as I mentioned, like from a few minutes to 7 days if you're on an optimistic rollup. But like from the network latency, really, like it's really quick. Like usually less than a second or even less. So you can test it and like type, for instance, like arthur.lina.if on your MetaMask or on the ENS website, and you will see like the answer is almost instantaneous.
I think those are all the questions. Everyone can give a round of applause for Arthur.
Thank you, guys.
This is the last session before lunch. So if you guys want to come back, sessions will start again at 2 p.m. Thank you, everybody.
GM, everyone. Welcome back after a break. Supposing you enjoy your lunch. This afternoon, we're going to have 2 sessions, and the first one is going to be an interesting one. My name is Eric, and I come from Africa. My state is Ghana. So next time you meet me, remember that my state is Ghana. Let's have fun. It's going to be interesting this afternoon. You'll help me welcome an amazing speaker who has been working on Ethereum indexing. And no other person than Ryan Smith is going to speak on index on Ethereum. Oh my goodness, okay. He's going to speak on index on Ethereum. What do you need to know about it? So, ladies and gentlemen, everyone here, help me welcome Ryan Smith on stage.
Hello. How's it going? Cool. Oh, okay, cool. There we go. Yeah, so hello. I wanted to first talk about some stuff that I saw in Hacker News this morning. This hard drive here, it was pretty cool. I don't think it has the number on here, but it was like 60 terabytes of data, and the part that I saw there was kind of interesting was 12 gigabytes per second of sequential reads. And that's very exciting, and I'm going to come back to why that may be interesting a little later in the talk here. Another thing that when I saw that I was reminded, does anyone remember Fusion.io? Does Fusion.io sound familiar? Okay, like 2 people maybe, 3 people. Okay, do you know who the guy is up in the corner? Like raise your hand, do you know who that is? Yeah, Steve Wozniak, the Apple guy. Yeah, in 2010 he started a company called, or he was co-founder or something. He started a company called Fusion.io, and they were building really cool storage technology. And then that reminded me of this thing that I read recently, Dropbox. I think in it might be on there. Yeah, 2022, Dropbox had this article where they talked about how they were migrating away from SSDs and onto hard drives, which I thought was just like a very fascinating thing. And in particular, like maybe you've been sleeping on hard drives, but there's been some recent developments in like the spinning metal area of databases, which is shingled hard drives. And that was like a thing that was entirely new to me. And you can see there, like if you Google actually Dropbox SSD SMR hard drive, you'll find this great article that talks about all the reasons why they went away from SSDs and back to hard drives. And it's just a very fascinating article. Okay, so I've only got 25 minutes, and I was thinking like, boy, there's like a lot of stuff that I'd like to talk about when it comes to Ethereum indexing. And so my first thought was like, well, I can hit these 25 topics and maybe do, you know, 1 topic a minute. But then I was like, man, but that really doesn't like cover all the stuff that I would be excited to talk about. And so I was like, well, there's really like 50 things that we could like explore. That gives us like 30 seconds per topic. But then I realized like this is just a terrible approach. And so I willed it down to 3, which gives us about 8.333 repeating, of course, minutes per topic, which I think is much more reasonable. The way that I'm going to break this down is I'm going to share kind of how I think about software dependencies in general, and then we'll kind of like also explore like I think some unique characteristics of the Ethereum data space as it relates to dependencies. And then I'm going to talk about like this pattern. I've built like a lot of indexers over the years. I've been in this space for a long time, and there's been like a couple things that I've seen like kind of just like like I've done some things like over and over again, and I've kind of distilled it down to a pattern. So I'm going to share that with you today, and maybe you know, inspire you to build your own indexer, and perhaps you could use some of the ideas in this pattern. And then finally, I love databases. I really enjoy Postgres. I like other databases as well, but Postgres is in particular a thing that I enjoy. And so I'm going to share some fun Postgres tips. And so let's see. Yeah, let's get started. Oh, yes. OK, so I have a project called Index Supply. It's a company that sells indexing stuff but today, like, I'm going to convince you to not buy my software. Even though I do this stuff, I actually think it's like great fun to build it yourself, and I also think that there are particular situations in which it actually makes sense for you to build it if you're working on a company. And we're going to explore that here in just a second. So I'm not being facetious. I'm giving this the college try, convincing you to build your own indexer. Do not use my stuff. Okay, so let's get into kind of how I think about dependencies. So to start, like I want to talk about Ethereum in particular, and so like there's kind of like this base question of like what is indexing Ethereum, and so quick poll here. Who's read the yellow paper? That's about like I want to say like a third of the audience. Okay, great. So in the yellow paper, you basically get, and like the way that I'm kind of like thinking about this is that when you think about dependencies, you have to pick some anchor point, right? Like at a certain point, you're going to say like, okay, I'm going to go like invent a new kind of hard drive technology. Like, no, you're not going to do that. You're going to buy a hard drive, and then you're probably going to like use a file system. You're probably going to use an operating system. And so like there are these things that we kind of like anchor around, and then like on top of those anchors, then we start to think about like, okay, should I build it? Should I buy it? And so I think in particular for Ethereum, like we have like these primitive data structures that are built into execution clients, and they give us things like blocks and transactions and logs. But the databases that are within these execution clients are really optimized for processing the transactions, like not necessarily optimized for arbitrary queries. And I think that's like a fine thing, and perhaps there's like opportunities to blend those two types of workloads together, maybe. But we can kind of, I think it's fine actually. Like in particular, Geth has like these freezer files. Has anyone worked with a freezer file? Raise your hand. No one has worked with a freezer file. I don't see anyone who's worked with a freezer file. Okay, these are really cool. In Geth, like all of the transaction and log data is just like packed into a binary file on this file system. You can read through it very quickly. It's very interesting. If you just Google freezer files, you'll see some interesting stuff come up. Okay, I'm going to keep going here. One of the interesting things about the Ethereum landscape is that we have these core primitives, we have the nodes, and we have a standard JSON RPC API. And what's really great about this is that if you build with that as your dependency, you have this really nice commoditization effect where if you don't like your particular provider, they're not doing it for you. You can go to like 10 other providers, and so you really do not have hardly any vendor lock-in. Now there's some disadvantages, like if you just work at this level, because you have to actually develop software, you have to manage databases, so there's a little bit of a cost to it. And so, if we kind of move up, if we go to like the other end of the stack, and you use something like, like what I build, or there's like a handful of other products out there that give you like a more robust API to access the Ethereum data, and maybe you don't have to use a database, but now you're like entirely dependent upon that API. And if that API doesn't work for you, you've probably built your application around its abstractions. And so, you want me to move over? Okay, I got a subtle hint that I should move over. You want me to keep going? Okay, perfect. Is this better? Wonderful. If you build around those types of abstractions, you can kind of hamstring yourself eventually if it doesn't end up working out for you. And so, like another way that I like to look at this is when it comes to like dependencies in general, like let's say that you have like a very high value project. Like you could have a high value project or a low value project, right? Something you're just messing around on the weekend, or you could have something that you're trying to build a business on top of. And within that category, you have like low skills or high skills. And if you don't know anything about about interacting with databases or keeping data around and easily accessible, then you might want to buy something, and that's fine. But I think one of the things that I would like to kind of posit today is that indexing Ethereum, like, it actually isn't that hard, I don't think, and I'll throw like a couple things kind of at you to kind of encourage you to, like, if you happen to be in this category of you're working on a high value project but maybe your skills aren't there, I think that there's absolutely stuff that you can do to advance your skills so that you can build something that you're really proud of. And then on the other end of the spectrum, it's like, okay, you've got a high-value project, you have high skills, and here, I think it's like very important to build it, actually. If it matches the core competency of the company or the project that you're working on. And I think the most important thing here is that, like, when it comes to thinking about dependencies, it's like you don't want to outsource your thinking. You want to kind of come up with your own opinion and like your own motivation for why you're doing a particular thing with your data. And when you build it, you're forced to think about it, and you're forced to lay something out that you think is going to match what the business needs. Okay, so you got a low-value project and you have low skills. I say just jam it together. You do whatever. Find the quickest path to get the thing online, and that's fine. If you've got a low-value project but you have high skills, I think actually kind of both can work. And the way that I kind of think about this is, if you form an opinion of how you're working in a particular problem landscape, and you come up with your own opinion for how you want to build a solution, and then like you maybe do some shopping. You say like, oh wow, there's a couple projects that already exist that are doing the thing that I would do. And so in this particular case, you're not outsourcing your thinking, you're outsourcing the maintenance of that software, which is like a real advantage. And so even if you have the skills, it really is a toss-up in terms of whether you build versus buy. Okay, so part 2. I'm going to go over this essential indexing pattern. And like I said, I've used this for probably, I don't know, 5 or 6 years. I've worked on some pretty big websites in the Ethereum space. And this is the pattern that really has worked well for me. So I'm going to share it with you today. And it's basically, there is this old Fred Brooks quote that says, show me your flowcharts and I'll continue to be mystified. Show me your tables and I won't need your flowcharts. And so I like to start with the tables first. And so like the building block here is that you have a table called blocks, and you keep track of the number and hash of the block. And then you have all these auxiliary tables like foo, which is like your indexed data, arbitrary data that you want to index. Okay, so now here's like a wall of code. But basically, like this is like the core function. And I won't like go into every painstaking detail here, but this is like the core function that uses those two tables to effectively index data on Ethereum. And it uses some, like you can kind of see here, there's some RPC code going on, there's some database code going on. In particular, this thing down here at the bottom, this copy logs, that's like a really cool Postgres technique that allows you to really quickly load data into a table. And so again, like I'm not going to go through the whole detail here, but I wanted to show you this because it's actually, like I'm saying like this can get you very, very far. And in fact, you can even just kind of copy and paste this into a project to kind of help bootstrap you and get you started. At some point, like I might even throw this on a gist or something, so that someone could like copy and paste this, and we'll make it work and compile and stuff. Because right now it doesn't, but it's more or less there. Okay, so another thing with pointing out is that like the current like kind of high-level architecture of Ethereum indexers kind of fits into this first category. And so basically, like I said earlier, we have these sources of data like an RPC API or an execution client, but they don't really give us the type of interface that we would want when it comes to building queries for our applications. Source, it's like an ETL workload, right? We extract the data from the source, we transform it, and then we stick it in another database that gives us flexible queries so that we can build stuff onto our apps. It's fine patterns, like what the graph uses. It's a very common pattern in the space. I think that there's another pattern, though, down here at the bottom, which I'm more interested in, which is, how can we like just continue pushing like our query logic onto the source data, and instead of having ETL, we just have query to the database. And I think that's a whole interesting path to explore, and I've got some ideas there, and would be happy to talk about it. But I just want to kind of call that out. Okay, so. Part 3, we're coming in here on the end. I'm going to go into some Postgres tricks. And then another poll for the audience here. Who uses Postgres? Okay, wow, quite a bit of people. This is by far the biggest, positive affirmation of a poll that we've done so far. It was about like, I would say like 70%, maybe 75%. Okay, great. So you've got the essential indexing pattern, you've got the architecture. What are some here's like a quick checklist of like really good features to use when it comes to indexing Ethereum. First one is copy. Show of hands here. Who uses copy? Okay, fewer, let's say like 10 to 20%. Okay, so if you are inserting more than, let's say, 3 rows at a time, and you're using insert, you are wasting compute cycles. It is massively inefficient. There is almost practically 0 downside to using copy. So if there's one thing that you walk away with today, and you're a Postgres user, and if you're ever inserting more than, let's say, 3 rows, like move over to the binary copy, and you will instantly see a major performance boost. Advisory locks, another really cool feature in Postgres. So it's an in-memory lock that you can use, so it's very cheap. You can have thousands of them, maybe even hundreds of thousands of them. And this is a really nice way if you want to build an indexer and you want to have 2 of them and you want to perhaps like run them in an HA configuration, but you only want to have one doing the work at a time. An advisory lock is a great feature to use. Another feature that I like is table partitioning. And so we'll kind of explore this a little bit in my next tip. But basically, you can take like a table and you can specify a partition key on that table, and then you can specify how many partitions you want to run, like let's say 10, and Postgres will automatically create 10 child tables for you. And then when you query the logical table, it'll automatically find the right partition table to get the data from. And this is like completely opaque. You don't have to do any of this stuff in your application. And it gives you a really nice performance boost when you are bounded by disk I/O. And so let me kind of show you how to kind of think about like when you may be disk I/O bound. To do that, I'll quickly introduce a Brin index. Show of hands, who knows about a Brin index? Even fewer. This might be the smallest number, but I see you out there, and bless you, because this is a very fantastic index for some use cases. So basically, like when you have a table and you put data in that table, Postgres will put, like if you insert a row into a table, Postgres will take that row and it'll end up in a file on the file system. Postgres, by default, uses 8 kilobyte file sizes, so that means that it's going to be spreading your rows across multiple files on your file system. What a Brin index will do is it will basically, if you have a column that has a high correlation, like so for example in Ethereum, block number would be a high correlation to the way that your data was going to be laid out on disk if you do an insert only append kind of write style. So if you're just like keeping up with the blockchain and you're writing data and you're putting the block number in those rows, then like as you store stuff on disk, it's going to correlate with the block number, right? And so this is a great use case for a Brin index because what you do is you have this super tiny index, much smaller than a B tree, and it keeps like, we have like this page block up here that says, okay, in this page block 0, I have block number 0 to 99,000, and those rows are stored in pages 0 and 1. And so you basically have like this top level, like higher level index that like, you know, for a given block number, it can basically redirect you to the right set of pages to read in the operating system. And so let me quickly show, we've got about 2 minutes left. Let me quickly show you, so here's an example. So I have this table called logs. You can see I got a block num column there. This table's about 4 gigs. And then you can see I checked the correlation of the block number. It said 80 to 99%, and I queried it like earlier this morning, and it was saying 99%. And then all of a sudden, it just stopped saying 99% and started saying 83%. And so then I became very angry. But that is what it is. I think it's wrong, but that is, I'd like to find that stuff out later. Okay, so here's another cool Postgres tip. If you're writing queries, you've got to figure out like the explain command. It's like it is literally life-saving. Like get to know this command, and you will become a great database administrator. So you can see here we hit a bunch of blocks, about 500,000 buffers. So multiply that by 8 kilobytes. That's how much data that we read. You see, I created the Brin index. And you can see that index size is only 320 kilobytes. And I had a 4 gigabyte table, so a very small index. And then the resulting query after that is I only had to read about 42,000 buffers. So like a massive decrease in the amount of I/O that was going to happen there. I'm just going to go ahead and show you what a B-tree index would do, which is like your default index. So you can see here, it's a much bigger, we went from 320 kilobytes. B-tree index is 250 megabytes, much bigger index. But you can see down here, it's just, game over. B-tree index is really great. Much faster, much fewer buffers. But sometimes you don't need Sometimes you don't need to have that level of performance, and you might want to trade off storage size. Also, it's very quick. Like if I have a terabyte table and I create a B-tree index over a block num, it's actually going to take a long time because it's going to seek scan that whole table. A Brin index will happen much faster. So even if you're in a pinch and you're just trying to like find some data in a big table and you don't want to wait to create a B-tree, creating a Brin might actually be a good stopgap. Another Postgres little bit of tidbit of knowledge is that you have a B-tree index and that is going to have a ton of data in it, and you might say like when you're doing a query and you have like a huge table and you have a huge index, does Postgres have to load the entire index into memory to be able to do the search of the B-tree, to be able to find the right rows to return to you? The answer to that question is no, and I thought this is kind of like a fun fact, but in the docs it says, typically when you have a B-tree index, so if you have an index that's, let's say you had a table that's a terabyte, you got an index that's like 100 gigs, 99% of that is going to be the leaves, which means that when you want to go search that table, before like you need to find like the target rows, you're actually going to be able to keep that index in memory because the majority of the data that you're going to be searching on is going to be very small. Okay, so time is about up. So oh man, I'm really bummed. I really wanted to talk about CTIDs. And I didn't, but it's really cool because whenever you query, I'll just briefly mention it, whenever you query a table, you can always ask for a CTID. It's a hidden column on a row, and it tells you what page and what offset into the page that particular row is in. And then there's some cool things that you can do with clustering if you want to rearrange rows as they sit on disk for improved I/O performance, you can do that with cluster, although it's not an online tool, you would have to recluster if you wanted to change it. Okay, whirlwind tour there, but that's it. I wanted to kind of plug Farcaster. We have a Postgres channel, and I encourage you, if you're interested in any of this stuff, check out the Postgres channel. There's a lot of good discussion happening on there. So thank you very much.
Thank you, Ryan. Question time. So the audience have some questions for you, and we're going to go through it. The most highest
reorgs. Yes. So that code that I showed earlier handles reorgs. It was in there, and so maybe you got a photo of it, or maybe we can I can post it on Gist or whatever. But there are very easy ways to handle reorgs. It's not that big of a deal. Don't let it scare you. We can definitely solve that problem.
So first question, one PTA. One picture for us was handling blah, blah, blah. So 5 votes. It means that it's the most important question now on the stage. So can you answer that one, please?
Yeah, we just did that one. So I think the next one would be how to deal with load balance RPCs. Yeah. So it's kind of also kind of a pain in the ass. Basically, you send a request to an API. You say, give me the latest block, and it's like the latest block is 10. And then you say, okay, great. Now give me all the logs for block 10. But it's load balance, so it goes to a different node. And the awful thing, the sin of the JSON RPC API is that if you ask for logs and you give it a block number that is higher than the block that it's currently processed, you would think it would say, hey, I don't have that block. I don't have these logs. Error. It does not do that. In fact, it'll just give you no data back, as if it had that block but did not have those logs. And so this is a big gotcha, and you really have to look out for this. There are a couple tricks. I'll just go ahead and give you one now. But it's like 50% success rate. I don't think there's a 100% way to deal with this, but one hack is the JSON RPC API allows you to send batch requests. And sometimes there are proxies that will take batch requests and split them up and give them to different nodes. But assuming your API provider doesn't do that, and it just takes the batch of requests and sends them to one machine, you could hack this by putting your get logs request with a get block number request, because if you ask for a block number by a specific number and that block number isn't on that node, it will return an error. So this is like one way to trick the node into giving you an error when you ask for logs and you don't have the block. So there's a couple other solutions, I think, but we'll keep cruising here.
Yeah.
Do you think it makes sense to have an index or interoperability? I don't know about number one, that first question. I'm going to go on. So what do you think about using ClickHouse or Times? Oh, that's interesting. Yeah. So I mean, here's the deal. If you want to do like a group by, or you want to do like a count or a sum over like 1 million rows, or yeah, over 1 million rows. Like if you want one column over a lot of rows, you might want a columnar database. And the idea there is that you are wanting to reduce, like, so instead of like, if you don't have a columnar database and you have to like get the value out of a row, that means that you have to go scan a whole bunch of operating system table pages to get all of the rows, but really you only care about one, and so, for doing like an aggregate or something. So that's a lot of wasted I/O, right? And so the idea is, can we do better? And so for very specific use cases, when you want to do aggregated stuff, a columnar database might save you from a lot of that I/O. So, it is a way to improve performance if what you're trying to do is like more analytical queries that works on aggregated data. So not great for OLTP stuff, but yeah, if you have aggregates, it's fine.
1 more minute to go.
Let's see. Do you think it makes sense to have an index? Oh, I already did that one. I didn't have an answer there. Can you explain better why a Brin index is so much smaller than a B tree? Yeah, because a B tree is going to have like some knowledge of every row in the table, right? Like every row in the table is going to have some map onto the index structure, whereas a Brin is like lossy, right? So in a Brin index, I have one node in the index, but that one node in the index can actually cover, let's say, 100,000 rows, right? It can say, hey, you're querying for block number 10, and the Brin index says, okay, well, I know that block number 10 is like in this block of operating system pages. And so then you have to then go like basically sequential scan within that set of pages, but at least you're not scanning on the entire table, right? So it's like the Brin index is smaller because it just simply has less information. But it can cut, if you're just trying to get rid of a sequential scan, like it definitely can like cut out a sequential scan. So
all right, thank you so much,
yeah,
Smith. Thank you for having us. Please give me a hand applause. Thank you. Oh, wow. Interesting. The next session is going to be a keynote speak by... Okay. So we have 2 minutes break. Just to move around, stretch your leg, 2 minutes. We are back on stage at 2:30. Thank you. Welcome back. Everyone, GM, once again, help me welcome Justin, who is going to have a 20-minute keynote on the theme, the Universal Cryptographic Adapter. And Justin is the man to do this. So in the next 20 minutes, the man you're going to hear is Justin. And Justin, this is the audience. Please walk on the stage and engage your audience. Thank you.
Hello. So after Ryan talked about data, we're going to talk about data. So to kind of like situate ourselves a little bit in, I have 60 slides. You can't go through 60 slides without knowing why you're here, because otherwise you'll just like lose attention and collect frogs. So Zurich thesis for data systems is that essentially in like one sentence, programmable cryptography, so zero-knowledge proof, FHE obfuscation, enables what we call the universal data adapter, which is in some way like the Turing machine moment for data. What I mean by the Turing machine moment is we think we basically finally have an abstraction that's powerful enough such that it's not like a marginal improvement, it's like an order of magnitude improvements. The same way electrical circuits basically got turned into like extremely powerful beasts when we figured out how to program them and make them general. It was not like an improvement at the physics level, it was an improvement at the mental model level. So another way to say that is we think cryptography is a way to get more out of data. And most people will tell you that cryptography is a way to make data more private or whatever. I think that that's a great side effect, but deeper than that, cryptography is a way to get more out of data. Essentially make data more interoperable, be able to get data out of their silos, reap more economical benefits out of data. And it's pretty important because we live in a world where the value of data keeps increasing over time. One way we like to put it is we take data out of their data prison. Today, if you want your data to be safe and secure, it's useless. You have to like kind of like keep it for yourself. And it applies equally for like individuals who want to do self-custody, but also for companies. Like, why keep your data on your Linux server if you can put it in the one big database, you know? Because the one big database will like give you more value out of that. So there's kind of like this push and pull between people want to keep their data kind of like away in some sense in a secure environment, but that's equivalent to a prison. You know, you can't go screw with the inmates, but the inmates are not useful to society. And another way to say that is it enables more interoperability in usage of data. So our goal is to create more total value out of this, and at the same time enable a pragmatic route towards data ownership in a world where data keeps increasing in value. Because if data keeps increasing in value, the burden of proof for going through that route keeps increasing. Okay, so this is kind of like the TLDR on the data stack we have so far. We have pods, which are essentially specially issued packets of cryptographic data, almost like a record in a database. We have these cryptographic machines called GPCs that ingest pods and make claims about them using zero-knowledge proof. And the really interesting thing with this system is it's performant enough to run on mobile browsers while being flexible, and it's close to being production ready. And all of you guys are using it. Zupass, where your tickets are and your frogs is running on pods and GPCs. So as an example, a Devcon ticket is a pod, a frog is a pod. I used GPC to log in into the Telegram group where you had to prove you had a ticket. When you enter the frog zone downstairs, you also make a GPC. So this stuff just works, and there's a huge, like, not huge, but there's definitely a list of like, on top of that, like third-party application that is built on top of this system, mostly from the Zuzalu ecosystem. So here's the TLDR. The way it works is some authority attests to some data and signs it via an EDDSA signature on the job curve. This gives you a pod. You take a bunch of pods, you put them into a GPC, and you make a claim that is verifiable, and then you can hand that over to a verifier. That's essentially how it works. We'll go into the details. So the issuer basically calls this like pod.sign method on a bunch of key value data. You get out of it this thing with a signature that is on the content ID. We'll focus on the date of birth here for the sake of the example. Then you configure a GPC config, which makes a claim about the date of birth. For this example here, it's not revealed, and we prove that it's between a minimum and a maximum. And then finally, a verifier receives the artifact from the proof and can verify that claim. And a really cool thing is you don't need any new zero-knowledge circuits. It's pretty flexible and also extremely performant, right? So we have this system. We've been working on it for a year. And you can go check it out tomorrow at Classroom B at 2:30 p.m. But last summer, we wanted more out of our system. Like, this is pretty sweet, but we think this is far from being the best we can do. So if we look back at this paradigm I just showed you, there's a bunch of limitations. The first one is we need specially issued data. What this means is we need to convince data testers to like change the way they issue data, which is not very pragmatic. It's limited to one round of computation. You can take pods, put a GPC on top, but what you get out of it is not another pod. It's like this thing that you can't keep computing over. And finally, it's very much limited to single-player use cases. What I mean is when you create this GPC proof, you actually need to know all the input pods, which means that if you try to do it together with multiple people, one person will know all the inputs. So this is not compatible with the world we're in today, if we're pragmatic about deploying this beyond, things like Zuzalu, Devcon, etc. First, there's a lot of cryptographic data, yet it's very heterogeneous. Stuff that comes out of trusted execution environment, blockchains, email, transport layer security, national ID systems, etc. All of this is cryptographic, but it follows different schemas, different signature schemes, etc. Basic use cases often require more than 2 rounds of transformation, like you want to transform your data multiple times across multiple people. And we think that there's a whole world that might open up if it's actually possible to go more than 2 rounds. If you think about the internet today, we never have like platforms that go more than 2 levels deep. It's like we're building on top of mud huts and we dream of skyscrapers. We don't really know what's going to happen if we can go deeper than that. There is a lot of work on domain-specific system from the cryptography perspective, but yet there's absolutely no interoperability. Over the last 18 months, none of the ZK-ID systems actually work with each other, So it's pretty interesting, like why? And from the programmable cryptography perspective, the unlock of zero-knowledge proof is trustless refactoring and import, right? That's the right way to think about it, not as like a way to hide data, in my opinion. And you can use it to now create a universal system for making claim about the world's data. And the unlock of fully homomorphic encryption or co-snark MPCs, now you can combine that data confidentially. So we want to put together a system that makes use of these primitives and is like situated in a world like this without being wishful thinking about like, oh no, the whole world is going to like issue pods with EDDSA job signature or whatever. Like that's not going to happen. So what we want is we want verifiable and interoperable computational graph. So we want to import data. I think it's about emails, API calls. This is like a mobile driver license from the state of California. We want to turn that into pods. We want to compute at arbitrary depth with an arbitrary number of participants on this data. And finally, we want to export a view of this data to a verifier that can check the integrity of all the computational graph and the integrity of all the imports via like a single succinct proof. Right? That's where we want to get to. And so that's putting it together again. The goal for a second version of the stack is we want to be able to introduce anything trustlessly. And the reason trustless is important, it's not because we think that, oh, like, you're going to be censored when you like import your like RuneScape character or something like that. It's more like if it's trustless, it's scalable because any computer can do it, as opposed to having like some bottleneck in the system somewhere. We want deep computational graphs because actually today we've never really seen what would happen if many parties were to be able to operate on a piece of data and kind of like pass it along, right? Most of the time you have data that gets ingested by one big group of people and then it gets consumed and that's it. And we also want to do it between multiple people while maintaining confidentiality because we think this is how you can tap into much bigger economic output. Okay, so the first challenge we had when we faced this, which I think not many people have thought about, this is probably the most interesting challenge, is program composability. So imagine you have a list of friends. It's probably like a list of pods that you've received, like each of your friends signed something saying they're your friends. You can put it in a program, here it's some Rust, but anyone can read this, which counts the amount of best friend you have. Best friend is just like a property of friend, and you get out 13. Now you take this and you put into another function that says, hey, do you have a great friend groups, which counts how many best friend you have. Here it just counts, hey, is it bigger or equal than 3? And you get a Boolean out, true or false. Okay, seems simple enough. Here's how it looks like more abstractly. You have some pods that go into program A, gets a pod out, go into program B, get a pod out. Okay, so assuming we can do this cryptographically, what problem remains? Well, the main issue is if you have a program that operates over the output of a different program, you need program B to understand program A, right? Either via static analysis, either via formal proofs, but program B needs to know what program A does. So unless you write program B after having written program A and kind of like hard code the link between them, it's really hard for a program to make sense of the output of another program. If I tell you 42, and I'll tell you how it was computed, it's really hard for you to know even what the significance of that output is. And we don't really think like that most of the time. Like when people say, oh, we'll have ZK VMs and then we can solve everything, the main issue is that, yeah, good luck now doing static analysis and kind of like trying to make sense of other programs. And at the end of the day, it reduces to the halting problem. So what we did is we threw away the CPU model and we went to logic. and we threw away the opcodes and we moved to logical operation. So instead of a virtual machine built on RISC-V or something like that, we built a logic virtual machine. We replaced memory slots with logical statements. So statements like A is greater than B, or there exists C such that C is part of D. We replaced opcode with logical operation. So as an example, A smaller than B implies A is not equal B, or if you have A defined as 10 and B defined as 10, you can derive A equals B. All of these are like basic logical operations. Data becomes theorems. Programs become proofs. Not the kind of proofs that you know about if you're a cryptographer, a different kind of proofs. Now we're going to mix all the words together. And it's like a pretty interesting way to look at the system. Essentially what we have is data that gets imported are axioms. They're combined into a logic, like through a logic proof, they get combined into a theorem, and then more theorems can build theorems, right? So the interesting thing with that is all of mathematics is already built on that principle, which is every time we prove something, we can prove more out of it. And we don't need to understand what has been done so far. Like mathematics is truly interoperable in a way that programs are not. So if we get back to this example, you know, after we've counted how many best friends you have and want to know whether you have a great friend group, what this turns into is you have a theorem, and through another logic proof, you get yet another theorem. In plain English, you would have theorem blue, I have 12 best friends, implies theorem green, I have more than 3 best friends. Makes sense, right? So now we have 2 kinds of proof in the system. We have a formal proof and we have a zero knowledge proof. The ZK proof is used to show that the formal proof was computed correctly and hide some inputs about it, right? You want to be able to say, I have more than 3 friends without showing who your friends are, right? So, and you can kind of like go arbitrarily deep here. You have theorems, you make proofs. Out of that, you get a new theorem. You combine that with a previous theorem, maybe for someone else to make more theorem, and so forth. Here's how it looks like in a very early version of our system. So these are statements. These are the actual things that are inside a pod. So the most basic statement is the value of statement, which is that the value of an entry is this. Like the value of is best friend is true in the specific pod. This is how most people think of cryptographic data. They just have the value of statement. They don't have anything else. But then we added a bunch of other stuff, like the equal statement, which is this entry is equal to that entry. Or the sum of statement, which is that the sum of the two, the entry number 2 and 3 in the tuple equals entry number 1. And this is like a very early version that we had, but you can imagine extending this to something that is powerful enough to essentially prove anything in first or second order logic. And these are our opcodes. As an example, we have the equality from entries opcode, which says, hey, if you have entry 1 and entry 2, you can apply the equality from entries opcode only if entry 1 equals entry 2 to get a statement that says entry 1 equals entry 2. So what we had to do from a cryptography perspective is essentially build a circuit that instead of proving the state transition of a CPU architecture, proves the logical operations on statement is done correctly, right? It's a cryptographically verified theorem prover if you want. Okay, so the second challenge we had is we want to be able to import data from the real world because we don't expect people changing the way they issue data. It was already sufficiently hard to get them to export cryptographic data in the first place. Good luck coming back to them and telling them they did it the wrong way. So what this turns into is you want to be able to turn any verifiable piece of data into a set of value of statement with special metadata. As an example, who signed it, what was the URL if it comes from like a web proof, when was it signed, etc. Right? And then you can further combine these into any other pod using the logic. So what if I want to compute with one of my frog, right? You guys have frogs. I hope you have frogs. If you don't have frogs, you're a loser. You need to go get frogs. Frogs are pod 1s. Pod 1s, as I was showing earlier, was the first version of our cryptographic data system. From the perspective of pod 2, they're foreign cryptographic objects. They're on different curves with different signing algorithms. They're merkleized in a different way. Yet they can be imported via what we call an introduction gadget. So you have this introduction gadget that is going to verify the EDD sig is correct. It's going to store the signer into a value of statement with key underscore signer. And it's going to copy each of the pod 1 entry into a value of statement. And then you get a pod. And the cool thing is now you can take 2 frogs, you can introduce them, and then you can make a proof about them. You can say Todd is more beautiful than the MA mustache toad. That's something you can prove with the system after you have introduced the data. And the first thing we want to do is be able to import emails. We want to be able to import like regular API calls and probably deal with one of the government-issued ID system. But then over time, you can imagine importing things from Ethereum, importing things from virtual worlds, importing bank accounts, receipts, or even like actual mathematical proofs, and keeping generating statement about these. Okay, the third challenge we had is making building easy. This is what it looks like to put together a sequence of logical opcodes, and it's extremely gnarly. Don't ask us why we have strings. It should be pointers. It's a whole story. And making sense of pods or crafting them becomes very tedious and easy to get wrong, right? The users of the system need to craft a sequence of logical opcode to make a new pods, but on top of that, they need to make sure that the statements they get out when they receive a pod actually match what they're asking to be proven. If you get this, you know, all of these logical statements, like how do you, like, it's hard to know whether this actually proves that the person matches the claim you're trying to like verify. So what we did is we put together a little Lisp. It's a logic programming language to create pods and verify them. It's a Lisp because it's really easy to write a Lisp versus other kinds of programming languages. And it has an interactive development loop. Here's what it looks like. So here I'm just making a pod. Technically, this is an introduction gadget because I'm making data out of nowhere. So I say, hey, key age is 26, zip code is such, ID is such, and what I get is a bunch of value of statements, including a magic one, you know, the underscore signer one, which points to who created it. And then I can make more pods out of it. So let's go through an example. Here, I'm going to make a pod that says, I have both an ID card and a pay stub, where the user ID is the same on both, and my age is over 18, and I think that's about it. And I reveal my salary, right? So first what I'll do is I'll look for another pod that has a salary, a timestamp issue, and an ID. And I'm going to reveal zip code salary timestamp issued with the same key name. And I'm going to make some assertions that age is over 18. And then I do a join. I say ID card ID and pay stub ID are the same. The cool thing is I'm going to be able to prove that ID card ID and pay stub ID are the same without revealing the ID. That's the thing that's very powerful about it. What I get out is a bunch of statements. And you kind of have to trust me on this because it's small enough. But the ID is not revealed in the pod itself. The fourth challenge we had is multi-party pod creation. So today, if you're on the right side, like the little smiley guy there, the red pods are private, right? You only see what's in the yellow pod. But if you're the person on the left and you're putting the proof together, you actually get leaked the input pods. So what we want to be able to do is essentially put a box around proof calculation. I'm talking about the formal proof, not the ZK proof, such that the input pods are not leaked across the party, right? And we were hoping to get a demo of this by Devcon, but of course, it did not happen. The rest happened, but not that. So the way you solve this is you execute logical operation into either a multi-party FHE or something like verifiable garbled circuit or co-snark. In order to do this, you also need to crack verifiable fully homomorphic encryption without multiplicative overhead, which is tricky. I won't talk too much about this, but if you're interested, come to the programmable cryptography CLS on Friday. So that's pod 2. It's a system that can import data that is cryptographic regardless of where it comes from, enables deep computational graphs, and then you can export whatever view you want on the data with a succinct proof to a verifier. It's logic-based, both for its claim and its operation, and has a bunch of cool features. It's in active development right now. We hope we'll have a production-ready version by end of 25, and we'll probably go through a bunch of pilots throughout the year. If you're interested to learn more about it, so first, if you're interested in pod 1, which you can use right now to build stuff, it's tomorrow at Classroom B at 2:30 p.m. And if you're interested in pod 2 and PEX, we're running a pretty long and interesting workshop on Friday at 12:30 p.m. at the Programmable Cryptography CLS. So I'll keep the QR codes up for a little bit, and then I'll be done. So thanks, guys.
Thank you so much, Justin. And we have a ton of questions. So look into the questions and start answering them. We have 3 minutes.
Oh, so you're not going to read the question, I have to do the work? Okay, cool. All right, you mentioned first order logic, also second order. Those are not computable logics, they're just computable and enumerable. What am I missing then? Because you're computing for sure. This is true. So our logic so far is a bastard logic. It's a logic that is not actually the kind of logic that logicians use. So an active area of research is figuring out how do we essentially like have a logical system that is also computable in a way that is like as sound and complete as possible. And if you have asked that question, please come talk to me because we're very interested in that. So great question. Running this in the browser means you need to trust the server to serve a non-compromised version of the software. How will this work in practice? Are we going to have an open standard for pod processing? Okay, so if we go down to the level of like, well, you have to trust the software you use, I have a bad news for you, which is it's a problem for all of the industry so far. So the way you'll solve this is the way you'll solve everything else. So I don't think I want to answer this question. What's next? Can you scroll or something?
No, they'll scroll it from there.
I got there late. What is this for? It's for making data useful beyond this stuff that we have right now where we just store them in databases and we sell them to OpenAI. Okay, I think that's it. Thank you.
All right, thank you so much, Justin, for this session. We have some break. We have 5 minutes break. But before you go, thank you for your time. If you're here, you're developing something, we need to move beyond just building the tech and looking for application. I'm building the biggest human layer in Africa. If you want to see how this technology is solving problems, you need to visit Africa or Argentina. Let's do this, and I hope you have a good time in Devcon. Thank you. See you again.
Hey guys, can you hear me okay? Sounds like you can. My name's Heidi, and I'm gonna actually be your MC for the next 3 hours. Over the next 3 hours, we're gonna be talking lots of different things, scaling, L2s, and my favorite, which is cypherpunk. But what's funny about that is that I'm actually from Coinbase, funny enough, so some of you guys might get a laugh out of that, being into the cypherpunk style stuff. Anyways, we've got a really good lineup of people here. But before we talk about that, we should probably talk about where the bathrooms are. If you guys haven't gotten up in a while, go up and stretch. But the bathroom is, if you walk past stage 5 over here and then turn the corner, that's where it is. And then, yeah, one other thing that I want to remind people of is that you can participate in the Q&As as well. So how do you go about doing that? Well, you scan that QR code. Now, if you're privacy-minded like me, you're probably sketched out by QR codes, and that's perfectly fine. You can also access it in the Devcon app, which is what I usually do. And go and ask your questions, and we'll have a Q&A at the end. So, without further ado, I'd like to welcome T-Dot onto the stage, who will talk about autonomous worlds.
Good afternoon. All right, my name is T-Dot. I'm a software engineer at Lattice. Yeah, I'm about to talk about, bring you on our journey, basically building the best infrastructure for autonomous worlds and mud apps. Okay, so I will start by talking a little bit, bringing a little bit of context for those who don't know what mud is and what are autonomous worlds. I will then kind of describe some design patterns that we learned about while we were essentially solving problems for mud apps and how basically we solved them. And then I'll be describing a new system that we're prototyping. You might have gotten a sneak peek already if you caught Alvarez's talk earlier on mud. So yeah, stay tuned. Okay. So if you're not familiar with Lattice, we've been promoting a vision for on-chain games to basically develop properties of a thing that we call autonomous worlds. Who here knows what autonomous world is or has an idea? Okay, that's quite a lot of people. Who knows about mud? All right, that's good. But so we're all on the same page. I'll give my quick definition of it. Essentially, whoa, things are moving. So when I say autonomous worlds, what I mean is like permissionless virtual worlds that are seeded by initial teams who are then joined by early adopters who build on top of it until the plot evolves beyond anyone's single control, and then complex drama and social components emerge. And to enable autonomous worlds, we've built MUD on Ethereum so that world builders could have robust primitives to implement their vision and build fully on-chain gaming loops. And then on-chain games are, well, too expensive to run on Ethereum mainnet, so we needed a cheap chain with big blocks and infinitely scalable DA. So we basically added that feature to the OP stack and deployed it as a chain called Redstone. And on top of Redstone, we're also running free services for mud apps like public RPCs and indexers. And actually, to give you a little context, this is a screenshot of Conduit's public rollup dashboard. And if you look at the top 6 L2s, you can see, except from base, all of these L2s are mostly focused on on-chain games. So these are like all the megagas per second that is here. So all these rollups are ranked by megagas per second. And you can see all of them that have extremely high megagas per second are basically have on-chain games deployed on it. And actually, it's kind of interesting too, is Redstone doesn't have that much transaction per second, but its megagas per second is very high. That means that MUD transactions are actually storing a lot of data on chain, so they're actually quite big. So that's why we needed Redstone, so to have a chain with very big blocks and a lot of gas, and so that MUD apps would stay cheap. So some applications that launched on, or are about to launch on Redstone, if you haven't caught the Eve talk earlier by Hilmar and Justin, but I'll talk a little bit. Eve Frontier is a part of the Eve Online universe. So they designed an incredibly sophisticated world physics and are progressively bringing components on chain over the next few years. You know, they're here for the long term. So builders can basically implement business logic permissionlessly on top of it. So if you missed the talk earlier, I recommend you go back and check it out. And then Biomes is bringing Minecraft physics on chain with new types of creative gaming loops. And they have very intensive requirements to enable multiplayer. They're currently on Redstone mainnet. Actually, most of the gas that you saw on the dashboard earlier is coming from Biome, so very excited about this world. And while these teams develop the physics and they seed the worlds with the origin stories and the gaming loop, it is when people can build on top without permission and extend the world with new experiences that properties of autonomous world really emerge. So we like to call more technical users who extend the worlds sewage hackers, because they get their hands dirty and they need access to lower level infrastructure primitives, such as indexers, RPC APIs to power their applications. And you know, it's like most inhabitants of a city, they don't need, or they don't concern themselves with the sewers, but they're a crucial part of these very dense environments. If your sewers stop working, you're pretty fucked. Okay, so I'll go over some requirements. We want to enable worlds where multiple players can interact with the state at the same time. We want low friction for inhabitants so that they don't have to pay expensive transaction fees. We want to stay EVM compatible so that apps can be compatible with other chains and other tooling that's in the Ethereum ecosystem. And lastly, we want this to be super easy for MUD users to integrate, so they shouldn't have to rewrite their apps or add complex client logic. If you're using MUD, all the tools that we built work out of the box. Okay, so one of the things that we worked on was enabling MUD apps to deploy on mainnet with a future-proof data availability solution. So we actually worked with Optimism to, we designed and we implemented a Plasma DA protocol in order not to use blobs. There's actually a talk right now in the other stage where they're discussing, are blobs cool? We thought blobs are not that cool, so we like blobs, but we wanted something that's more future-proof and infinitely scalable if you had more chains. And so we worked with Optimism and to upstream this in the code base, and this is known in alt-DA mode. And our specific DA layer uses a Plasma-like design so that stakeholders can have an emergency exit hatch where they can challenge data if they believe the data is missing, and you can basically keep the chain running while you withdraw your funds. And if you want to know more about how this system works, I recommend you check the Optimism specs. Actually, a fun fact too is once we decided to launch Redstone, we were doing some load testing and we ended up breaking the chain on testnet because we had too much data. And we started with a very large block size, 100 million gas, and the OP stack limits were not large enough to enable this kind of payload size. So we actually collaborated with the OP stack core developers to raise this limits that was introduced in the Fjord network upgrade. And it was really easy to ship quickly because we control the full infrastructure by running the chain ourselves instead of adding intermediaries like roll-up as a service providers. So it allows us to make custom changes to the services and test potential protocol changes directly so we can observe the effects on application directly before they eventually get upstreamed in the OP stack. And when we started running the L2 chains, so we had to learn how to run the chain and do all that stuff. And we quickly ran into bottlenecks because our sequencer node was busy building blocks and handling RPC requests. So we did some basic things like separating the read and the writes. And essentially, eventually the Redstone sequencer stayed private. We exposed another one that was synced over peer-to-peer. Then that node also got a bit overwhelmed, so we added another node and split them by regions. Now the problem you face, and actually you might have heard Ryan talk about it in indexing, is you can end up with different states if you have a load balancer in front of your nodes. And there's actually really cool ways that, for example, Optimism implemented a proxy D which helps basically keep a health check loop, so you can check that each of the nodes has consistent state, and you remove them from the set if they're inconsistent. You have other goodies like caching and rewriting reorgs. And eventually, we also wanted to have better latency inside of different regions, so we added, DNS load balancing, so you can see here our user is in the south of France. He gets redirected to the closest region, which then goes to our proxy and load balancer and a bunch of nodes. So this is things that we implemented. Another aspect, and if you heard Ryan's talk earlier, you already probably know how to implement your own indexer. But actually, a common bottleneck is experienced by MUD application is when the state grows and usage grows, the initial load of the game can be very slow, especially when it's hydrated directly from a node RPC. So this is solved by loading the initial state from an indexer database. We first released an open source version of the indexer, so apps could index their own world. And we also wanted to offer free indexing for all the MUD applications. And our first indexer implementation was kind of not as performant. It had limitations, so we collaborated with Ryan, actually. And Ryan ended up building most of the indexer that we're actually running now. And it can scale for a whole bunch of worlds. So, yeah. Okay, another aspect that I learned about recently myself is how Ethereum providers, like browser clients and things like that, they make a lot of requests by default before sending a transaction. And if you're far from the RPC server, the latency can add up. Some of these requests, like estimate gas, they're also quite slow because they run the EVM quite a bunch of times to estimate the gas. So we made some optimizations. You can see here, it's just by default, you can be making as many of these requests, and so that ends up pretty slow. So we made some optimizations on the MUD browser clients. So we added a nonce manager, which only syncs with the RPC when you need to. We made sure that transaction context is preloaded, so when you click, you're only sending the transaction, you're not doing a bunch of other things, so that it feels kind of snappy. And we're also caching gas estimates, so we don't actually need to call estimate gas every time, and things like that. But, however you spread read nodes across the world, if you're using an L2, at the end of the day, transaction confirmations will always be the fastest, the closest you are to the sequencer. And you're going to have to wait for the block time before you actually get your confirmation. So if you're running a sequencer in Europe, users in California and Japan are getting pretty awful performance. And the experience playing the game can be very different from users who are close to the sequencer. So what can we do to improve this? How do we scale block building? So one way we could do this is we could have multiple chains in multiple regions. Maybe they could even be L3s, Or, I mean, that could work maybe with Optimism's interop protocol. If we want to bring block buildings very close to the user, but there's going to be a lot of chains. You don't want to be running tons of different chains in all these different regions, especially when maybe your users are moving. So you just want to be loading block building at the edge wherever you need to. So what if we could run block building at the edge when needed, just for a piece of state? And for example, imagine you get matched with different players in your area and you start an ultra low latency game match. And so I will preface this by saying this is probably not the only solution, but this is the one we're currently validating as a prototype. And so I'll try to explain a little bit how this is made. So if you remember the previous here, we're like actually deploying block builders directly on the edge. And we call them points of presence, like for CDNs. And what they do is essentially they act like a full Ethereum RPC, but they only pull the state they need from the upstream. In our situation, the pubs, they just request the latest version of the state. And if we need to write to that state, a point of presence can then acquire a lock on it. And this is handled at the MUD level, because we have static ways of determining, which MUD table the pub needs to write to, and then only that pub can batch transaction to modify that state, and then they can send the confirmations immediately without waiting for the actual chain payload to be built. So pub builders can send in transaction batches to the upstream eventually, just in time before the block get built, and then no other pub builder can modify that state. So, and then you have basic CDN stuff like the state locks are cleared, on least recently used basis. And they're automatically cleaned up once you have more data that comes in and your data has been stale for a while. And then these are other examples of things that you can speed up once you can run them on the edge. For example, when you're estimating the gas or you're managing the nonces. And so you can have extremely precise gas estimates by running them directly on the edge. You can have fresh nonce management when you're syncing it. And you can even do ERC 4337 user op bundling on the edge. And so, I mean, this just accelerates a lot of things. And when we were testing this, it actually ended up getting to a very, very good performance. Actually, I'll show you a little demo. I don't know if I press play, this will work. Okay, cool. So we implemented this game just to demo this prototype. It is multiplayer. Every time you move the fly, this is a transaction that is executed and a receipt that is sent back to the browser. So you can see like all of these 20 milliseconds here every time you're executing a transaction and getting the receipt back. And so I mean, this is still a prototype, but if you want to learn more and get to know, actually test the thing yourself, get a feel for it, you can come to Mud Day tomorrow and actually experience all the games or learn more about how all these things works. All right, thanks for listening. No question yet.
That was a great presentation. I noticed that no one had any questions in the Q&A. Oh, it's coming? Okay. Because I was going to front run you guys. No. Audience first. Oh, man. Okay, I'm going to ask my question then to fill the time gap. Okay, so this seems really awesome and amazing. But given my background, I do a lot of security research. So all I see is, oh my God, scaling extremely quickly. What are your thoughts around security?
I mean, obviously, you have all the security assumption of the Ethereum protocol, which are respected. You know, we're part of the super chain. We're trying to do all these upgrades. So everything that is basically touching the Ethereum protocol has the guarantees of ALT-DA chains from the OP stack. And, you know, all of this is audited or like is reviewed by the OP stack team. And then on the things that we control, then it looks more like Web 2 security, where you have your servers and your DNS and TLS, all that kind of stuff. So you do have different kind of areas, and we have different ways of solving these problems that are more specific to either Ethereum protocol or basic services, hosted services.
Gotcha. I have a lot more questions for offline, but any other questions since then? Okay. I'll go for the first one here. So how are you in the super chain with a custom DA?
I mean, we're not in the interop set just yet, so I guess this would be the kind of slight differentiation. But we're still kind of, so we're not part of the upgrade set, so we don't get the basic roll-up upgrades. But we're in the super chain per se because we're actually using the upstream protocol version of the protocol. We're not running a fork. And so all the code that we run is basically reviewed by the OP stack core protocols.
What's next on the roadmap for MUD? What features are most needed next?
I mean, I can speak for the infrastructure part of things. Yeah, what we're really trying to do here is get to these extremely low latency and get those on mainnet. So we're trying to get, the new indexing. We're trying to get all these things available on Redstone mainnet. And then probably the next thing that we probably will be working on is, integrating interop, so Optimism's multi-chain protocol inside of MUD. So we'll also have some exciting things like this, but this is still work in progress.
Gotcha. Yeah, that speaks to my question of why you joined the superchain. How do you balance the benefits of scaling and the latency optimization against the dollar cost?
Yeah, that's a good question. I mean, one thing we've been trying to do is move towards a more bare metal server architecture. So instead of using AWS's very expensive servers, we're trying to run things on different bare metal providers that are like cheaper and have a lot of redundancy because they're obviously less stable. So that essentially, if a region goes down or a server goes down, if it's not as stable as AWS, the users don't really see the difference. And then basic stuff like bin packing, just adding a bunch of services run on the same machine. So you have all these optimizations that you can do. But yeah, we're still fine-tuning this part, actually.
Okay, we got a question that's really popular. Can it run Doom?
Oof, that's actually a really good question. I think you should come to Mud Day to find out about that.
Can WoW be next? Next question, by the way. That was a joke. You didn't have to laugh. What's your thought on CRDT and CRDT plus blockchain? I'm sorry, I'm not the person to be asking that question.
I think it's an interesting question because it's like CRDT I use if you really want to do like pure decentralization and you care about not having a single point of failure and having all the browsers be able to eventually reconcile the state and things like that. So I guess it would really depend on what your use case requirements are. If you're trying to build a game that is, even if all the lattice servers go down, you can still play the game, then CRDT could actually be a pretty good solution. But otherwise, I'm not fully certain that you can get the same kind of performance and latency that we have when we have these edge block builders.
Cool. Any other question, guys? I got one spicy question here. Oh, nope. Oh. Someone else has another question in here.
This is not a question.
CRDT is, yeah, someone has a point here to make. What is your take on that? CRDT is only for commutative operations, bad for games. Thank you for that spicy question, or opinion rather.
What was the other take you had?
Oh, the other take I had was, I'm curious how you actually see the difference between Chain and all of their, fun mobile app games. I don't know if you guys have played any of them, but they're highly addictive. And you do end up earning whatever tokens in their ecosystems. And they seem to be building something quite similar, probably a lot less complex than what you guys are.
Yeah, I think, so it's quite interesting too, because what we're really focusing here is like autonomous worlds where you bring as much part of you're trying to bring all the physics on chain so it can live without anything on the client, and then eventually can live out, outlive the teams, outlive everything. And so these kind of games that are kind of addictive, they're not really geared for this kind of, long-term view or things like that. You really have the gaming loop, that's all that matters. Whereas here we're trying to have everything be on chain eventually, and that's what MUD is about really, is like enabling all these very complex physics fully on chain.
Gotcha, okay. Thank you. Any other questions? Well, thank you for your time.
Thanks.
Thanks, guys. Give them a round of applause. Come back in 7 minutes where we're going to be talking all about the Arbitrum DAO. Hey guys, so this next session is going to be pretty fun. We've got Patrick here from Arbitrum talking all about his experience with the DAO. And thought I would add this. One fun fact about Patrick is he really likes to play Red Alert. Without further ado, here's Patrick.
Awesome. So just before I begin, who's heard of a DAO before? Raise your hand if you've heard of DAOs. And then raise your hand if you've had a positive experience in a DAO. Some people, but less hands exactly. You know, DAOs are, you love them or you hate them. And hopefully we'll explore that during the talk. So just to get started, what I want to talk about today is the following. Why should rollups care about DAOs? And then I want to get into the DAO itself. What do we mean by autonomy, decentralization, and then organization as well. So I started the Arbitrum Foundation just about 2 years ago, and I'm not a DAO person. I don't know anything about DAOs, certainly when I joined anyway. So I joined the foundation, and if anyone remembers, the Arbitrum DAO rejected our funding. That was a great experience. Then after all that heated, discussion, I sat there and thought, why have we got a DAO? Like, why should I care for this DAO? Why is this DAO important? So I want to sort of answer this question, how I thought about it about 2 years ago. And it starts with how do you govern code, and how do you govern the live deployment of code. So let's start with code. I'm sure most people here are familiar with GitHub. You go on the website, you look at a repo, you look at the code, you flick around, you're like, okay, this is roughly how it works. So you can get an idea how it works. Anyone can read, anyone can figure out what's going on, if you're a dev. Then the next part is, how do you govern this code? How do you decide how to merge code and upgrade the code? So anyone can typically submit a pull request. You look at the code, you find a bug, you fork the code, you fix it, and then you do a pull request. And then typically you have these code owners. So these are the code owners for Go Ethereum. They'll eventually say, okay, that's a good change to the code, I'll approve it, and then it gets merged in. So anyone can contribute to it, and there's this governance process, these code owners who can decide the merge in your code. Now, what's also cool about open source software is that anyone can download the code, run the code, and do what they want with their deployment. So these are the instructions for Go Ethereum. You can download it and create your own local test net. So maybe as a gauge here, who's ever done that? Who's downloaded Go Ethereum, compiled the code, and ran it for your own local network? One person, two people. There you go. People have done it. It's great. You can do your own live deployment. But then the question is, what if there's, how many meaningful deployments are there of that code? And typically in crypto, there's one meaningful deployment. There's only one Bitcoin, only one Ethereum, and of course, there's only one Arbitrum as well. And then this raises a new question. If there's only one deployment of the code, how do we govern that? How do we decide upgrades to the code, and how do we change the code? Now, this is a governance problem, and the first way every project solves it is that it's centralized. So if you think when Bitcoin was launched in 2009, it was Satoshi Nakamoto on an IRC channel. This is SourceForge, so this is the one from 2009 where you can see Satoshi Nakamoto updating the code. He update the code, he'd go on IRC and say, guys, if you're running a node, here's a new version, please upgrade. So it's centrally orchestrated. Ethereum was the same, and of course, all the rollups are very similar as well from the get-go. So you typically start off with centralized governance. But then how do you, get decentralized? So in many crypto projects like Bitcoin and Ethereum, we have this process called rough consensus. And rough consensus is a bit like a game of hot potato. No one wants to take responsibility to decide who upgrades the software. So what you typically do is you get the potato, you pass it around, and you just hope it doesn't land at you. So in rough consensus today, you typically get, consensus amongst the core devs, consensus amongst the token holders, consensus amongst the community, and consensus among, the companies and the dApps and the ecosystem. And once everyone's sort of roughly agreed to say, I sort of want this to happen, you pick a flag day, so you could say the 1st of December, and at the flag day, the upgrade should be activated. So in advance, everyone, upgrades their nodes in anticipation of the flag day. Flag day happens, the upgrade occurs. It's rough consensus. It's obscure on purpose to avoid governance attacks. And also because no one wants to take the responsibility to decide this upgrade should happen. Another approach is on-chain voting. You know, what if you could identify all the token holders? The token holders cast a vote, and they say, oh, I do want to upgrade the software. I'm going to approve this. That is basically DAOs in a nutshell. You have this on-chain voting protocol. You can cast your vote. If the vote passes, then you could, process the upgrade on-chain. Everyone has time to upgrade their off-chain infrastructure, but eventually the upgrade will occur, and then obviously the system gets upgraded. And so that's why, from a software perspective, why DAOs are useful. If it's a centralized approach, rough consensus, then eventually you could have on-chain voting. And that's what DAOs really care about, or at least in Arbitrum. But wow, Patrick, on-chain voting, does that not impact the security of Arbitrum? Because now I have all these token holders that can upgrade the software. And of course it does. But when you think about a roll-up, or any blockchain system, to be honest, there's two parts to the security. The first one is the day-to-day operation. What is the protocol protecting the funds? Is it proof of work, proof of stake, fraud proofs, ZK proofs? What is the protocol running most of the time that protects the assets under the hood? And then there's always governance, 0.01% of the time. Human intervention, social consensus, where we all have to reach agreement to say, oh, it's time to upgrade the software, add a feature, fix a bug, or fix a critical vulnerability as well. And so governance is always part of a blockchain system. You may just say there is no governance, but then there's no way to upgrade the software as well. So governance is always there. You just need a process for it. And of course, DAOs care about governance. And they try to achieve this, voting protocol, diverse population. That's how you protect governance for the software system. So that's, how I understood why DAOs are useful for roll-ups. But what about the Arbitrum DAO? How has it grown over the past 2 years, and what do they like to vote on? So this is the A, in DAO, autonomy. Now, in my mind, and you sort of got this already, the DAO has two objectives. First, the DAO is the ultimate defender of Arbitrum. It's up to the DAO to decide if an upgrade occurs on the system. That's their main purpose. They don't really enjoy that, but they're stuck with it. The second thing they enjoy is that they get to manage their treasury. Back 2 years ago, they were given 35% of all ARB, and you can imagine people on the internet, they like to write proposals, they like to spend money, and they like to have fun. So this is the really juicy part and the really fun part. So over the past year and 8 months, on the forum, there's been about 200 threads that are, specific proposals for the DAO to consider. There have been over 329 snapshot proposals, temperature checks, where people have had to vote. There have been around 50 tally proposals. A tally proposal, could pass or fail, but that's where you spend the money, you take the money from the treasury, or you upgrade the software. And to date, they've spent around 700 million ARB, although a lot of that ARB is locked into initiatives, so not really spent, but allocated. But that's crazy. That activity is nuts. On average, it's 4 proposals a week. I don't know how the delegates keep up, to be honest, because we struggle to keep up, and it's our full-time job. So our DAO is overly active, and they could be less active at this point, work out more meaningful proposals that go through the DAO, but they're alive, they're well, and they're doing stuff. And what do they like to spend their money on? They love incentive grants. They funded crypto legal defense. They have their own independent grant programs. They love real-world assets, blockchain gaming. They like to fund us, the Arbitrum Foundation, They rejected us initially, but we're there now, and they like us. And of course, security audits as well, and a bunch of other stuff. And probably the most important thing in our DAO, and I think it's sort of underappreciated or people aren't really aware, when we started 2 years ago, we made the explicit decision not to get involved in our DAO. We were not going to get involved in governance. We were going to, not write proposals and let the DAO do their thing. And I feel like the first 3 months, from let's say March till September, it's a bit like a game of chicken. We're waiting for the contributors to do something. The contributors were waiting for us to do something, and we never moved, and we didn't do anything. And then around September, and then over the summer, there were some proposals submitted. But by September last year, you know, one delegate put in a proposal for one of the incentive programs. It eventually passed. I think that was, oh, I forget now. I think it was like 60 million ARB or something. It was like a huge proposal. But then the contributors and delegates realized, oh, we can do this. You know, we can submit a proposal. We can discuss the proposal. We can vote on the proposal. We can take the money from the treasury. And only after the proposal passed does the Arbitrum Foundation step in, and we do our best to help them. And I believe that's what led to the success of our DAO to date, because people realized, oh, they really have autonomy, and they can really do cool stuff. You know, in our foundation, we have about 4 people on the governance team. There's no way we wrote 300 proposals. So it's really exciting to see people step up and kick ass. And they are active. So this is like a governance call. They have 47 people on it, talking about funding stylists. You know, that's the alt VM for Arbitrum. Another call where they're talking about ops for governance. This has about 40 people on the call. They ran their own hackathons. They run their own delegate days. Our forum is extremely active. We probably get 20 to 50 posts a day. And actually for the hackathon, the judges for the hackathon, no one works at the Arbitrum Foundation. No one works even at Off-Chain Labs. They're contributors and delegates in the DAO, and they consider themselves Arbitrum, part of the community. And they're judging Arbitrum proposals. I found this on the internet. I thought it was funny. Everyone likes to do Pepe the Frog. Hi, frogs. And they're funding stuff that we have no involvement in. So DevReal Uni got funded by the Arbitrum DAO. They funded their own booth, the Arbitrum DAO booth. They fund Gitcoin rounds, and even like educational programs in Nigeria, and there's a host of other stuff. They're just funding stuff, and then I find out about it 4 weeks later. I'm like, oh, what are these guys up to? Oh, that's a great booth. You know, it's really cool to see people actually do stuff, and we're not even aware of it. Now, after 2 years, the way I like to think about the development of the DAO is that in the first 2 years, or a year and a half, we've done a really good job, or at least, you know, I make it look nice, because we also have lots of mistakes. But overall, I think we've done a pretty good job of enabling the DAO to build their own identity. They are a collective. They recognize they're part of the DAO. They can contribute, and they can do stuff. Now, over the past year, the DAO keeps asking us, the foundation, to be more involved. You know, they're like, oh, foundation, we want your advice. We want you on the committees. We actually want you to start getting involved. And so now I believe we're at a point where we can be more involved. You know, the DAO now has an identity where they're not going to rubber stamp stuff. We're going to give them our feedback, our comments, our opinions. If they want to take it, great. If they don't, they can ignore us. But now I think we're at the point where we can help them more and hopefully get them aligned on a certain direction where we can all kick ass together. But that's taken about a year and 8 months to get to that point. And now, to their desire, we're actually going to try to help them more, which for me is really exciting. Now, what about decentralization? What does that mean in a DAO? So when you think of decentralization, you typically think, oh, let's get the world population and get it in the DAO. You know, that's what most people think when you think of decentralization for a DAO. But the question is, what manner? What manner are we bringing these people to the DAO, and is that even a good idea? And there's 2 ways to think about it. You could decentralize the decision-making process, or you could work for the DAO as well. You know, you could be employed by a DAO and have your income there. So for decision-making, what you really end up with are voting blocks. You know, like any political process, you end up with voting blocks where contributors have a certain view, other contributors have aligned views, and they sort of naturally become a collective, and they sort of vote in certain directions. And I think for decentralization of a DAO, what you really want to do is recognize these voting blocks and try to maximize the participation in these voting blocks to make sure you can always reach some type of decision, either as yes or no, or they are forced to make some type of compromise. And actually, sometime last year, someone made this joke to me, one of the delegates. He said, the Arbitrum DAO has 4 political parties. And I don't know who those political parties are. I have a rough idea, but it's not well defined. But you could find that out. You know, if you're a researcher, you could look at the voting records, the Telegram messages, the discourse, the forum, analyze it, and start to identify who are these voting blocks and political parties in the DAO. And actually, the voting block idea comes from this paper. I have no involvement in it. The paper has 2 great insights. Decentralization for a DAO should be defined by voting blocks, and they have a certain way that measure entropy. But also they highlight delegation in a DAO, so if I delegate my vote to someone else, actually improves decentralization overall. Where normally when you look at that mechanism, you think, oh, does that not centralize it? Because now one party has too many votes. So I recommend reading that. It's a great paper. But most importantly, when it comes to like diversity of views in the DAO, you want to make sure that there's not too many cooks. Because if there's too many views and too many opinions, you escalate the process, it becomes paralyzed, and then you make no decision at all. And everything comes to a halt. But of course, at the same time, not everyone should have the same opinion, because then there's no discussion, and everything, passes. And obviously then, they're not very good proposals. So you want like a bit of something in between. And of course, it's hard to create that. But also, decentralization is about execution. And Ethereum's done a great job of this. So the question is, who is working towards the success of Arbitrum? And right now, we have multiple orgs. We have the Foundation, the DAO, Off-Chain Labs, Entropy Advisors, the GCP, all these committees. And long term, you would like to think, well, if the Arbitrum Foundation disappeared, would the DAO survive and continue? And I would like to think at some point we can get to that, and that's also another form of decentralization. There's enough orgs out there working on behalf of the ecosystem, and there's not a single point of failure. But now this brings me to the important question. How do you get hired by a DAO? And what does the org chart look like? So I put this tweet up earlier this year in January, because I recognize that in our DAO, there's lots of these side gigs. You perform a task, you get 10K. You perform another task, you get 40K. And sometimes you're like, oh, damn, this DAO pays really well. But where are the applicants? Why is no one applying for these opportunities? And obviously, when you ask on Twitter, you get everyone's opinion, which is why I get a good giggle out of it sometimes. So here's some of the comments I got. And the summary is that getting hired by a DAO is hard. Now, there's a lot to read there, so I summarized it. So in the top left comment, he basically says, Paddy, why would I spend 3 months trying to work for a DAO to eventually get hired to then only get 1.5 times my salary? Like 3 months of free, unpaid work, it's too much for a slight pay rise. It's not worth it, no thank you. Don't want to deal with the DAO. On the top right-hand side, the poster basically said, Paddy, the DAO is full of politics. I have to go to the DAO, and I basically have to beg to people on the internet to get a salary. No thanks. I don't want to beg. I just want to earn some money. Then at the bottom, the first poster said, well, the DAO is scary. There's a huge learning curve. There's a scary form. I don't even know where to start. Where can I find these paid opportunities? So then, after I got all those comments, I stepped back and thought, well, what do most people want, like in this room? What do most people want in life? Most people either want a hobby, do something fun, or have a side gig. Today, most contributors in our DAO fit that category. They want a side gig, they want to have some fun, they're just genuinely interested in being in a DAO. The vast majority of people want some formal employment. They want a job posting, they want to apply for the job, they want to be interviewed by a small panel, they want to get hired, have stable income, health benefits, just want to be a normal employee. And the irony is, for the past 10 years in crypto, we finally got to the point where most people in this room can work for a crypto company and have a stable job. I don't know if you were here in 2015, but getting a job was impossible. Today, so many jobs. And now in DAOs, we've basically said, oh, well, let's forget about that. We finally solved the problem of employing people, but you know what, we're just going to go back to DAOs and not employ anyone. But most people want to be employed. And so most DAO contributors, they're actually more like entrepreneurial in spirit. A contributor is willing to go to the DAO, submit a proposal, pivot, 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 get rejected again, then eventually get their proposal passed, and then have the opportunity to run their initiative. But most people can't do that, unfortunately to the people in this room. Most people just want a normal job. They don't want to fight with random people on the internet to run an initiative. And you have to recognize that, which is why DAOs don't get huge, not many people work for a DAO for that very reason. So you could solve this and say, well, Paddy, why not just have a centralized org that can hire people? And obviously that's not the solution. The whole point of a DAO was not to have a centralized org, it was to be decentralized. So what happens then in practice? And so over the past 2 years in Arbitrum, I basically came to this observation where the DAO's job is to create an org chart through popular vote. So every time the DAO wants to do something, they either spin up a new committee, like multi-sig service, the procurement process, treasury management, or they spin up a new org. So we funded, no, when I say we, the Arbitrum DAO funded Entropy Advisors, the Gaming Catalyst Fund, Plurality Labs, and even the Quest Big Grant Program. And that's how org charts are created in DAOs. And then you would like to think in the future, if you want to work for the DAO, you wouldn't go to the DAO itself. You would find these orgs, find these committees, and just apply. Get the job, and then go kick ass. So I see most people working for DAOs via orgs and committees, and not actually interacting with the DAO itself. And that's basically my last slide. I have a bunch of interesting things I find interesting anyway about DAOs. For example, I think this one's probably one of my more interesting ones at the moment. So in DAOs, sentiment changes really fast. 6 months ago, the DAO wants to do A. 6 months later, A is toxic, we should do B. And that overturn window is so interesting to see how opinions change so fast. That's really easy to measure. You could just do an analysis of the text and figure out why. So I've run out of time, so now is the Q&A. So if there's any questions, then I'm down for a Q&A.
Awesome. That was a great presentation on Arbitrum DAO from last year. Now, there are a couple of questions, but if you have any burning questions here for Patrick, please either scan this QR code or go into the Devcon app and just ask some questions using your ZooPass. We already have one question here that is definitely the most highest voted, which is a question that I think many of us have is, how do you actually encourage active participation in the DAO, given that most people simply care about making profits instead of actually being involved in the decision-making process, which can be lengthy? Why should people care?
Yeah, exactly. I think people should follow the money. Most people want to make an income, they want to have a salary, they want to be paid. I think what's important is, most people want to be paid for their merit and not their geographical location. So if you have a skill that you can contribute to a community, you should be paid for doing that. And that's the same for DAOs. A lot of our contributors who interact with the DAO directly, they eventually get a proposal passed and they get paid from that proposal. And you should be paid from your proposal. If you're going to run an initiative, you should be able to make money for doing that. So, it's not an altruistic thing. You just have the right to make some money just like everyone else. DAOs aren't free, they're not voluntary. Trying to make some money if you can.
Awesome, thanks for that. How do you verify that the decision makers really have the expertise to make the right decisions? They may have the votes, though.
Oh, 100%. This is one huge issue for DAOs. So I think one of the problems we have now is not even just expertise, but when you have 4 proposals a week, and now let's say 380 proposals over 2 years, not only do they not have the expertise, but they may also just not have the time to do the proper due diligence. So I think what you really want is the DAO to vote on big, important initiatives, not small grants. For example, if there's a proposal to the DAO for $40K, probably not worth the time of the DAO itself, go to a grant program. What you really want is them to vote on big proposals, but also hire experts. So in our DAO, the DAO has hired the ARDC, the Arbitrum Research Development Collective, and their job is to provide expert advice to delegates based on certain proposals that come along, like risk, technical, or even just economics or anything business. But of course, delegates themselves may not have that expertise, and there's a huge risk in that. And another one is, we don't have it, but you also have liquid democracy. I know that's more experimental, where I could delegate my vote on certain topics to certain people. So that can help, but that requires more participation.
We've got a lot of questions coming in here.
Oh, wow.
Some of them actually aren't appearing right now on the screen, so I'll ask one that's on the screen. What will we need to develop a DAO in a dictatorship country like Burma, where we are not legally able to establish any sort of blockchain initiative, to scale, fund, educate ourselves more about blockchain and DAOs?
What will we need to develop DAOs? I mean, I'm not a lawyer, so it's not really the one for me to answer, but what I would say is, DAOs aren't restricted to your geographical location. They're typically centered around topics. So in our case, we're centered around, a roll-up, a software topic, and that's what people interact with. You've got like Constitution DAO, where it's just, again, random people on the internet that wanted to buy the US Constitution, but then they got rugged by, Wall Street. But they're mostly around, initiatives and not locations. So that's probably the best way I can answer that.
Gotcha. I have a cheeky question here actually too. How do you vet proposals to prevent malicious proposals from being pushed through? But I have an addition to that question, sorry. And that's how do you actually vet your contributors? Because increasingly we're seeing a lot of problems with contributors being not exactly the people you want contributing to your core projects and instead putting backdoors in.
So, I think that was that not Tornado Cash where they got rugged by their DAO proposal, if I remember right?
Yes, Tornado Cash, but there have been several other DAOs that have been rugged like this.
So, I think at least in the technical sense, there's three aspects. One, we vet the code ourselves if it's going to go through because we need to protect our DAO. They have the ARDC, I think is Open Zeppelin right now, that should also vet the code and sort of give a sign off to say, it looks good. Then the third one is also compliance, isn't it? If you're going to get funds to someone, then we take care of all the compliance needs and the legal agreements and everything else. I know someone in the audience who takes care of all of that for us. I won't point them out. But yeah, generally it's, and also the last one is, our DAO has a maximum politeness policy. So if you're not polite, then you shouldn't be involved. And that's done a really good job to make sure it's not toxic.
Interesting. We have one more, I want to ask one more question while we're here. How do you get involved in Arbitrum DAO to become a delegate?
Well, how do you get involved in Arbitrum?
Oh, sorry, I read the wrong one. How do you avoid political groups in the DAO having so much power so that they can block proposals? Sorry, it's the one at the top.
There's two sides of this, isn't there? So I was saying this to someone earlier in the hallway. A DAO is a representation of the values of that community. So for example, if you're interested in DeFi, smart contracts, you'll probably end up in the Arbitrum DAO. If you're interested in, I don't know, something that's completely not Arbitrum, then you'll probably not join our community. So what happens there is you just naturally get these political parties forming. But what you really want is, you want you want voting blocks there to make sure decisions do get made. But you want to make sure they're diluted. There shouldn't just be one party that can veto any proposal in the DAO. And the only way to dilute them is through delegation. And you have to really trust the token holders who you're delegating. For example, we at the Arbitrum Foundation, we can't delegate. So we can't impact how people vote at all. But that really comes down to people delegating in a way that makes views more diverse. But of course, making sure the voting blocks can still exist so decisions can be made. Because otherwise, you're paralyzed.
Gotcha. Thank you. Thank you so much, Patrick.
Cool. GG, guys.
Sorry, there were a billion other questions.
I was surprised.
Hey guys, I'm really excited to announce this presenter. Rose here is from DarkFi, and she's going to be talking about Lunar Punk Endgame, which is very exciting. So I'm going to welcome Rose here onto the stage right now.
Hello, everyone. Oh, good. Thanks very much for coming. Before I start, I just want to get a sense of the attendees. So, how many people here have heard of DarkFi? Okay, it's like maybe half. So I just want to say, to start off, that I won't be talking about DarkFi much, but if you're interested in that and you want to learn more, I recommend that you stay for the talk that's directly after this, where my colleague Amir will talk and explain everything about DarkFi. But today I'm going to talk about Lunar Punk. Who here has heard of that term before? Okay, for those that don't know what it is, if you know what cypherpunk is and solarpunk, then you're halfway to understanding what lunarpunk is. One way of describing lunarpunk is as a synthesis of cypherpunk and solarpunk, which combines aspects of both imaginaries to create a new version which supersedes both. But if you don't know what cypherpunk or solarpunk are, the best way to understand lunarpunk is as a sci-fi imaginary that's oriented around utopian anonymity. So what does that mean? Utopian anonymity is the perspective or conviction that anonymity is something very good for society, and that it could actually lead to a emergence of new kinds of civilizations. The basic idea is that surveillance and a society based on data extraction is a kind of dead, controlled world where society can't progress. Through anonymity, we allow different kinds of societies and new forms of civilizations to emerge. So that's why lunarpunk sees itself as a kind of utopian anonymity. And tools like DarkFi play a role in bringing this utopia about. But the goal of this presentation is not to talk about that. In fact, this presentation has 3 goals. So firstly, I'm going to try to define lunarpunk not through these words and definitions, but actually by showing you a potential future. So this talk is a sci-fi with sci-fi artworks that is supposed to kind of speculate on one possible chain of events and to define lunarpunk concretely by example. Secondly, I want to clear up some misconceptions. So when I first wrote about lunarpunk, that was back in 2021, there was later an animation made of it. If you Google lunarpunk and the dark side of the cycle, you can find the video. And the kind of mistake that I made at the time was that I defined lunarpunk in contrast to solarpunk. Solarpunk was something related to transparency and surveillance by virtue of its transparency, whereas lunarpunk was positioned in contrast to that as a pro-anonymity perspective. The issue with this framing is that it made people believe that lunarpunk was some kind of negative or some kind of shadow of solarpunk, that it was rooted in negativity and skepticism, whereas solarpunk was something optimistic and positive. So that's a misconception, and I want to show you through these images why lunarpunk sees itself more as a utopian perspective. So it's really a story about how can these anonymous tools lead to a world that is better than the world today. So it's an uplifting future. And one of the reasons why lunarpunk is often seen as a negative is because in the lunarpunk imaginary, there's an idea that the nation-state paradigm is overcome. For some people, that idea is suggestive of chaos. So they find it scary and they find it something bad. For lunarpunks, that's a really good thing. So it's the beginning of a new age. It's something uplifting and optimistic. So I want to show you that in the coming talk. Finally, the goal of this presentation is to provide a new image of the future. So we believe that by creating images of the future and by providing sci-fi speculative imagination about where the future could go, we actually make those new kinds of futures more likely. So by providing these kind of images, we compel the future in some ways to move in that direction. What I'm talking about here is a strange aspect of science fiction that you see in many sci-fis, such as William Gibson, cyberpunk, and all kinds of science fictions, where the sci-fi actually precedes, it anticipates the future. So sci-fi has this amazing ability to bring about new kinds of futures and imaginaries. So we believe that one way to reorient the future away from surveillance dystopia is through this effort of speculating on other kinds of possible pathways, and through that speculation, making those pathways more plausible and concrete. Okay, so I'm invoking a lunarpunk called Porrig Pierce, who was a revolutionary who participated in the 1916 uprising in Ireland. It was a failed revolution, but through its failure, it actually brought about the next revolution, which was a success. So this is something that Porrig Pierce said just before his execution. He said, "We seem to have lost. We have not lost. To refuse to fight would have been to lose. To fight is to win. We have kept faith with the past and handed on a tradition to the future." So I'll let you kind of reflect on that. I just wanted to bring that up. I think it's very interesting because sometimes when it comes to the fight for privacy, people become very, very resigned. But in fact, that it's through our efforts, and even when we seem to have failed, we are in fact winning through the very act of defying the surveillance paradigm. Okay, so now we're going into the sci-fi. Sorry for the extended introduction. We begin at the beginning, 12,000 years ago, in the Neolithic Revolution. In those early days, there were many different kinds of civilizations that coexisted. On this timeline, we see the emergence of a particular kind of civilization, the rise of cities and ancient Mesopotamia, the emergence of the nation-state paradigm 5,000 years ago. So throughout history, there have been many different kinds of civilizations that have competed for dominance. So in human history, there's a kind of a rise and fall of different competing civilizational formats. And in this kind of 500-year interval, a particular form of civilization will define that paradigm. So the last 500 years have been the time of the modern nation-state era. But as we move into the millennium, we're coming into a new paradigm, which is different to what became before us 500 years ago, in the past 500 years. So this is the Y2K paradigm shift that we're currently a part of. And essentially, what we're seeing is this form of civilization that has emerged and became the dominant form of society in the past 500 years is breaking down. And a new kind of civilization is assembling itself. Peer-to-peer technology, anonymity, cryptocurrency all play a role in the disintermediation of the nation-state and the emergence of something new. We believe that the next 500 years will be a kind of new dark age. That sounds scary, but it's actually not. It's actually a really good thing. So what does it mean? The new dark age will be a time of spiritual growth and development. It will be a time of re-decentralization, where we will see a global reconfiguration of power, and the existing nation states will decline, and something new will be born of that. So it's a fertile age where the new kind of society is taking root. So this is the projection toward the next 10,000 years of human history. So the basic contention is we're entering, with the Y2K paradigm shift, we've entered a kind of new dark age. This is a period of around 500 years where we experience a time of great spiritual growth. The spiritual development that we are set to undergo in the next 500 years will lead to a new renaissance. So that next phase, 1,000 years in the future, will be a synergy of the 500 years of spiritual development with the new technological capacities that will come about as a result of that shift. So the goal in the next few slides is to sketch out like one possible timeline of events that could lead to this phenomena. And it's a quick sketch, but I hope it's going to excite you and show you the possibilities. As you can see here, once we go through this Renaissance period, we enter kind of a neo-Roman cosmic expansion where like life and human life, animal, plant life expands to the cosmos, eventually ending in a great human speciation event where we'll see a enormous diversity and plurality of different kinds of society, but also different kinds of post-humans that have evolved to different planetary conditions. Okay, so this is, if you can see the date there in the future, it's 2033, so it's the near future. Here in this image, you can see lunar punk fighters. They're in a 3D weapons production facility. So this is a little snapshot of, the coming storm, where global power begins to break up, and organized factions start to assemble and become the seeds of the new paradigm. So you can see that there's like forests creeping in. They represent the reforestation of society. 3D printed weaponry is going to be a major defining force in this disintermediation of state power. Anonymity in cryptocurrency is also playing a big role. At the same time, we will see the rise of regional identities and network states. So these kind of new crypto-enabled network exit civilizations. So I think we're going to see both things at the same time. So the regional identities are pre-existing, in some cases like indigenous identities that have a strong sense of rooted locality to a place. So you might have the re-emergence of some of these ethnic groups that have been misplaced by the nation state or silenced by the nation state. So they're going to rise up and they're going to start to assert autonomy within the next 100 years. At the same time, the network states are going to rise, so we're going to have both things happening simultaneously. The network state is something more cosmopolitan, so you'll see a lot of different ethnicities coming together around technology, around space exploration, around longevity, and other kinds of like guiding topics. So you're going to have both of these forms. This is going to eat away, wear away at the nation-state paradigm, and also provide the seeds of the next phase. So now we've skipped a little bit further into the future. As you can see, we're like over 200 years into the future. So there are a series of events that happen. One is, this image kind of indicates the changing spiritual landscape. So we can see here kind of robed, neo-Druidic female figures on an island, Skellig Michael. For those that know it, it's an island that was home to monks within the previous Dark Ages. In the new Dark Ages, it becomes home to a new spiritual order that holds nature as sacred. but sees science and technology as a way of connecting with nature, kind of a sacred act of worship and reverence. And so in this new monastic order, we start to see technologies emerging that more closely resemble organic life. And this particular monastic order is very interested in quantum biology, but also in biology in general, genetic research. So you can see some of the life forms that they've engineered in the corner of the screen. So as they get deeper into this quantum research, they begin to uncover new forms of weaponry. I mention this because I don't want to give the impression that the utopian future we're describing is one where there's no conflict of any kind. In fact, we expect that it'll be more the case that there will be new sovereign communities, and those communities are enabled to be sovereign because they're able to back up their sovereignty with weapons. That doesn't mean it's going to be necessarily a state of war all the time. You know, it's just a case of a kind of armed neutrality. So it's like there are new monastic orders, new spiritual orders. There is societal speciation at the level of culture, like many different societies existing side by side. They're autonomous, and that autonomy is backed up with weapons. Okay, so at some point in this timeline, there is the discovery of alien life. That is like a huge event for humanity, in the same way as the Copernican revolution like recentered man from the cosmos, and you know, was it like a shock that changed the trajectory of civilization. In the same way, the discovery of alien life will shock humanity and force a new perspective upon us. I say here, like, there's another idea, which is like maybe we're going to discover something like evidence of an old civilization on Mars. So there's theories about this, that actually Mars was home to a giant nuclear explosion. There's evidence in the minerals. So people are like, maybe there was an advanced civilization that blew itself up with nuclear. The discovery of something like this on Mars, along with alien life, could bring about a new perspective that is, you know, begins to revere nature and life as something fragile and special, and that should be protected. So the idea is like feeding into this new spiritual perspective that has emerged in the Neo-Dark Ages. You have this like this new reverence for life, because you have a cosmic perspective which shows, you know, the kind of devastation of nuclear war on Mars. That's just one scenario. Okay, so back on Earth, we've seen the results of this new spirituality that has emerged. Many different civilizations. This one is a Neo-Celtic civilization that loves nature and that has been reviving extinct species. So they've started all this research into biology, and quantum has like borne fruits. So they have this whole new hyper biodiverse ecology of extinct plants and animals that have started to cohabit with the living. So this is happening, and through that research, by amassing all this new genetic knowledge of the extinct plants and species, we actually make a series of breakthroughs in our understanding of nature and biology. So this is, you know, immensely useful, and it leads to an evolution in plant-animal-human communication. So again, we're nurturing this deep reverence for nature through this deepened relationship to the plants and animals that we cohabitate with via this like improved communication. Okay, so I put this here. This is just a quick sketch to show that at this moment of history, we're in like 2500 to 2800. We're in the Neo-Roman era, like just after the Neo-Dark Age. So this is a time where, you know, the political structure of the world has been basically decomposed into more older regional identities and the newer network state type exit civilizations that are more cosmopolitan. So you have these things side by side, and they have strong trade routes and connections. So they're not isolated. They're collaborative, and it's possible to exchange ideas and materials through this like global confederate system that has like healthy trade routes. I emphasize that because there's a misconception that you can't have like global cooperation at the level of trade and economy without nation states. That's a misconception. We've been doing it for like thousands of years. So I'm running out of time, but I'm going to like fly through these. These network states, they were focused on the space exploration. So they've built these centers in the Atlantic, which are like launch pads where they've been they're able to explore like the space. So, that's the benefit of those network states. Then we see the first signs of successful terraforming experimentation on Mars, which is the introduction of these like new genetically modified mosses that have been discovered by the civilization that's really into reviving extinct life. So terraforming on Mars is starting to go well. Eventually we move the humans and the animals to Mars. In the year 3740, we begin to see the first signs of speciation. So the humans and the animals and the plants that have migrated there are already starting to adapt to the low sunlight and to the thinner atmosphere that they experience on Mars. Finally, I had to put the moon in there because it's lunar punk after all. The terraforming has also been adapted to the lunar surface. So we're really spreading life throughout the cosmos. Finally, 10,000 years into the future, the humans have expanded into exoplanets. This is the point where we start to see the extremes forms of speciation, where humans and animals begin to diverge rapidly. Along with this hyper-diversity at the level of society. So that's a quick sketch of what the lunar punk future could look like, or one possible future. A huge thank you to ZK Armour, who made all of these artworks. He worked really hard on them, and they're so beautiful. So thanks so much to him. He does all the art for all of DarkFi. And yeah, thanks very much for coming to the talk, and I'll pass on to Amir, who's coming after me. Thank you.
That was a great presentation, Rose. And I actually made a big mistake at the beginning of this by not introducing you first and saying that Rose can actually basically bench press her own weight. Now, if you can hang on just for 1 minute here, we've got a couple of audience Q&As. So there's a pretty big question here that's upvoted, and that's, why is DarkFi an alternative L1 when it could instead be a properly private Ethereum L2? Its weaker security scares me. Do you have any takes on that, or should we wait until the next?
I'm happy to answer that. I'm going to start with the second thing, which is about the security. The plan with DarkFi is to do a merge mine with Monero, which basically means we're bootstrapping off the security of the Monero blockchain. So I don't see it as being scary or like weak security or anything like that. That's the first thing. Second thing is, why are we in Alt L1? The main reason is our focus is on anonymity, privacy. So we spent all of our development effort on that, and we weren't particularly opinionated on which, like, are we in L2, do we use IBC or any of that? That's not our focus. We know that there are many projects who are working on decentralized trustless L2s, IBC, other kinds of like trustless bridging. So we're just letting those projects work out those very difficult problems for us while we focus on the ZK ecosystem. And then whenever, like, and please, if you have ideas on this, please talk to me. As soon as there are available trustless bridging, like trustless L2s, decentralized L2s, and or IBC that can work with the UTXO chains, we'll adopt them. We're not fixated on being an L1. We'd happily, we want other blockchains to connect. We want to connect to them. So we're open to it. Come talk to me if you have ideas.
And I think we have time for one last question. Does DarkFi see AI as a friend or foe to the mission? And it also ties into that last question you see here, where how do you foresee the rise of machine intelligence in the Lunar Park timeline?
I see AI as a kind of like demon that has like grown off of the surveillance and the collection of like the mass data harvesting. So it is this kind of like scary evil demon that is like based, like grown on surveillance, like fed on our data. But that's not to say that, it can't also help us in interesting ways. For example, maybe you guys know Dr. Nick. He's a person who's very optimistic about the AI. So like if you talk with him, he'll give all kinds of ways in which the AI can benefit societies. So my main issue with the AI is like its origin, but I'm not saying that it can't be used for good stuff. And maybe in the Lunarpunk timeline, it helps with these new experimentation into like hyper biodiversity and space exploration. Maybe AI plays a role in that. Maybe it plays a role in the human-animal communication. There's plenty of potential there. And I think it's probably one of those things that forces the coming like shift toward a new civilization. It's like one of those like transformative technologies that's going to reconfigure the new paradigm.
Awesome. Well, thank you so much. Rose is going to be stepping off stage now, but I'm sure all of your other questions you can go up to her and ask her. Thank you.
Thanks very much.
Okay, I will start now. So, my name is Amir Taki. I'm a free software developer for 20 years and a core Bitcoin developer from 2010 to 2015. I wrote the BIP1. I made the first UK Bitcoin exchange. I'm 10 years plus working on privacy technology. I made the first privacy implementations in Bitcoin, CoinJoin, stealth addresses. In 2015, I joined the YPG and I fought on the front line against ISIS. I was 3 years working in Syria for the local revolutionary government. And in this talk, I'm going to talk about DarkFi. So DarkFi is an L1 for anonymous smart contracts. It's like, in the same way Monero is the anonymous version of Bitcoin, DarkFi is the anonymous version of Ethereum. So I will also today talk about the app that we're building for users, like what are we putting into users' hands. So let's begin. Let's have a look. So, okay, that was actually, let's just go back here. So let's start with the name, DarkFi. DarkFi's name actually comes from 2013, where there was a project that we founded called Dark Wallet, and it was founded by me and Cody Wilson, who invented the 3D printed gun, by Vitalik and a group of Spanish hackers. And you can actually go on YouTube and you can find the initial video, which is an important piece of Bitcoin history. But the name itself comes from a speech by the director of the FBI. And the director of the FBI said that if people begin using cryptography widely, if everybody starts adopting cryptography, it threatens to create these dark zones in the internet where law enforcement cannot penetrate, the going dark problem. And the quote is, he goes, you know, the law has not kept pace with technology, and this has created a public safety problem. So you might go, okay, well, why do we need the cypherpunk values? You know, cypherpunk values, what are they? You know, number one is anonymity. And I'm not talking about when I say, you know, people go, oh, our project's private, you know, like, oh, we provide user. No, I mean strong anonymity in the sense that if they come for you, they cannot find out who you are. You are completely protected. And there is no gray zone there. There is only the project, your project is either anonymous or it's not anonymous. Also, censorship resistance. What that means is 100% pure free speech. You can say whatever you want and nobody can shut you down. There is no compromises with free speech. It is absolute. Third property, sovereignty. What that means is we run the infrastructure. We own the infrastructure. They cannot shut it down. It's like in our hands, in the hands of the community. So why do you need these things? Well, imagine a scenario where an authoritarian government comes into power and they begin oppressing your friends and putting them in jail. And you need to mobilize to create a parallel free society. What do? You create an anonymous on-chain DAO. You communicate anonymously. You raise funds into that DAO. You allocate resources to people for different projects. You coordinate the work using anonymous infrastructure, anonymous task managers, and then people get paid a salary, they get paid money, they need to cash it out, they need to do OTC, they need to trade it so they can pay for stuff, and people using this infrastructure are able to mobilize. And you know, what I'm talking about is not a theoretical thing, it's a real thing. The time is coming, and we all feel that within the next 5 years or so, there is going to be some major event of huge macro, economic or political significance. Right now, they are putting devs in jail for making anonymous software. And when they are doing that, they're trying to frighten people into compliance. And it's like, you know, if I say something and, you know, I'm just saying, you know, commenting about something, and I suddenly go, or someone says to me something, and I suddenly go, oh yeah, blah, no, rah, and I react really aggressively, and you go, whoa, why is he reacting so aggressively? That is not a sign of strength. That is not a sign of power. So when they are oppressing people and putting people in jail for making anonymous software, that is not, that we are not meant to back off from that. That is a signal of where they're weak, and we're meant to hit them harder. We're meant to push further. And you know, people always go to us. Oh, you know, what about this project? You know, what about this other project? You know, DarkFi has no competition because, you know, there's all these projects go, oh yeah, I'm a privacy project, blah, blah, blah. Join our Discord, you know, check out our Google Docs. They are putting people in jail. They're putting people in jail, and if you are using Discord, then you are obviously not afraid. And if you're not afraid, you're probably not doing anything important. You know, in England, I literally saw the other day a guy, he went to a protest and he just held up a sign and he said the politicians are corrupt, you know, BlackRock, etc. They put him in jail for 3 years. And I even read now that they are reducing the time served for criminals in jail from 80% to 60% to make more space in jail because they expect more people to go to jail now, more higher capacity because of these new speech laws. How crazy is that? They're putting people in jail. And like people are really suffering right now. People, like the elites are trying to divide society, separate people from each other. They're actively hostile to the interests of the people. And yet cryptocurrency, as technologists, we have this huge power of cryptography, and we have not, after billions of dollars of VC money, you know, the VCs, they get the money from central banks, you know, they get it from their friends in Wall Street. And, you know, they don't put it into disrupting the status quo. But then this industry, which was meant to change things, to have an impact, goes to those same guys, ends up, you know, kowtowing before them, trying to ask, oh, please, sir, give me some funds. And that's why we haven't been able to deliver. That's why projects are going, join our Discord, you know, check out our Google Docs. We haven't even built a chat app after so many years. And now you're going on Twitter and you see a project going, oh, I think the future is AI conscious agents communicating, allocating resources. It's like, have you built any of that? No. You haven't built anything. It's just talking rubbish. We haven't built the basics that people need. And then people go, okay, you know, DarkFi, what you're building, you know, what about criminals? What about the criminals? You know, everybody, all the movies is all about, like, you know, mafias and criminals and gangsters. The reason why people are you know, like, watching this stuff and they're going, oh, you know, I actually sympathize more with the criminals because everybody feels that we're under foreign occupation by a colonizer. That's how dubious the law has become. The law no longer holds moral weight. And they turn around and they say, you know, for us people who are trying to gain our freedom, they go, oh, that's criminal. You know, oh, what about criminals? They invented that label and they put that on us. And we're playing the rules of their game that they invented. If anybody's the real criminal, you know, they're the real criminals. 2 million people died in the Middle East for absolutely nothing. Absolutely nothing. 2 million people died. Shocking, absolutely shocking. Things need to change, and we are technologists, and in our hand, we hold cryptography. I study a lot of math every day, and, you know, when you're reading the math, you discover mathematical truths, and you go, oh, that's very interesting, and you take these mathematical truths and you piece them together to create cryptographic schemas, and we use these schemas, you know, to defend society from attack by nation states. You know, that is magic. If anything is magic, that is magic. We are like wizards casting a spell. You know, they used to say that violence cannot solve math problems. That's what that means. no matter how much violence the state uses with their man-made laws, they cannot defeat the power of the cryptographers. When we wake up and we realize that power, we will become invincible, because the trajectory of history, when a technology whose time has come, it can't be stopped, no matter what laws they try to do. We have bought some time, but do not be under the illusion that governments are our friend. Maybe the SEC has eased up on breathing down our necks, but they're not our friend. The crackdown is coming. We have to use this time to build and to make governments irrelevant. So, oh yeah. So, you know, that's people waking up, realizing, you know, that things are changing, and this is the, you know, the lunar punk fight. So, yeah, I just, you know, like, okay. Because when we're doing cryptography, we're summoning the power of Mother Nature. That's how powerful that stuff is. And, oh, okay. So this graph is actually, well, we don't need it. We just talk about this. So, you know, anonymity and surveillance are in a feedback loop. The more that they crack down on anonymity, the more it validates why we need anonymity. And the more it pushes us to understand this is the value in cryptography. Cypherpunk, you know, anon, P2P, censorship-resistant, sovereign infrastructure for the people, for the community, to allow us to build the new paradigm, the new economic paradigm. And the more that we're successful, the more that they're like, oh, this is disrupting the status quo. This is the thing that actually changes things. And the more that they crack down. That's the feedback loop. And so, yeah, you see it there. And so that's why this split, DarkFi, RegFi split, whether it's 5 years, 10 years, it's an inevitability. It's coming at some point. And so for example, Tornado Cash case. The reason they put the Tornado Cash people in jail was because they made a mixer, but it's not how they put them in jail. In the same way, it's not how they put Al Capone in jail. They put him in jail using the taxes thing. So with Tornado Cash, it was actually three things. The first was they had access to their internal Signal chats. And so they were able to say, oh, you said this and you said that, so therefore you're like the CEO. So when we were building DarkFi, we realized that we needed to have this completely anonymous communication system, P2P, where all the messages are unlinkable. Nothing like that exists. So that if they come later with chats and they go, oh, you said this, then we go, well, no, I didn't. It can be absolutely anybody. Anybody can assume that identity. And we use cryptography to, you know, ensure that we have spam protection and, you know, that it's functioning. But we've been using that for several years to do the DarkFi development. And people, they always go, oh, but, you know, how can you do things anonymously? Well, you know, culture does not come from Reddit. All the internet culture came from 4chan. That's like, when people are in free speech zones, that's when they like really explore, you know, they explore thought. And that's when, you know, people are willing to like think critically rather than just trusting authority. And we need that more than ever. And we built technology in the 90s, and we were all anonymous. We'd just join an IRC channel, and we start coordinating, sending patches. How we've got into this situation now, where everybody's like, oh, but you can't run the internet with people being, that's a psyop. They've psyoped us into thinking everything have to be like, you know, real name on Twitter with a blue check mark. That's not how it was. The internet wasn't even built like that. The internet was built by like people mobilizing together. So anonymity is the real deal. And second thing with Tornado Cash was they had a DAO. And the DAO, they had like, all the people had tokens in the DAO, and they go, oh, well, you've got this amount of tokens, therefore you're like a board member. So then we were like, okay, you know, and we had this experience with Assange DAO, where people don't know, but Assange's case was bankrolled by Assange DAO, which, you know, raised 55 million to free Assange. That was done by the crypto community. But when we did it, we had this DAO where all the members were completely transparent. And so it just killed the DAO, because it's a DAO to like free a political prisoner by all means necessary. And everybody's like, oh, well, you know, like, I don't want to act in a DAO. I could go to jail. I'm just some random dude. If I go to jail, nobody will hear about me or care about me. So, and then secondly, the DAO was participating in an auction. So the fact that the treasury was public just broke the game theory of the auction. In 2020, 2021, everybody was talking about squad wealth, DAOs, the future organization, you know, of Ethereum, of blockchain, you know, to mobilize community. That vision never came to pass, and instead it just went into like DeFi, degen, you know, nihilistic shitcoinery. And the reason why I think that didn't happen is because we were missing the adversarial, you know, anonymity in DAOs, where DAOs can't do anything important. They can't change things if people, they can't like have an impact on politics if people are completely exposed and vulnerable. So, you know, like, DarkFi built the world's first anonymous DAO, the only anonymous DAO that exists in the world. That infrastructure exists on DarkFi. And the third thing about Tornado Cash, they ran infrastructure. We've built everything ground up, you know, completely sovereign infrastructure, P2P task managers, everything. And you know, they're telling me I'm running out of time, so, you know. I'll just talk about the UI, because, you know, when I watch movies, like, okay, Silicon Valley, they've got this broken paradigm where they, you know, try to capture as many normies as possible and tax them. They're like, oh yeah, people are stupid. We just need to get loads of stupid people. And crypto people have fallen into that trap, where and that's why I read an article recently. It said Gen Z does not know how to use a file system. And it's indeed, like, when you go on the Mac computers and you look at the file browser, it doesn't expose the file system. You can't access it. So it's like, literally, not only are they designing the software for stupid people, it's actually making people stupid. And we need to create software, the vision of the future that we were promised in the sci-fi, in the movies in the 90s. And instead of trying to copy, you know, Silicon Valley, you know, like all these garbage delivery apps that are made in Electron slop, JavaScript, and they're just shitty and they lag. Like, why do we think that is the authority? Why are we trying to copy Google? Why are we not building actually cool stuff? Why are we not building the things that people who are being oppressed actually need? That's why people is looking at cryptocurrency, guys, it's a scam. We haven't built the basic tools. Everybody's talking about very fancy stuff. We need to actually put the things that people need. How come DarkFi project there are projects which have 20x to 100x of our budget, and they have not even built 20% of what we've built. We've built much more than other projects, which is a small project. How is that possible? That should tell you a lot about this industry and how this industry is operating. So I just go through some of the stuff. You see, you've got OTC swaps, ZK compiler, you know, the consensus algorithm, you know, chat, completely cross-platform, Windows, Mac, Linux, Android, iOS. And lastly, to wrap it up, you know, they call us criminals, but they're the real criminals. And in the end, history will be the judge of our actions, and history will absolve us. And anonymity is offensive. It expands spaces. It expands the territory of freedom, as Satoshi said. Privacy is not simply a normie. You know, people go, privacy is normal. Privacy is special. It's something we strive for, we struggle for. And this is the dark forest, the internet rewilded with cryptography, you know, is how we mobilize to change things. We are not criminals. We are forest rebels. And this split is happening, and cryptography is magic. Crypto regulation is an open and official provocation against liberty and sovereignty. All who advocate for it are domestic enemies of the people and must be absolutely opposed. The right of the people to keep and deploy cryptography shall not be infringed.
Thank you so much, Amir. That was a fantastic presentation. Amir, there are 1 billion questions for you on the Meerkat app, so...
Just come approach me. I'm very approachable afterwards. You know?
Thank you so much.
I'm around.
Up next, we have Ash, who is with Taleo. And we have Ash, who's with Taleo, and she's going to be talking all about MPC tools, which is really exciting. So stick around.
It's good? Yeah. Hello. Wow. Thank you for the introduction. That was quite, I think it's, I should have wrote to someone earlier to ask if I don't go after Amir, because like it's really hard to follow somebody who's so full of energy and so full of like good ideas and yeah, principles that we should follow more and more. So yeah, I will talk to you about MPC, basically, some of the tools that can provide some of the privacy expectations that the cypherpunk values might actually benefit from. I'll give you an educational tour of MPC. So from auctions to ZK, my A to Z. I don't know if it works. Is there a way, sorry. Is there some special trick? This? Yeah. Okay. Hello. So I go back to the start. So yeah, I want to give you a bit of an overview of MPC from A to Z, which if you know about MPC use cases, it's from auctions to zero knowledge. And so one thing I wanted to start by, and maybe this room kind of appreciates this, is that cryptographers are not cypherpunks. And I think I come from a background of cryptography, and there is a tendency in the cryptography community to think that because we build the tools that can, you know, help us exercise the freedoms and the cypherpunk values that we want, we do feel like we are some sort of rebels. But after quite some time now, I kind of realized that's not actually the case. Mostly what people, like what the cryptographers actually like to do is push symbols around to try and make some proofs of security and feel smart. And so this is great, and it's really cool that we have secure protocols, but it does not make them cypherpunks, and it does not result in the sort of freedom tools that the cypherpunk values maybe need, and the types of things that Amir was talking about just now. So yeah, cryptographers are not cypherpunks, and this is why I kind of put it in this session, in the cypherpunk session, rather than the applied crypto track. And so I think in building kind of freedom tools or, you know, privacy preserving tools, it's important to kind of understand some of the cryptography. So yeah, this is why I want to give you some view of MPC. So what has MPC been used for? And first of all, does everybody know what I mean when I say MPC? Okay, 1, 2, 3 people. So MPC stands for multi-party computation. Is there anybody like who has absolutely no clue at all what multi-party computation is? Okay, one person at the very back. You're too far back to... no, but anyway, MPC is used for computing on encrypted data. So it started in the 80s with coin flipping, mental poker, comparing integers, small things. And essentially what it is that, you know, a user, Alice, who has some data in her local device or in her machine, and whatever machine, she can secret share it to a network. And this network communicates, nodes in this network communicate to do computation on her encrypted shares, and they produce a result. This is it, essentially. And so the first large-scale kind of practical example of this was the sugar beet auction, which was run in 2008. And this was a double auction to determine the market price of sugar beets. It was an MPC run between farmers and a sugar processor and researchers in Denmark. It was super nice because everybody agreed that this was kind of needed and useful. The farmers didn't have to reveal how much they were willing to pay. The sugar processors couldn't, take advantage of farmers, and everybody kind of won. So this was a super nice example of an auction that was run in MPC. Something that could have benefited from something like this is, let's say, the Constitution DAO, who lost an auction because they revealed how much they were willing to pay, and their competitors could see how much there was in a public wallet before. Another one was the Boston wage study, so identifying salary gaps across gender and ethnicity. So this was done in Boston. They did MPC, so like a private computation across census data to try and analyze whether there was a disparity between wages across genders. Naturally, they found that there was. And they found, I think it was 30%, maybe it's too small here. Oh yeah, it was 30%, I think, in 2016 when they first did this study. And they did it again last year, no, 2023, yeah, last year. And it had decreased to 21%. So by doing this kind of study, at least you become aware of some problems, and then maybe you can actually start to try and solve them, which is quite nice for society. There was also an Estonian student graduation. So I don't know if you noticed, we are also doing a bit of a tour of different countries here, and these countries are where a lot of the main MPC researchers are actually from. So it's kind of interesting, also geographical tour of MPC. But this study was to try and determine if the dropout rates in IT studies were due to people working at the weekends, if their part-time jobs were interfering with their studies and causing them to drop out. And this was particularly important in Estonia because they became much more technologically relevant country, and they needed a highly skilled IT force, but they had high dropout rates, so they were really trying to increase the education of IT workforce. They actually found that there was no correlation between these two things, which was a bit sad for the study, but at least we got a nice example of MPC out of this. So it was run between the Ministry of Finance and the university. So another one was, then things started to turn a bit weird. All of these things kind of had nice societal implications, but then the tooling and the MPC protocols became a bit more efficient, and they started being picked up by big tech. And Google had this experiment with MasterCard, I can't remember what year, 2017-ish, 18 maybe, where they wanted to achieve the holy grail of advertising. So this was the headline at the time. And so Google, as you know, has a very can't compute together. MasterCard would never be willing to share people's information with Google just in the clear, because it's first of all illegal due to whatever privacy regulations and consumer protection regulations, but Google also would not be willing to share their information with MasterCard. So they had some sort of blocker where they wanted to get around, and they were like, okay, we want to compute on each other's data, but how can we do this in a legal way? So they did an MPC between some Google and MasterCard to do some aggregate statistics. So saying, I show you an advertisement for some privacy bracelets on your browser. Did you actually go to the store and buy privacy bracelets? Or how many people went to the store to buy privacy bracelets after they saw this ad? So this was the kind of thing. And then another one, WorldCoin iris scanning. So this is maybe something that you've, actually now it's called World, I should have updated this. But this is where an orb scans your eye. Kind of start moving towards the dystopian, maybe I shouldn't say this, but realm where people are kind of doing MPC to sort of sidestep regulation. And so I think the cryptographer point of view is a bit okay, there are problems in society and we have privacy issues, just throw MPC at it, just throw some crypto tools at it, and that's all fine, your problem is solved. But I don't think this is necessarily the case, because with the Google and MasterCard example, there was really kind of a lot of, not uproar, but like discussion at the time about whether this is actually good or not. Like, is it good that now Google and MasterCard can collaborate on our data? Okay, sure, I can't be singled out, it's not my data necessarily, but like, as a group, we all kind of suffer because Google has more power. And so this is a bit questionable. So it's not really like just throwing MPC or just throwing cryptographic tools at a problem doesn't necessarily solve the privacy issue that kind of underlies the whole thing. And so the question then, I mean, like, I think, is it possible to solve these things? You know, like, how do you start to think about solving privacy issues or like, you know, adhering to these cypherpunk values with cryptographic tools? And there are some super nice examples, which maybe you have actually seen at this venue. So one of them is from Cursive, who are a small team who are building privacy-preserving applications. And they are doing private proof delegation. So this means that actually you have these badges or some stickers or some CoSNARK bracelets or whatever. They're downstairs in the main hall just after the registration. You can go. And essentially it's a chip that you can tap with your phone. You can enter your socials, and then when you tap other people's chips, you can do a private intersection of your common connections, so the common people that you've met and tapped, and then you generate a proof on this private intersectional conference style. But the reason that this is interesting is because, you know, as things become a bit more complicated, the proofs get big. And actually your phone gets slow. And you know, these things need some libraries for verification and proof generation and all sorts of stuff. So sometimes it becomes a bit restrictive to actually do proof generation on your phone. So then an answer might be, well, why don't we actually start delegating proofs? And you see this a lot with, I think, the development of proof markets. So like all these proof markets started popping up over the last years to say like, ah, hey, we can, you know, have some pure beefy machines that will generate your proofs really fast for you, which is great, but like if you have any sort of sense of privacy at all, this is terrible now, because now you're just outsourcing all your private data to this server who will generate proofs for you very quickly, but yeah, you don't get any privacy. Here, you outsource your proof generation, but you do it in a secret shared way, like in this MPC way, and you generate the proof over those secret shares. And so this is being done now downstairs. Not downstairs, but like in the internet. You can see it downstairs. So yeah, this just happened yesterday. And when I say actually you can outsource this to a network, this network is not this mystical being in the sky as it has been for the past 20 years. Now it is actually live. So there's one network that is run between us, Tatseo, the Cursive guys who built this nice cryptographic connections app, and the PSE group. So each of us are running a bunch of nodes that are generating these proofs on these secret shares. So yeah, go down and see them if you want to actually feel MPC in your hands. There's also actually an MPC exhibition that you can learn more of the history. So yeah, actually what they're doing is collaborative snarks, generating collaborative snarks, which is just generating zero-knowledge proofs in an MPC network. Currently, they are using our tooling actually to do this, which is available for CIRCOM. So if you're used to building CIRCOM circuits or Noir circuits, which is up and coming and getting lots of hype this week in particular, now you can use our tooling to do the same thing, but in an MPC environment. So yeah, that's snarks. And so yeah, all the stuff that you will generate here are collaborative snarks. And so how is all of this stuff actually leading to these kind of new, nice things that are not just getting us around regulation, but like this actually cool solving privacy problems kind of tech? And I think the most interesting thing that MPC is kind of enabling now in this blockchain world is this private shared state. So you have these private blockchains or L1s or L2s like Aleo and Aztec who now have zero knowledge smart contracts, and they have like private state and sometimes public state, and you generate proofs on your private state and you can do stuff with the public state and interact. And this is nice, but in a sense it's a little bit limited because the zero knowledge proof is just a statement about a fact, and like it's very difficult to actually do computation with that. And so if you can instead have a sort of MPC network where you can maintain your privacy, you can actually do more. Like, so you can actually do computation on all of your private state instead of just having zero-knowledge proofs in public state. And so you remember this picture from before, we had like one party secret sharing their data to nodes in a network. Now I think the interesting part with private shared state is when you sort of introduce other players or other entities. So now you can take like multiple people can share their data to a network in a privacy-preserving way, and the network can do computation over that. And I think this is super nice because we don't have to start revealing things to anybody. We don't have to. We have like all full general-purpose computation, and not just kind of workarounds with zero-knowledge proofs. So for me, this is like the most exciting thing that is happening in the crypto world at the moment. So I think with that, like the privacy conversation is becoming super nicely nuanced. It's not like full, like privacy is not secrecy necessarily. It's like you're not like completely black boxed and tied off from everything and nobody can see my data and no one can touch it and I can't even use it and like you shouldn't learn anything about me. And it's not like fully open like everything on Ethereum. If I interact with the chain, like everything is public and everything is recorded forever. Now we're kind of finding this like somewhere in between this all or nothing approach. And for me, this is super nice because in my life, in my day-to-day life, I come here, I stand in front of you, I want to be seen at times, but I also at times don't want to be seen and I want to choose. Like I want to have the option to come and like see people and I want to share myself and my thoughts sometimes, but I also want the option to not. So having this sort of and I also want to sometimes avoid some people and talk to some other people and whatever. Like, so having this nuanced view is super nice. And so if you are sort of MPC inclined, but not necessarily a cryptographer, how can you start thinking about these? And I think one of the things that we're seeing is like, okay, you know, I get excited. I'm like, oh, look, it's like it's live. You can actually use it now. It's great. Everybody should do this. Like, and some people are like, wait, no, though, like, because I mean, like Amir, like he's talking about super serious things where people are like dying and whatever, and it's like, okay, yeah, maybe like my little MPC protocols are not for that case. And like the question then is like, okay, who are your adversaries and how much power do they have? And so like I said to you before that we are running these co-snarks on the network, which is established between us, Tatseo, PSE and Cursive. So in a sense, you're outsourcing your work to us and you're outsourcing your data to us. So in a sense, you trust us. You trust us not to collude because if we all come together, we can reconstruct your secrets. And so one question that you might ask if you're starting to think about these things is like, how many people need to actually collude? Is it like all of them? Is it just one of them? As long as one of them is honest, is it okay? And so there are different models and different trade-offs that you can make and different levels of efficiency and things like that. So another one is then, yeah, like different notions of security. So like, okay, if somebody can tamper with your system, how much can they do? And so I think the most common model is normal. So maybe there's some information leakage. Maybe you like learn some stuff by observing the network, but they still follow the protocol. And then there's kind of the worst case situation where you kind of try to protect against malicious security. And protecting against this means that, or like adversaries that can break security in this sense means that they can control and manipulate and arbitrarily inject messages, like they can just completely destroy your system. So like if you are running an election, let's say in an MPC, and you have a malicious, like if you have a malicious adversary, they could, you know, just change the results of your election. Like, you know, you have nothing. So if you want to protect in this kind of situation, it's super hard, and you're not going to have much efficiency. That's for sure. So yeah, what about efficiency? I think I mentioned a few things, the WorldCoin example, the Cursive example. I think these are two nice examples of things that are running in production, which I think are the kinds of things I would hope the sort of cypherpunk people would care about more than the theoretical people who care about the math. And so in saying that, the difference between specialized protocols and like general purpose computation is quite different. So like you can do like highly optimized stuff as in the case of WorldCoin, and they are doing uniqueness checks. You do about 40 billion checks per second. And okay, that translates to, okay, you have 2 eyes and you know, you have many readings and your iris is pretty like data rich. Yeah, it's data rich, so it's a lot. And this translates to, I think, about 15 people uniqueness checks per second. And so these cursive co-snarks that we're generating downstairs, not downstairs, but in the network, are about 12 seconds each, but 11.9, like the vast majority of that is the witness extension. So this is like the actual MPC part rather than just the proof generation part. So proof generation is very fast, but witness extension is not too bad. So this is where it's at now. And so that's it for me. If you have any questions, I will be glad to take them. Thanks very much.
Thanks so much for your presentation, Ash. We've got a couple of questions here on the docket. But before we ask those questions, I meant to actually mention one fun fact about Ash here is that she actually was an MC just yesterday, so she knows how it feels.
I know how you're feeling right now. After like 5 hours, I was like, I don't remember anyone's name. I don't know what even this topic, where are we?
This was a great one, though, even though it was technical. But the first question here is, when Co-Noir?
Co-Noir is now there. Like now you can use it. So yeah, if you go to the Tatseo GitHub, you can go and find Co-Noir and play with that.
Awesome. And then what's the difference between ZK with MPC versus FHE computation?
Well, I resisted saying things about FHE. So FHE is great and like is a super ultimate goal for privacy because even if like there is collusion in the network, stuff is still encrypted and you cannot like it's like a better level of privacy, but it's hyper inefficient. Well, like it's super inefficient. So I think we saw at ZK Summit recently, if you wanted to generate zero-knowledge proofs in an FHE environment, it was like order of minutes rather than, you know, tens per second. So wow. It's just slow. And I think FHE is often considered a specific example of MPC. MPC is super general, so everything can be cast essentially as MPC. But yeah, FHE is just slower.
Thanks. And the next question is about MPC wallets. Is it the future, and what are your thoughts on MPC wallets generally?
I also didn't mention MPC wallets, and I was going to make a comment about that. So for me, when I mean MPC, I mean like general purpose MPC, like general purpose computation. For me, MPC wallets are kind of threshold signatures and things like this. So it's a little bit of a special case and like a kind of a sub computation. It's just one type. It's just generating signatures essentially. So it's kind of a small part of MPC. Super efficient. I quite like them. Personally, we don't work on any of that stuff, but I like it. Yeah, they're cool.
Cool. And there are a couple of questions that are more about your opinion on things. But first one is, how do co-snarks work?
How do co-snarks
Very
work?
briefly, in like 20 seconds.
If you know how ZK works, you take the ZK and you split it over 3 people. Like essentially, what is needed to compute a zero-knowledge proof is essentially linear, so you just do it 3 times and you communicate and you get 1 proof, in a nutshell.
Okay. And what do you think of TEE, or T? And what is T?
Did this question come from someone who knows me or someone who doesn't know me? That makes all the difference. So TEE is a trusted execution environment, and it's like a super hot topic at the moment. I think they're wonderful, and no. So the thing is with TEs, they're great, and it's a super hot topic at the moment. They're quite easily breakable, so I have sometimes been critical of them in the past, which is why sometimes I'm wondering if this is someone who knows me. But I think it's good. Like, so with the co-snarks, we talked about the collusion problem, and you know, I said that in this network, let's say that we are running now, you trust the 3 of us not to collude. And so TEs are one defense against this. If you sort of run the MPC in a TE across, you know, the nodes in the network, it's one nice defense. And also, like, as I said, TEs can sometimes be a bit weak. If you use 3 of them from different providers and like spread them around the world, it's also a lot better. So ultimately, I think, yeah, we're going to see that happening very soon.
Cool, thank you. And I think we have time for one last question. How does the MPC network receive private data? Is it in the encrypted format for snark generation?
Yes. Simple. I mean, it's encrypted like across the internet, but overall, like before that even, from your phone, it's sent it's split into secret shares, which is seen as, can be cast as a form of encryption. So essentially you encrypt it on your phone or your local device, and then you send it to the servers.
Cool. Okay, I think we got time for one more. Can we remove initial trust set of MPC?
What's the initial trust set, I wonder? So like if you talk about like the collusion issue.
Yeah, I think that's what they're implying, is the collusion.
Can you remove it? I mean,
actors.
not everybody's working on it, but like this is the big problem in MPC at the moment. Can you remove it? Never fully, I'd say. But yeah, we try. I mean, there are different options, like running things in TEs. You can start thinking about economic incentives for people not to collude. But yeah, this is a problem.
Cool. Well, thank you so much, Ash. And
thank you. You're a better MC than me. You did a very good job.
Thanks.
Thank you.
But you can find Ash outside. Ask her any other questions. Hey guys, we are back, no longer with 30-minute talks. Finally now we have a nice short lightning talk that Sasha, who's a researcher here, who's going to be giving all about the philosophy of Ethereum, which I'm pretty excited about. So welcome to the stage, Sasha, whose fun fact by the day, today is that she likes unicorns.
Thank you. Well, hello everyone. I'm Sasha, and I'm here to talk about Ethereum not just as a technology, but as a philosophy. During these few minutes, we'll journey through the history of thought, exploring how ancient and modern ideas align with what Ethereum brings to our world today. But before we dive in, a quick disclaimer: as philosophical concepts I'll touch upon have been simplified, and the majority of philosophers will discuss never foresaw blockchain, and linking their insights to Ethereum is quite an interpretive intellectual exercise. Well, we're all aware of how Ethereum is transforming our economy, society, and governance, but its impact goes even deeper, as Ethereum also challenges us to think about core philosophical dimensions, from the nature of reality and truth to ethics and art. Ethereum core extends beyond decentralization, programmability, and automation. It embraces resilience, open collaboration. It values inclusivity and sovereignty. Rooted in a vision of social economic freedom, Ethereum aspires to create a borderless network where innovation thrives and hierarchies dissolve. These fundamental principles resonate deeply with timeless ideas explored by philosophers across the history. Thus, philosophical concepts like decentralization and consensus appeared in Greek city-state or polis. Plato envisions them in his works. Also, trustlessness or parrhesia was another core idea, as well as privacy, with Aristotle's distinction between public, polis, and private oikos spheres. Furthermore, blockchain's immutability mirrors determinism and the medieval pursuit of eternal truth, and decentralization feudal hierarchies. The Renaissance introduces the concept of security, an idea that became central to Ethereum's framework. And, for example, Giordano Bruno's idea about universe as a living organism may match the Ethereum's infinite garden metaphor. Early modern philosophy, spanning the Enlightenment and beyond, emphasizes reason, individual freedom, and skepticism toward traditional authority. Thinkers like Jean-Jacques Rousseau or John Locke championed personal liberty, autonomy, and property rights. Also, this era focuses on industrialization, finding its modern reflection in smart contracts. As we progress through history, anarchism, seen in DAOs and DeFi, celebrates community-driven intermediary free systems. Proudhon's idea of industrial democracy and Kropotkin's mutual aid resonate here, as does libertarian socialism through DAOs that balance egalitarian P2P interactions with social justice initiatives like UBI. And pragmatist thinkers like John Dewey underscores cooperation and practical solutions, action-based outcomes. Contemporary philosophy brings fresh new perspectives. Thus, phenomenology, which emphasizes individual freedom, aligns with Ethereum focus on personalized interactions. Then, emphasizing freedom, choice, and responsibility, existentialism matches with Ethereum, which enables autonomous decisions and accountability. Analytic philosophy, in Wittgenstein's call for clarity, echoes in Ethereum's language for secure exchanges. And of course, postmodernism, which critiques fixed hierarchies, resonates with Ethereum ethos. Worth noting that today's thinkers bring diverse perspectives on blockchain. Some, like Zizek, critique it, while others acknowledge its transformative potential. Now I want to briefly talk about Ethereum's philosophical DNA, as I said. I believe, and I think many of us here believe, that Ethereum embodies a convergence of multiple philosophical movements which form its philosophical DNA. blending in many fascinating ways, starting from cyberpunk and cypherpunk, which sound similar but each hold unique vision of freedom and autonomy. While cyberpunk imagines rebellion against centralization, cypherpunk provides the cryptographic tools for privacy. Other influences are cyber-utopianism, which sees technology as a path to democracy. It views Ethereum as a tool for open, accessible systems that empower individuals worldwide. And crypto-anarchism, which emphasizes privacy and autonomy, resisting state control through cryptography. Then there is Ethereum also draws on techno-libertarianism and post-humanism. In essence, the first highlights Ethereum's role in personal autonomy, while the second envisions it as a transformative medium reshaping identity and community. Next are object-oriented ontology and defensive accelerationism. Object-oriented ontology is a part of a popular speculative realism movement. It views all entities, human and non-human, as equally significant. In this perspective, every block, smart contract, and code line on Ethereum has its own agency, acting within a flat network of relationships. And defensive accelerationism, as many of you know, supported by Vitalik Buterin, it calls for responsible tech progress, balancing innovation with ethical responsibility. Lastly, solarpunk and lunarpunk, they represent Ethereum's dual potential, a sustainable open future alongside robust privacy-focused protections. Also, to further frame Ethereum as philosophy, I want to shortly add several perspectives. In terms of metaphysics, Ethereum can be seen as a pluriverse, an ecosystem of diverse interconnected realities where multiple systems, cultures, and values coexist and interact. Then, epistemologically, Ethereum offers trustless knowledge, a paradigm where truth is verified collectively. Then, in terms of ethics, Ethereum introduces technoethics. In terms of teleology, one of the goals of Ethereum is a tool for digital liberation. Mainly, Ethereum isn't just a technology, it's a living philosophy, an experiment in rethinking trust and freedom. It invites us to ask what happens when the code carries our values and when autonomy, privacy, and decentralization become foundational. Together, we're shaping a new philosophical paradigm. Thank you.
And we'll start in 2 minutes. Thank you so much, Sasha. That was great. I don't think we have time for Q&A, so thank you so much. We've got about 2 minutes until our next speaker starts talking about building privacy protocols on Ethereum. So we'll come back in 2 minutes. excited to announce the next presentation is going to be all about smart contract privacy with Paul Brody here. And fun fact about Paul Brody, first off, he's with EY and also with the Enterprise Ethereum Association. And he's very, very passionate, surprisingly enough, about public blockchains and has no relation to the next speaker. So here he is.
Hello, everybody. So if you follow me on Twitter, you know I promised a joyful and uplifting presentation. I lied. This is going to be pretty pragmatic and realistic. I'm going to tell you about how to use Ethereum and specifically smart contracts to do something useful and interesting with privacy. So a couple key topics for today. Number one, let's press the magic button. We're having technical difficulties. So first item I want to talk about is the business case for privacy. And as soon as the clicker works, we will advance to the next slide, which it's not doing. It's not doing that. So anyway, I'm going to talk from a little bit of memory. So pretty much every business agreement comes down to something very simple. I've got money, you've got stuff, and I would like to exchange my money for your stuff under the terms of a business agreement. And the challenge with that is that for companies, they want that information to be private. How much money you have, how much stuff you have, what you're buying, where it's going, that's all like super secret, sensitive business information. Oh, it's working now. So business case for privacy. As I said, companies want to do very simple stuff, exchange money for stuff under the terms of an agreement with privacy. And blockchain is actually this incredible piece of infrastructure for doing this way more efficiently. So we can tokenize the money, we can tokenize the stuff, and we can turn all the business terms and conditions into a programmable set of rules that can be implemented very easily. To make this work, however, we need two kinds of privacy. Number one, we need privacy about the transfer of assets and payments, right? How much I'm paying you, what you're giving me, where it's going. That stuff needs to be private. But secondly, we also need privacy for the terms and conditions of our agreement. Like, it's really important, if I can read the agreement between company A and company B and it says, I'm going to buy 500 widgets at $10 a piece, I mean, I kind of gave away all the information that you need to know anyway. So we need these two kinds of privacy, and in particular, pseudo-privacy or mixers or things like that aren't really good enough for businesses, because if a lot of companies do lots and lots of recurring business with each other, and eventually, if you do enough of these types of transactions, you're going to be traceable even in a public mixer environment. And most business assets are not fungible tokens. Money might be fungible, but the things that you're buying are often not fungible. And anything that's non-fungible becomes instantly traceable in a public environment. So it's really hard to design without leaking information. And that's some of the stuff that we've really been working on. Now, before I talk to you about how, I just want to take a second and talk about, like, what is the value proposition, like why is this worth doing? And I want to share with you a very specific example, which is around the use of smart contracts for business automation. About 5 years ago, EY and Microsoft worked together to replace the procurement system for the Xbox video game network with a set of smart contracts. And the idea here was to replace an existing system which had a traditional ERP system, and it was sort of semi-automated. At the end of each month, they would look at all the transactions and they would manually apply some of the rules that they had implemented between Microsoft and their 3,000 odd gaming suppliers. Well, it took, on average, in the old system, about 45 days to calculate how much they were owed and go through all the individual contracts and special rules. When we turn those into blockchain-based smart contracts, the beauty of these kind of smart contracts is they're basically scripts, right? It doesn't matter. As long as the rules that you and I have agreed upon are logical and clear, then I can automate them and they can run properly. And the result was that we basically took a process that used to take 45 days and we brought it down to about 5 minutes. Right? That is a good improvement, and we did it for about half the cost of the existing system. So the value proposition of being able to take a complex business agreement and turn it into an automated smart contract is incredibly large. The problem that we had at the time was we didn't know how to do this under privacy on a public blockchain, right? Eventually, where we want to go to is this ability to put together tokenization with smart contracts and in a way that you can create a complete business model that's running on chain. In this picture, what we have is a very typical supply chain, right? Raw materials, they get manufactured, they get transported, they get put in a warehouse, they get sold to a customer, and then they get supported. Now, every single item in a traditional manufacturing supply chain we can represent as a token. Some of the things are fungible tokens. Most of them are non-fungible tokens. Anything with a serial number becomes a non-fungible token, right? And so basically in this picture, stuff moves from left to right and money moves from right to left, and a set of smart contracts governs this movement of the process away. And not only can we run the business process for about half the cost, but we can also run the supply chain much more efficiently. We think we can typically, if we move from traditional supply chain models to a tokenized supply chain model with all the rules of preventing double spend, you can actually cut maybe as much as 20% of the inventory from your supply chain and have the same service level. So in short, this is worth crazy amounts of money. Now, let's talk about a specific use case that we are implementing for clients and rolling out worldwide, and this is renewable energy. And I want to talk about why renewable energy is such an incredible use case and application and how we got there. I want to start with the roadmap for privacy that we are working on at EY. We've got two applications that we're building. I talked about two types of privacy that we want to do. One is privacy of moving stuff around, and the other is privacy of the terms and conditions of a business agreement. So for the privacy of tokenization and moving things around, we have created a layer 2 ZK rollup called Nightfall. Nightfall allows you to move around fungible and non-fungible tokens. It's an EVM-compatible layer 2, so it actually can run on top of the mainnet. It can also run on top of, say, a layer 2 as a layer 3. So Nightfall is for moving stuff around. Starlight is a transpiler that basically takes a Solidity smart contract and turns it into a set of zero-knowledge circuit. Our idea, our concept, is to get each one of these pieces working independently and then bring them together so that you can have this full business-to-business kind of complex roadmap. Both of these, to be clear, are, although they are largely developed by EY, we have put them into the public domain. They are public domain, open source contributions to the Ethereum ecosystem. There are no proprietary gotchas here. There are no surprise, like, special terms and conditions in the open source license. It is full public domain. We have relinquished all ownership to these assets. Thank you, sir. That is how much we love and believe in the Ethereum ecosystem. And we have been on this journey for a while, by the way. I know we're getting a lot of attention from the Noir program that's launched this week. I'd tell you that we started at about the same time as the folks at Aztec, and we are across, most of our team is across town from them in London. And one of the things that delights me so much is to come to Devcon and see how much competition is now in the privacy space. Like, I really believe that even if we lose the competitive race with some of the other solutions, we win. But I'm not yet given up on losing. We have been on this journey for a while, even though the numbers didn't sort of look out correctly. We started in 2017. And here we are in 2024. We're on Nightfall version 4. Nightfall version 3, which is currently in production, is a ZK optimistic rollup. ZK for privacy, optimism for finality. Nightfall version 4, which we showed off earlier this year and will be in production next year, is a ZK rollup. So one ZK for privacy and one for instant finality. All right, let's talk about renewable energy and exactly how we implemented this. So the way that renewable energy contracts work, and the reason why they're such a good candidate for zero-knowledge applications, is that they are kind of complicated. And this is a simplified version. Very simply, you got a power buy. You got somebody, they got a factory, they want electricity, they want a lot of electricity, they're going to buy it from somebody. But maybe they're a large company, they have a good social responsibility plan, they have committed to become carbon neutral. So what power buyers do is they reach an agreement with a renewable energy seller, somebody who's got solar facilities, battery facilities, whatever it is that's renewable and fully green. Here's the problem. Electrons are fungible, right? You might want to have your locally produced organic artisanal electrons, but actually the way it works is you have to take what the power company is giving you. And so what happens is the power buyer basically buys electricity from the power company at whatever the market price is in their environment. The power company in turn buys power from a whole bunch of suppliers. Some of them are very green, some of them are not so green. The agreement exists between the renewable seller and the renewable buyer. And what the smart contract does is it basically keeps track of the market price that the power buyer paid to the electric company and the difference between that and the agreed upon price, and then they settle up usually every month or so if one party owes the other. And there's usually complex terms and conditions, like a commitment to buy a certain minimum amount of power in the grid or a certain maximum price that they have to pay. And the idea is that they are basically providing the incentive and enough financial value to the renewable provider to structure long-term investment. And these renewable energy contracts are incredibly important because a lot of these solar facilities, wind facilities, they could not be built without the advanced commitment of buyers like these kinds of factories or other companies that are committed to be carbon neutral. These advanced commitments that they make, they're often 5 or 10 years at a certain price for a certain number of megawatts. These are incredibly important to guaranteeing the revenue that provides the investment funding to build these kinds of facilities. Right, so that's what the structure is. So a little bit like, video game contracts with thresholds and minimums and rebates, renewable energy contracts can be quite complex. To build this renewable energy contract, we went through a multi-step process, which I want to explain. We started by just creating a Solidity smart contract without privacy that followed the terms and conditions that we wanted to implement. And once we had that working, we created a modified Solidity application, which we call a Zolidity application. And all we did was mark up the variables and the logic that we want to be private. So we have a little guide on how to do this. And then we put that into the Starlight transpiler. And what that does is it spits out a zero-knowledge circuit, a whole application that you can run on chain, which we call a ZAP, right, for a zero-knowledge app. And please don't ask me who is in charge of our naming, but there's a lot of Z's in there. And so the idea here is to keep it very simple. And Starlight itself came out of a really important learning experience we had. So about 3 or 4 years ago, we tried to teach our research team, our PhD mathematicians, tried to sit down and teach our developers how to write zero-knowledge circuits using tools like Socrates. It was a spectacular train wreck. It just did not work at all. Our Solidity developers were like, this is too difficult, I don't like this, I don't want to do this. And so we went back to the drawing board and we said, we need to find a way to make this much easier and much simpler, and you just should have to do some minor changes to a Solidity smart contract. And that's how we ended up with Starlight. So Starlight is really designed to be as easy as possible. It allows you to take a Solidity application that you know already works and turn it into a zero-knowledge application. You still have to think very carefully about how to design it in such a way that you're not going to leak really sensitive metadata, because if you're not careful, you will accidentally end up leaking metadata. But the goal is to get to the point where anybody can do applications. As I said, it's public domain and open source, so you can go and try it out yourself. There are currently about 100 companies worldwide that are designing and testing applications using Starlight. And in particular, we've been working very closely with the Central Bank of Brazil. We have about 60 or 70 banks in Brazil that are testing out Starlight-based applications. And for the last year, we've been working really hard to refine the Starlight application development process and tooling. Right now, where we are is that we are in a kind of a stateless environment. So the Starlight application receives data, it calculates the amounts owed, but it does not store anything on chain, it doesn't store any commitments even off chain, it's a stateless component, and transactions are relatively inexpensive, provided you deploy them on a layer 2 network. The future path is that we want to integrate Starlight with on-chain payment and with some level of off-chain stateful storage of things like the amount of electricity consumed and the amount of money paid, so that you really have a proper continuous record of the entire set of business transactions. But that's a goal. As I said, we're following a kind of crawl, walk, run strategy, and the goal is to start and build things that are very, very pragmatic and useful to business users, rather than try to like bite off the whole thing at once. So we have fundamentally a bit of a different approach than, say, Aztec or some of the others who are, I think, have a very ambitious and kind of complete approach. We welcome participation. Our content, it's public domain, it's open source. All of our tools are open and available, and we publish them on the EY blockchain site on GitHub. So that's really important to us. We have many, many contributors, but underpinning all of this is kind of a long-term commitment from EY to invest in privacy, because we believe it is the one thing that enterprises need in order to get fully engaged with on-chain business and to give up this fixation that a lot of people have with private blockchains. Lastly, we are here. We have an impact booth. Our research team is here, and quite a few members of our engineering team as well. We would love to talk to you about how to help you make privacy-enabled applications that are regulatory compliant, right? They will not end you up in jail. I feel like, I myself would not do very well in prison, so I don't want to go there. And then lastly, I'm ready to take a couple questions, but I also want to share with you my little QR code. It will take you to a website that will give you what we call a proof of Paul NFT, which is minted on the Polygon proof of stake blockchain, and we made a special one just for Devcon. So, am I on time? Have we got enough time for a couple minutes of questions?
Yeah, we've got some time. We've got about 6-7 minutes.
Perfect.
So we've actually got a lot of questions, but feel free to ask some more on here. So it looks like the top question here is, why did you build Nightfall rather than contribute to other open source ZK rollups?
Well, at the time that we got started, there weren't any other open source ZK rollups. I mean, this was 7 years ago. And by the way, almost all the ZK rollups that are out there are ZK for scaling, not ZK for privacy. And in fact, one of my frustrations was, 7, 8 years ago when we got started down this path, everyone's like, hey, we got to fix the scaling problem for Ethereum. And while I agree with that, and I'm really pleased with the progress that Ethereum has made on scaling, I think it's incredible. At the end of the day, for business users, there's no scaling. The scaling problem is not a problem until you solve the privacy problem. Without privacy, no business user is going to touch Ethereum. And I want every business agreement in the future to be on Ethereum.
Awesome. Well, how do you tokenize real-world assets without them being centralized?
That's a great question. So I think, let's see here. I guess the quick answer is, I think for individual companies, those assets are going to be, if you're tokenizing your own asset, it is going to be to a certain degree centralized in your company. And this is kind of an issue that we've talked a lot with other people, is in certain circumstances, there are some things where only one participant really knows the status of that asset. The only company that knows where your UPS or FedEx package is UPS or FedEx, right? And so you have to accept that. And one thing that is a really cool thing is there's a process, a well-accepted business process from the world of TradFi. It's called a SOC audit, right, which is a systems and organizations control. And what it is you have an independent organization come in and assess your reporting mechanism. And so in the cases where you can't have proper decentralization, you should have external auditing and testing to make it more reliable.
And I think we have time for one more question. Can you talk about the Brazilian CBDC and how the experience is of using Starlight on Drex? And for my sake, can you explain what Drex is?
Yes. So Brazil has they've had some really cool thoughts about their CBDC. So as many of you may know, CBDCs are really struggling with acceptance and success because they don't offer a lot of value. The Brazilian central bank has taken note of that, and they've really thought a couple of steps ahead, and they've said, you know what, if we want our CBDC to be successful, we really should consider making it programmable and in an EVM environment, which I think is fantastic. Now, I have urged them to go one step further and just plug their whole CBDC into public Ethereum. I'm not sure they're ready for that yet, but what is exciting about this is that in this environment, Brazil has clear banking secrecy laws, and so if I want to trade with you, if I want to do a transaction with you, the Brazilian government doesn't just say privacy is nice. The Brazilian government says you must respect the privacy of your users, you must build privacy-enabled applications, and so they have been testing a number of different privacy solutions. What I think is really exciting about Starlight compared to some of the other ones is that it is our whole goal in building Starlight and Nightfall is to be 100% compatible with an EVM environment where you use native Ethereum tokens like ERC20s and 721s. You preserve all of the true native Ethereum functionality around like the prevention of double spend, the proper management of assets. Our goal is not to create something new, it's to make these things fully compatible and transparent in a very straightforward way. So we want to make it simple, and I think that's a big part of the value proposition. We'll see how Drex evolves, right? But I think this idea of like fully programmable, privacy respecting kind of CBDC EVM is quite exciting.
Thank you, and I actually lied. You have about 3 minutes left for this Q&A. So
fantastic.
It looks like we've got a couple other questions. What made you choose ZK over Oasis Sapphire or the Secret Network? I assume that's because you guys started back in 2017.
It's partly because we started back in 2017, but it's also because, again, we want true, full native privacy. And one of the things that's also really important to us is that we don't want any kind of off-chain systems that are required. We don't want any special security like hardware security modules or proprietary tools. Our goal is to have a fully open source Ethereum native privacy application with no kind of built-in tax or license or system. So that was our goal, is to be completely open.
And another question, it's more applicable, but like, I'm curious, all the smart contracts that you've developed for Nightfall and Starlight, are they compatible with just any smart contract and being converted into ZK circuits, or are there any changes required to satisfy those constraints?
So there are some changes, and basically the Starlight kind of user guide explains how to make those changes. You really do have to be careful. If you design, what you end up with is like a black box. And so if you're not careful, if I have a black box and I have only 2 parties in it, and I put in $10 and you put in 2 widgets, doesn't matter how fancy the logic is in there, from an external point of view, you know that your contract is basically saying the pricing is $5 a widget, right? You've leaked all the meaningful information. So you have to really carefully design your application so that it is optimal for preserving privacy. Before I've got 1 minute left, I want to talk about this one around privacy for governments and how regulators view this kind of thing. And I want to share with you kind of the one really, really important insight that we have learned in terms of working effectively with regulators. It's really important to help them understand privacy and anonymity are not the same thing. So when we design Nightfall, which is our privacy layer 2, in order to use it, you need to have an enterprise identity certificate. This doesn't mean that your transactions are visible and there are no backdoors in the system, but externally, governments and regulators can see who is transacting. They cannot see what you're doing. They cannot see with whom you are transacting, but they can see that you are transacting. These enterprise ID certificates, X.509s, can only be issued to companies that can pass basic backgrounds and sanctions checks as well. So I would not call it, by the way, KYC, but it is identity. It is a legally accepted form of business identity in many countries, including the United States. And if a regulator comes to you, you can tell them what you're doing, and very importantly, you can also prove to them that what you're sharing with them is truthful. So, I think we're done.
Awesome. Thank you so much. Great presentation. Guys, it is now the last session of today's Devcon Talks. Congratulations, you've made it this far. We now are going to have lovely Anne Brody come up here and talk to us about Infinite Gardens. And before Anne comes up, I want to mention one fun fact about her. She used to be a drummer in a band before doing this. So here's Anne.
Hello. I know it's late, and I thank you for being here. Your presence signifies your support for the social sciences, and I appreciate it. So thank you. It's such an honor to have the opportunity to return to another DevCon and get to present the research findings that Dr. Paul Dillon Ennis and I have been working on in the past year from our latest paper, which we've titled Tending the Infinite Garden, Organizational Culture in the Ethereum Ecosystem. Now, unfortunately, Paul, who maybe some of you know him as Polarpunk from CryptoX, he couldn't be here today. He's off fulfilling his Nobel professor duties, but for anyone who actually knows Polarpunk, I suspect that the real reason is he's probably too busy playing Helldiver. And I have on-chain proof. Look at that tweet. I mean, if you've seen his dedication to that game, you know it's like practically a second job for him. So you're stuck here with me, and we're going to talk about the sexiest subject in crypto, and we all know what that is, right? It's governance. Governance is sexy, come on. Okay, okay, so I'm not a governance guru, and I don't claim to be able to provide you with the answers to the most compelling governance questions in Ethereum, but what this talk is intended for is to provide you with a perspective for thinking about governance in the context of Ethereum. Now, before delving into our publication, let me briefly introduce who we are. We belong to a rare breed. We are the social scientists that have chosen to grapple with the intricacies of the social layer of this weird and wonderful ecosystem. And we both published one of the earliest academic papers on the culture of Ethereum, and then we decided to join forces, and this is the result, and you're going to get to hear about it. Now, Dr. Paul Dillon Ennis is a professor at University College Dublin in Ireland. His research focuses on Ethereum culture, with an emphasis on the social layer. He is the author of Absolute Essentials of Ethereum. I highly recommend buying the book. I myself am a doctoral candidate at McGill University in Montreal, Canada. My background is in anthropology, science and technology studies, and communication studies. And my research interests are based on the culture of open source movements, hackers, hacktivism, DAOs, governance, and crypto ideologies. Okay, so to begin, I will give you a brief synopsis on what the paper is about and present the core argument before actually getting into the rest of the content. So we focus on the role that culture plays in shaping Ethereum's governance by exploring what we refer to as social imaginaries of Ethereum's core developers. Now, I'll explain what social imaginaries are in a moment, but in essence, we argue that in the absence of centralized hierarchy, such as with the case of Ethereum, these social imaginaries step in to define the boundaries of legitimacy in decision-making within Ethereum's protocol governance. Okay, so social imaginaries, what are they? Social imaginaries is this theoretical framework that STS, science and technology scholars, like to use. Now, without getting too philosophical here, as much as I love philosophy, there is an element of studying subjectivity and people's relationship to technology. But to put it more simply, it's really just trying to understand the collectively held beliefs, norms, and attitudes about a technology, deriving its theoretical understanding from thinkers like Charles Taylor and Jasanoff and Kim. So the way Charles Taylor describes it is, quote, the ways people imagine their social existence, how they fit together with others, how things go on between them and their fellows, whereas Jasanoff and Kim, they extend on this definition to encompass more publicly formed visions of desirable technological futures. Now, why should we even study social imaginaries? Well, studying social imaginaries is crucial, I think, because it allows us to uncover the dominant ideologies, unquestioned assumptions that shape our understanding of technology. So, for instance, there is a widespread belief that technology is inherently neutral, or that economic efficiency should always be prioritized during the design process. So studying social imaginaries equips us to envision alternative technological futures and pathways, and it empowers us to rethink existing directions and avoid perpetuating hegemonic structures or political agendas embedded in technological choices. And in this way, we can build more robust tools that serve the needs of various groups of people. Now, as I mentioned, blockchain scholars really love studying social imaginaries, and there's already been some studies done on blockchain community. So Lana Schwartz helped popularize the use of social imaginaries in the context of blockchain communities. So according to Schwartz, who first started studying Bitcoin, she argued that Bitcoin represents an effort to collaboratively build a monetary system that she refers to as infrastructural mutualism, and that is an imaginary end in itself. And this concept blends the ideals of open source collaboration with cyberpunk culture, which strongly emphasizes online autonomy and privacy. However, Schwartz also points out to another more individual aspect of Bitcoin culture, which is what she calls digital metalism. And this reflects the libertarian values that are held by many Bitcoiners. Now, there is also the world computer imaginary, as proposed by yours truly. Of course, I did not coin the term. It's from Gavin Woods, and the world computer imaginary is what distinguishes it from Bitcoin and is therefore quite central to how Ethereums view themselves. So instead of a money system like its predecessors, Bitcoin, Ethereum is basically read by its community as a neutral platform, a shared world computer that people can build dApps on and experiment in these more expressive and creative ways. There's also the hacker engineer imaginary by Jaya Clara Breaky, and that one has more of an emphasis on the hacker culture that embeds the construction of artifacts. So yes, blockchain does have a neoliberal bent to it, but then this imaginary reminds us that in fact there is also a hacker tradition that is part of a broader historical lineage, which often gets forgotten, but is very much relevant to how these systems are conceived and how they get constructed. And the productive money imaginary is basically when in Bitcoin you have the sole focus of the currency is its existential focus, but in Ethereum it has more of a productive function, which is for staking or to pay for transaction fees. And then today we propose a new imaginary, which we refer to as the Infinite Garden, which refers to Ethereum's continuous evolution, alluding to an eventual endgame or state of ossification. Now I'm going to talk about the research approach and how we did it. So we interviewed key figures from Ethereum's core development group, and what is interesting about Ethereum core devs is that they're part of a porous group. Theoretically, anyone can become a core dev through consistent contributions, as there are no formal barriers. Our interviews weren't limited to developers. We also spoke with researchers and coordinators within the ecosystem, and here are some of the people that we interviewed, including Vitalik himself, Danny, Pooja, Tim, Alex, Ben, and Trent. So our interviews were semi-structured, meaning that we had a set of open-ended questions that allowed for deeper exploration of topics as they unfolded. We then analyzed the discourse using something we call grounded theory, a method where you start with raw data gathered from the field and then gradually build theoretical insights by identifying patterns and themes in the discourse. We began collecting data in February 2023, coinciding with the Ethereum all-core dev calls, particularly the time of the Chapella upgrade. Our focus was on the interpersonal dynamics within the core dev group, and we wanted to understand how decisions were being legitimized in this sort of decentralized environment. And through this process, we aimed to identify the cultural constructs that shape Ethereum's decision-making process. Now, I don't have time to fully dive into how Ethereum's governance works, but here's a quick overview of the key stakeholders involved. We have the core devs, the full nodes, the stakers, the media, the dApp builders, and the end users. Now, this structure forms what we call a polycentric governance system. Essentially, it means that multiple overlapping decision-making centers operate autonomously but interact with each other through cooperation, competition, and conflict resolution. No single entity holds control, and governance happens through coordination among these decentralized bodies. In Ethereum, this polycentric governance is distributed across these various stakeholder groups with no central authority, decision-making is spread out, and different actors must work together to manage governance and address conflict. And by the way, for a really stellar description on Ethereum's governance and all the details, I really recommend checking out the work of Kristen Kim. Okay, so now let's talk about the key themes that emerged in the discourse. So the first one was cypherpunk values. For anyone who doesn't know, the cypherpunk movement began in the 1980s, emerging from online hacker culture as a protest against the growing power of the state to monitor its citizens through digital networks. They are activists who advocate for the widespread use of strong cryptography as a route to non-violent direct action and political change. Some of the core values that define cypherpunks include decentralization, permissionless, censorship resistance, and credible neutrality. Our research showed that these values are very much alive within Ethereum's development culture. And here's a quote from Ben Eddington confirming this. He says, "We are for decentralization, we are against political capture, and we are for credible neutrality and making Ethereum robust against capture in all its aspects." Now, it's no surprise that Ethereum devs exhibit cypherpunk values, but what stood out in our findings is how many of the interviews perceive themselves as part of this broader lineage, which directly traces back to Bitcoin's cypherpunk-inspired ethos and this concept of infrastructural mutualism, which I mentioned earlier, which embodies open source collaboration and decentralization. And it resonates deeply with Ethereum's core developers today. Another key theme that emerged during our research was conflict resolution, specifically how core devs manage differing perspectives within their group and from the wider Ethereum community. Our interviews took place around the time of a major Ethereum upgrade known as Chapella, which went live on April 2023. And this upgrade allowed participants in Ethereum's staking mechanism to withdraw the ETH they had locked up during the transition from mining to staking, which was a huge milestone for the ecosystem. Now, many of the developers we spoke with emphasized the clarity of the decision-making process, reflecting Ethereum's collaborative governance approach, despite some setbacks, back-and-forth setbacks, on the technical design. The considerations were relatively straightforward. As Alex Stokes put it, the process was, quote, pretty streamlined, and Danny Ryan reinforced that decisions were largely based on rough consensus, which means complete agreement is not required, but a general alignment is ideal. And here we have a quote from Vitalik himself, stating sometimes there are disputes and people generally try to, you know, keep talking until some kind of a fairly reasonable solution can be decided on. I feel like it just almost always ends up resolved in some sort of way because it bubbles over, before it kind of bubbles over into some really serious, horrible conflict. Okay, so this kind of suggests that overall Ethereum's decision-making culture has stabilized over time. Also, Ben Eddington has highlighted how decisions are generally made through discussions where dissenting opinions are welcomed and heard. In cases of disagreement, the direction is determined by the overall sentiment of the all core devs meetings. This speaks to a strong pragmatic ethos that is committed to engineering excellence, but one that is also fundamentally anchored in a mutual trust among the core devs, as well as the wider confidence within the Ethereum ecosystem in their technical proficiency. It is within this context that the hacker-engineer imaginary is most vividly realized. This ethos not only prioritizes practical solutions, but also embodies a deep faith in the specialized expertise of those tasked with Ethereum's continual development. And so one of the key research questions we had was to understand the extent to which market pressures influence the decision-making process of core devs. And what we found was that after Ethereum's transition from staking to staking in September 2022, developers did not initially prioritize enabling withdrawals of staked ETH. However, other participants within Ethereum's polycentric ecosystem, notably stakers, media, and end users, felt that unlocking staked ETH should be the top priority. In response, the core devs adjusted their focus, deprioritizing other upgrades and shifting their effort to enable withdrawals through the Shapella upgrade because they wanted to deliver that promise. And Alex Stokes, for example, emphasized the imperative to, quote, fulfill that commitment to withdrawals, while Danny Ryan pointed to a sense of duty towards the early community members, noting that many stakers were individuals who had taken a leap of faith during the transition to staking. We found that this commitment to fulfilling promises to early contributors was a significant factor in prioritizing Shapella's upgrade. And also, here's another quote from Vitalik, basically reaffirming this, stating, I feel like there weren't really any social challenges for Shapella because this is one of those examples of something that's purely technical, which is just that people wanted to withdraw. It was promised that people are going to withdraw, and so the biggest challenge is just implementing the withdrawals. We specifically found Ben Eddington's remark important because he emphasized how developers have a degree of autonomy from market pressures and do not allow it to sway them from their core mission. So as Ben Eddington states, mercifully, we've been free of commercial pressures. Core devs are pretty resistant to being told what to do, and we will make our own minds up. We found that core devs appear resistant to immediate market pressures, but are flexible when it comes to protocol changeness that are driven by fair economic considerations. So in this case, community members who staked early have contributed to the protocol and therefore should be prioritized in the right context. But prioritizing a change just to boost the market price would be out of the question. In this case, it's clearly the productive money imaginary that appears, where ETH has an important functional role in Ethereum to pay transaction fees to reward stakers. But core devs do not see their mission as holding up an asset's price. Okay, so now the new imaginary. We sense the presence of an unspoken social imaginary guiding Ethereum's evolution, which we refer to as the infinite garden. Now, this term was coined by Aya Miyaguchi, who's the executive director of the Ethereum Foundation, and it perfectly captures the essence of Ethereum's ethos. In Aya's words, quote, Ethereum is a protocol for human coordination. Coordination is a game, but not one that is played to win. Coordination is more like tending a garden, where one works only so that the garden continues to thrive. And this analogy reflects a temporal dimension to the thinking of Ethereum's core devs, where social imaginaries provide a way of understanding our place in time and space, among others, and within history. So beginning in 2020, Ethereum's co-founder Vitalik Buterin introduced what is often referred to as the Ethereum roadmap. However, it's important to note that the roadmap is not an official or formal document everyone must follow. Rather, it collates various long-term research strands on Ethereum's protocol development. So it suggests that there is maintenance work to be done on Ethereum, but that these seeds are being planted for the long term, where eventually, the garden will thrive on its own and it will achieve a state of ossification. So that's how we basically present the imaginary of the infinite garden. So why do we think the social imaginary is important? We think it's important because while there are clear structures or processes and practices such as EIPs, all core dev calls, and research forums, we found this social imaginary significant because beyond EIP 1 and README text, Ethereum lacks a formal constitution or governance document. So these social imaginaries serve as the essential enabling conditions for Ethereum's governance to function seamlessly. In the absence of formal guidelines for off-chain governance, these imaginaries play a vital role in defining the boundaries of acceptable actions and behaviors. As a result, core devs lean heavily on these implicit imaginaries to ensure cohesion within the Ethereum community and to push its collective goals forward. They guide core developers by fostering a shared sense of foundational values, long-term alignment, and nuanced understanding of the ecosystem collective expectations. Without a formal hierarchy, these social imaginaries become crucial for maintaining legitimacy and keeping Ethereum's development on track. They might be the only mechanism, in fact, that core devs can truly rely on, since making unilateral decisions risks alienating other stakeholders. So this infinite garden imaginary suggests a dynamic, ever-evolving ecosystem where growth and transformation are ongoing, but a key challenge we discovered was for core devs in maintaining cypherpunk values as the ecosystem grows. As Ben Eddington put it, how do we incorporate the interests of these stakeholders into protocol development without compromising our cypherpunk ideals? I don't think it will be easy. Similarly, Alex Stokes reflected, you'll get less alignment as the community grows. These things have gotten bigger, and I expect they'll keep getting bigger in some form of fashion. As it happens, it's harder to maintain alignment. These concerns reflect an underlying anxiety. As Ethereum grows, the original cypherpunk ethos could become diluted. For the core devs, this signals success, but it also invites the possibility of new visions of Ethereum that may diverge from the foundational values they aimed to embed into the protocol. So the term cypherpunk is becoming endangered. Despite of this, its ethos burns brighter than ever. To remain relevant in a changing world, the cypherpunk ideology must evolve beyond its historical origins, embracing radical inclusivity that acknowledges the diverse ways that people contribute to its ideals. Cypherpunks are not only coders, but also researchers, educators, curators of digital spaces, community organizers, and writers. And there are organizations actively working to preserve this legacy through privacy education and advocacy. So Web3 Privacy Now is a leading think tank. They are creating invaluable educational resources, while Women in Web3 Privacy is championing privacy specifically tailored for women in the space. This is a crucial moment to safeguard Ethereum's future and preserve cypherpunk values. In a world where control and influence loom large, your privacy is the foundation of your freedom, the key to resisting coercion from dominant actors. Now more than ever, protecting your privacy is not just a choice, but a vital act of defiance that ensures your voice remains your own. And we invite you to get involved, support these efforts, and explore how you contribute to the future of privacy. Together, we can ensure that the principle of the cypherpunk ethos not only remains relevant, but also evolves alongside the infinite garden. Thank you so much for your attention. I appreciate you being here. I hope you got some value out of this talk. And this paper is currently in publication, but it will be public soon. If you want to continue the conversation, feel free to hit us up on CryptoX. We are pretty active, either myself or Paul. And thank you again. Enjoy the rest of your DEF CON.
Thank you so much, Anne. That was a fantastic presentation. I know you guys had a lot of questions in Meerkat, so you can find Anne afterwards and talk with her and ask any other questions. And thank you so much for sticking around. It is now the end of presentations, so hope you guys had a good day here watching lots of different talks, and hope to see you all tomorrow.